what is network devices? So network devices are like the devices which are used in networking. They are called network devices. Okay, so there is a first device what we are going to understand is endpoint. Okay, so what is endpoint? Any computer, okay, any computers, okay, so laptops, all these devices are called endpoints or okay. So even your printers are also endpoints. So endpoints क्या होते हैं? What is endpoints? So when you talk about computers, laptops, printers, they are endpoints. So then what are servers? Servers are powerful machines. Okay, what are servers? So servers are powerful machines than computers. So for example, we have in the market, we have Windows server, then we have a Linux server. Okay, and there are a lot of Linux available also. Okay, like Linux servers, Ubuntu server, and all. But these are the more important devices we have. Okay, so Windows server, Linux servers, and all. So now when it comes to router, so what is router? This is a completely network device. Okay. So endpoints and server, you can call them, these are normal IT devices. Okay. They are also part of network. But what is router? You can see a symbol over here, guys. There is an icon over here, which is floating right now. So I just randomly added a wrong animation, I think. Okay, so this is the icon of router. Okay, and you can see this is an example of internet. Okay, so internet is giving connectivity to the router, and then router provides connectivity to the LAN network. So, so now we understand what is computer. Okay, endpoint. Then we have servers. Then we have routers, which are actually used for like different connectivity. Like if you want to connect with the internet, you need a device router. Okay, then what is this switch? So this is this icon of a switch. Okay, so this is the icon of a switch where you connect the switches with the laptops, servers. Suppose if you want to connect multiple computers, okay, what you will do, you will put a cable in the switches. Okay, that's called switches. Then we have a next. So don't worry, I'm just giving you overview right now. We will deeply understand each and every device. Okay. So I'm just giving a overview. What is endpoint, servers, routers, switches, and what are next generation firewalls. So this is the icon of firewall. You can block websites. Okay, suppose you want to block uh, any website in your company, like you want to block facebook.com. Okay, you can easily block with the next generation firewall. Okay, so let me come with my. Okay, so when two or more computers are connected, okay, like this is computer A, you connect another computer B. Okay, so this is also a network. But when you need more computers, okay, so suppose you have four computers now, A, B, C, and D. So how you will connect all these four devices? Then we have a device called switch. Okay, so we have a switch where we add cables. Okay, with these computers. Okay, so this device is called switch. Okay, so what is network? Connect two or more different networks. Connect two or more computers. Two or more computers is known as network. Is known as network. Okay, guys. So there are different types of network today. Okay, like we have LAN, local area network. Okay, local area network. Okay, then we have a wide area network. Okay, don't go for the bookish language. Okay, man, metropolitan area network. We do not use that kind of languages in the real industry. Okay, so we'll talk about the, because you all are learning to join industry. So we'll focus on the industry concepts. Okay, not the bookish concepts. Because in book is also written man metropolitan area network, which is not a. So as a network engineer, you will never get to know or never you will discuss anything in your company about man. So you can take an example like Dish TV and all. They are example of metropolitan area network. Okay, so this is just a full form. Okay, so normally in the IT networking, we do not use these terms. Okay, normally the Dish TV type of connectivity is like you can say it's a metropolitan area network, like city to city. Okay, but normally we use LAN and WAN. LAN is for internal connectivity. Okay, internal connectivity, internal. And when we connect anything external, okay, like when you connect internet, that is like external connectivity. Okay, so in I we call this intranet. Okay, there is a different name, technical word also. The technical word is called intranet. Okay, what is that? So this type of network is also called intranet. Okay, intranet. Okay, which means internal connectivity. Okay, and so intranet is not just one LAN, it is like multiple LAN networks. Okay, multiple LAN networks are good example of intranet. Okay, so what is local area network? Suppose you have taken internet connection. Okay, this is like your favorite ISP. What is ISP? Who provide internet? Okay, internet service provider. So ISP is connected to a router. Okay, so this is your office or home router. Let's call this is your home router. Okay, this is your home router, and this home router is like maybe Wi-Fi, and your laptop is connected to this. Okay, so your brother mobile phone is also connected. Okay, your parents mobile is also connected, or tablet. Okay, so multiple devices are connected in your home. Okay, so this is called LAN. Okay, this is also a LAN. This is a good example of LAN network. So when it comes to intranet, okay, so multiple LAN networks. Then we have, so this type of connectivity is also called SOHO. Okay, what is this SOHO now? SOHO is small office, home office network. Okay, small office. So in Cisco books, when you read Cisco books, na, so it is mentioned SOHO network. So what is SOHO? Small office, home office network. Okay, that is also a small network that is called SOHO. Okay, so SOHO networks. So when the network is very small, like small office or home office, is called SOHO networks. Okay, but when we talk about company networks, they are called enterprise networks. Which networks? Enterprise networks. Okay, like good companies, like maybe if you talk about any company, like let's call Nestle. Okay, so Nestle maybe have a good network in their office. Okay, maybe like take more example of like what is this? Okay, like Sony. Okay, so these are product based companies. So when they have their company network, they are called enterprise because these companies are called enterprise companies. So we have SOHO networks, then we have enterprise networks, then we have service provider networks. Okay, service provider networks. So means the internal network of any big ISP like Airtel, okay, or maybe AT&T. Okay, so these companies have their own big network that is called service provider network. Any company network is called enterprise network, and small companies network are called SOHO networks. Okay, but there is a general term to it, LAN and WAN. Okay, so when company internal network is called LAN, and when they connected with another branch offices and all, that is called WAN. Okay, MAN is just a like bookish term. Okay, we never use, but there is a network called SAN, which is called storage area network, which can be used. Okay, like storage area network. Okay, like you can have the SAN servers. Okay, you can have big hard drives, and people can upload data on those storage area networks. Okay, like the company hard drive, you can say, okay, the virtual company hard drive, or you can put a lot of data in the storage area network. Okay, so what is network? Let's repeat. So when two or more computers are connected together is called a network. And there are different types of network like LAN, WAN, MAN, and SAN. Okay, local area network, wide area network, metropolitan area network. Okay, storage area network. And there is a Bluetooth type of network also, which is called PAN. Okay, not the PAN, the kitchen PAN, that's personal area network. Okay, so now you can see this example, guys. Then how we access. So internet is very important nowadays for a company, for a home network, for everyone. Internet is important. Then how we get internet? So there are different type of internet connectivity. Suppose you go to ISP and say that I want internet access. Okay, so what they will do? Okay, so what they will do? So they will provide you normal cable connection that is called cable wide area network. Okay. So when a big enterprise company, I told you Soho. Okay. So small office, home office, and then there is an enterprise company. Okay. So enterprise. So you can say this is the main office LAN network. Can you see that LAN? Okay. Suppose this is the Delhi office network. Delhi is capital of India. Those who are not from India, by the way. Okay. So Delhi office. And suppose this is another office. Maybe we have office in Mumbai. Okay. So how we connected Mumbai office with Delhi office? We can have fiber cable. You can see fiber WAN, fiber cable. And then in my branch office, I can also buy fiber connectivity. Okay. And then I can, over the internet, I can connect these locations together with some technology called VPN. Okay. Virtual private network. I can connect my Delhi office with Mumbai office over the internet, with the help of what? Because internet is not secure. So I need a secure solution. Okay, if I want to connect my head office of Delhi with Mumbai, I will use a technology called VPN. Okay, so what kind of connectivity we get? Cable connections, fiber connections, and there is a cable like ADSL WAN. What is this ADSL? So that is like a phone type of cable. Okay, like suppose if you get a normal landline phones. Okay, nowadays we do not get this, but normally the normal landline. Okay, the normal phones, telephone cables. From that cables you get a connectivity that is called ADSL. Okay, ADSL has a full form also, which is like asymmetric digital subscriber line. Okay, asymmetric digital subscriber line. Digital subscriber line. Okay, so normally you have seen this type of that the ISP has given you a modem. Okay, then a modem is then connected to, this is like old design. Nowadays all the ISPs are giving fiber cables. But like when, if you remember, if you take a connection from Airtel, BSNL in India, or maybe you can check your local ISP. So they give you normal telephone cable, and that cable is added to a modem device. Okay, why this modem device is used? Because the signals what you get on this cable is analog signal. Which signal? Analog. Okay, so okay, I hope you got the point. So let's start from very basic, that what is the first device which is called NIC card. Okay, so let's start one by one. So the first device I will cover is NIC card. Okay, so what is NIC card? So NIC card is a chip inside the computers which are called network interface card. Okay, so network interface card. So the network interface card has MAC address. Okay, so it means your computer do not have MAC address, the chip which is called NIC card has MAC address. Okay, so let me show you the NIC cards. Okay, so nowadays NIC cards are available inside the laptop, but like if you check about the older machines, okay, or older computers, okay, so they used to have this. Okay, so the first device is NIC card. So this is the example of NIC card. You can see you can add this this card inside a computer or a server. Okay, so this is a small chip inside your computer. Okay, so that you can add a cable. Okay, which type of cable you can add? I hope everybody knows Ethernet cable. Okay, which cable? You can add a crossover type of cable, or what we call copper cable. Okay, ये देखो ऐसा होता है. Okay, so I'm sure that all of you understand this. Okay, every computer, laptop nowadays have this port which is called Ethernet port or Giga port. Okay, so these are called Ethernet ports. Okay, so the port name is Ethernet port. Okay, but the card, the whole full chip name is called NIC card. Okay, and what is NIC card? So NIC card is like a chip which is used in computers to connect the computers with the internet. Okay, so a network interface card is a hardware chip. Okay, so what is NIC card? Okay, so a network interface card is a hardware component without which a computer cannot be connected over a network. Okay, so now this is called wired Ethernet port. Which port? Wired. मतलब यहाँ पे केबल लगेगा. Okay, this is a wired Ethernet port, and there are in laptops nowadays you have wireless NIC cards also. Okay, so wireless NIC cards are also chips which are inside your computers, but they are wirelessly. You can connect those devices. Okay, so maybe a chip like wireless chip. Let me show you. Okay, so you can add wireless NIC cards also. Wireless NIC card, so which are like this. Okay, so you can have wireless chips. Suppose you assemble a computer. Okay, suppose you create your gaming computer. Okay, you need a Wi-Fi, so then you need to buy these NIC cards. Okay, so it means nowadays all computers have wireless, all computers have wired Ethernet port, and also nowadays every computer has Bluetooth also. Okay, so Bluetooth is also a NIC card. Okay, so Bluetooth chip is also a NIC card. So I'm giving you more examples here so that you understand in a very easy way. Okay, so हमारे यहाँ पे Bluetooth NIC card is also available in the market. Okay, so these three chips, okay, whether it is a Bluetooth chip, you can see here. Okay, so this is a wireless Bluetooth chip, maybe. Yeah, because I googled it. Yeah, so it looks like a Bluetooth chip because these are inside the hardware. Okay, so these are Bluetooth adapter because I just checked on Amazon. So you can see we can buy this separately if you want to add this chip inside your computers and provide Bluetooth. But nowadays, all these things are not required, guys, because nowadays if you buy any motherboard, okay, I'm sure you know motherboard kya hota hai. So the motherboard already have Wi-Fi. Okay, you do not have to buy a motherboard with a different Wi-Fi because nowadays all the motherboard chips, you can see this is a MSI B51 something, and already it is written it is a Wi-Fi supported. Means you do not have to add extra uh, what we call port. You can see here we have a USB port, and you can see on here also we have the Ethernet port. Can you see there? Okay, and there is a Wi-Fi port also. So you can see here it is already written over here that this has the LAN port. You can see LAN, okay, where you can add a cable, and this is a wireless Wi-Fi antenna connectors. Okay, so it means nowadays all computers, laptops, You do not have to add this NIC card, but you need to understand what is NIC. Okay, so NIC is a small chip with inside our computer, which will help us to connect over the internet. And remember, computer do not have MAC address. The NIC card has. Okay, it means when you say that my computer MAC address, that is not your computer MAC address. That is your NIC card chip address. Okay, and do one thing, go to command prompt. Okay, and run this command. Okay, which is like, go to command prompt and type this command, get MAC. Okay, so use this command in Windows. You will see all your Wi-Fi, Bluetooth, and wireless. Okay, so just type this command inside command prompt. Computer serial number is a different, it's just a model number. Okay, that how many serial number se kuch nahi hota. Serial number is just a product key. Okay, it is not a part of network. So if a card has both Wi-Fi, so just now Anoop has shared his computer because I'm not using Windows. Okay, so maybe, yeah, so you can see, uh, so this is Anoop computer. So he has given this command inside the command prompt and he got to know, okay, so there are two MAC address. This is called MAC address. Okay, so when you see this hexadecimal numbers, okay, number with some digits, alphabets, so these are called MAC addresses. तो ये क्या होते हैं, हमारे MAC address होते हैं. Okay, these are MAC addresses. Okay, right now in his computer, he has around two chips. One may be Wi-Fi, one may be Ethernet cable. Okay, so let's go further. Okay, then we have second type of device, which we'll talk about is like if you want to connect multiple computers together. Okay, so if you want to connect different computers together, then there is a device called hub or switch. Okay, so hub is a very old name. We do not use this name now. Okay, because hub is a very old device. So better to say this is, you can see this is a hub. Okay, where you can connect computers, servers, printers. So you can add a lot of devices in this. Okay. Okay. So let me go back. Okay, so a network interface card available in wired and wireless. Wired NIC and wireless NIC. Okay. So then we have another device. Suppose you want to connect more computers. Then we have a device called hub. But hub is very old device. Okay. So you can connect multiple computers like computer A, computer B, computer C, computer D. Okay. So you can connect a lot of computers together. And this is like connect more or connect two or more computers. Okay. Connect two or more computers. So what is the use of hub? Hub, you can say hub is used to used to connect. Hub is used to connect two or more computers together. Okay, so you can have this full stop here. Okay, so then what is the problem with the hub? The problem with the hub is, suppose if computer A, see this, see my screen guys. Suppose computer A want to send data to computer B. So what will happen? The hub will send the data to C also, to D also, means to everyone. So when you send data to everyone, that is called broadcast. Okay. So there are three types of basic connectivity. Okay. So one is called unicast. Okay. What is unicast? When you send one device to one device. Okay. That is called one to one, is called unicast. Okay. So then what is multicast? So multicast क्या होता भाई? So multicast is when you send data to maybe computer B. Okay. So you also send data to computer C, but maybe you do not send data to computer D. Okay. So multicast is when one to many. Okay. One to many. Okay, but in the case of broadcast, ठीक है, तो ब्रॉडकास्ट क्या होता है? व्हाट इज ब्रॉडकास्ट गाइस? तो व्हेन you send data from one computer to all computers, B, C, D. Okay. So when you send data to all computers, that is called broadcast, one to all. Okay. So that's the thing here. So hub क्या करता है हमेशा? So what hub problem is always broadcast. So is this a good thing? Suppose just imagine if you have 100 plus computers. Okay. So do you think we should send data every time to those 100 computers? So if I want to send my, okay, so when I want to send packets to other devices also, then there is a problem, right? So the problem is like we do not have to send the packet again and again to one of the main devices again and again. So that's the problem. One to all is like a radio. Yes, TV, radio is good example of broadcast also. TV, radio, because you can only send the data. Okay. Okay. Broadcast. Okay. Multicast, unicast. Okay. So that is like one to one. Multicast is one to many. So then we have a third device, which is called, okay, the third device I would say is hub, is already done. So we have now switch. Okay. So what is switch now? Switch is also like you can connect multiple computers. Okay. But the only best difference between switch and hub is, so the first of all, the switch is latest technology which work on very powerful processors and all. It has a lot of features. Okay, it can give you security. I'm talking about good switches. Okay, security. It can provide you some security. It can also maintain a table which is called MAC address table. Okay, so the main difference, if somebody asks in interview, okay, what is difference between hub and switches? Because switch has a table, this switch also used to connect multiple computer. Okay, the same definition. Switch is also, okay, used to connect two or more computers. Okay, two or more computers. Computer means like laptop, server. Whenever I say computer word, so it means computer, laptop, printer, server, everything. Okay, two or more end devices. Okay, so computer लिख रहा हूं मैं यहाँ पे. So used to connect two or more end devices or more computers together. Okay, so but switch will provide me security. Switch will also maintain a table which is called MAC address table. Okay, let me give you one example, guys. Okay, suppose you, so your friend calls you. ओके, तो आपका एक दोस्त आपको बुला रहा है समझो. ओके, सपोज योर फ्रेंड कॉल्स यू इन बैंगलोर. ओके, यू आर गोइंग फर्स्ट टाइम बैंगलोर एंड यू डोंट नो द एड्रेस. ओके, देन यू गोइंग searching Google Maps, everything and all, and then finally you reach the destination. Now you know the path. Yes, you know the path, that how to go to friend's place. Okay, but next time do you think you need to call your friend? Okay, maybe not, right? Because you know the path now. Okay, the same way switch is like, when first time it will also create problem, it will also do broadcast. Okay, but after first time, okay, only broadcast. So the hub problem is always broadcast. Okay, but switch broadcast to know the MAC address. Okay, broadcast to know the MAC address. Broadcast to know the MAC address. So once we know the MAC address, then we do unicast and multicast. है ना बढ़िया चीज, right? If we know the address, then we do not have to do broadcast. But when I don't know the address, suppose if computer A send data to C, for first time we will send packet to everywhere. तो पहली बारी हम सबसे पूछेंगे. Okay, we will send packet to everywhere. But once we know the MAC address of C, so the switch will maintain a table. We will store, okay, A MAC address is this, B or C computer has this MAC address. So next time, if you send a packet, that will not broadcast. That is why switch is called intelligent device. That is why switch को हम क्या बोलते हैं? Switch is also known as intelligent device, then hub. Why it is intelligent? Because it store MAC address table. Okay, and how it store MAC address table? Because we first broadcast, we got the MAC address, and after knowing the MAC address, what we will do? So broadcast to know the MAC address, then we do unicast and multicast. तो भाई पहली बार तो मैं ब्रॉडकास्ट करूंगा, फिर उसके बाद यूनिकास्ट एंड मल्टीकास्ट. ओके, बिकॉज ब्रॉडकास्ट प्रॉब्लम इज वेस्टेज ऑफ बैंडविड्थ, wastage of network traffic. Okay, so network traffic is called bandwidth. The technical word is called bandwidth. Okay, like we talk about in roads, okay, traffic jam or traffic is there on the roads, right? In technical, in IT network, we call them bandwidth. Okay, how much bandwidth you are getting, how much speed you are getting. Okay, wastage of bandwidth means wastage of internet speed or wastage of LAN network speed. Okay, so basics are very important because people do not take basics seriously, and that's why they lack in understanding. So basics are very, very important. Okay, so this is what we have done now. NIC, hub, and switch. Okay, so this is NIC. So then we discuss about. Okay, so this is NIC card, hub, and all. Okay, so now the fourth device we have is a router. Okay, we will see a practical representation also how these devices are connected. So then we have a device called router, and some people call them router also. Okay, so there are two different pronunciation, router and router, and some people call dabba. Okay, so router. So router is a device which is, so router is very, very important device because this router help us connect two or more different WANs. Okay, connected two or more different LAN networks. Okay, or different networks. Okay, let's not use LAN word. So instead of, you can say connect two or more different networks. Router is used to connect two or more different networks. Okay, the same example, guys. Suppose you have office in Delhi and you have switch. You connected a lot of computers together. Okay, so this is like my building A. Okay, so this is our building A, and there is another building, okay, which is like building B. Okay, so now if you have two buildings, okay, now you can connect two buildings also together. Okay, if the distance is a little high, you can need, maybe you need a router. Okay, so you can take an example if we connect two different LAN networks, or you can take more example if you do not understand the buildings. Okay, let's not go and, okay, you can simply say when you take internet connection. So what is internet? Internet is also a different network, right? Internet is also a different network. So then how you connect your network with a different network? So this is your company network. Yeah. तो ये आपकी कंपनी का नेटवर्क है. This is your company network. Then how you connect your company network with different network with the device called router. Okay, so routers are also many types of router which we will discuss. But as of now, you need to understand the definition. If somebody asks you, okay, tell me, you are doing CCNA, tell me what is router. So router is a device. Router is a network device. Okay, just add one more line here. Router is a network device. Okay, so when switch, somebody people ask what is switch. switch is a network. Okay. So now how you say in the interview, if somebody asks you, so router is a network device which is used to connect two or more different networks. So what is switch? Switch is a network device which is used to connect two or more computers together. Clear everyone? Yeah. So now we have a device called firewall. Okay. So we have a device now, firewall. So what is firewall now? So there are different types of firewalls. Okay. We are specifically checking firewalls which are now firewalls are three types of firewalls. Okay, so three types of firewalls. One is like software firewalls, which are used in your Linux machines, Windows machines, and all. Okay, like Windows firewall. Okay, so it is a software which is inside your Windows, like Windows firewall. Okay, then we have another firewall which are called like what we call them. Let's call them normal firewalls. Okay, let's call them firewalls. Okay, and nowadays we have next generation firewalls. Next gen firewall, which are more powerful. So if normal firewalls, like you can block block IP addresses. Okay, you can block IP addresses, you can block port number. Okay, so you can do all these thing with the normal firewalls. Okay, but next generation firewall means you can block with the URL also. Okay, with some app ID, content ID, lot of advanced features are there. Okay, URL filtering. Okay, so this next generation firewall can help you so that people do not attack also. Okay, like it can secure your emails, it can protect your whole company network. So it has a lot of many features. So currently in the market, if you talk about like three categories I told you, hub to use nahi hote. Nowadays we do not use hub. Okay, but three things we have understood today. One is called switches, then we have routers, and then we have firewalls. So as a network engineer, you need to be very good in all three products. Are you getting my point, guys? So CCNA, CCNP is just a certification program which can help you to learn about router and switches. Okay, so you have to learn firewall also. But today, if you talk about the skills as a network engineer, you need to have that is router, switches, and firewall. Okay, the good companies like Cisco is the main company who makes switches, routers also, okay, and firewalls also. Okay, the next company is Juniper Networks. So Juniper Network also makes routers, switches, and firewalls also. Okay, so now then we have a company like firewall, good company, like we have Palo Alto. Okay, which only right now I think they only make firewalls. I don't know if they have switches and all. Maybe they have basic switches, but not as good as Cisco and Juniper networks. Okay. Then we have companies like HP. Okay, HP, Hewlett Packard or something, Hewlett Packard. Okay, so they make switches. They have some firewalls also, but normally they are good in switches only. Okay, so Dell. Okay, Dell company has switches. Dell has a firewall which is Sonic Wall. Okay, but I think Dell do not have a good router. So maybe they have, but I'm just telling you the industry standard. Okay, तो हो सकता है Dell का router होगा. Okay, so maybe Dell HP has a router, but maybe they are using some customized product, but they are not the leaders. Okay, so Dell is famous for servers, not switches. Okay, so but yes, Dell has a firewall also. Okay, so I would say Dell is more famous in servers, not in switches and router. Okay, but the main big market is Cisco, Juniper Networks, And nowadays, there is another good company which is on the boom right now, which is Extreme Networks. Extreme Networks. Okay, Extreme Networks. And there is more what we call Arista. Arista is also very good in ये चीज जो मैं तुम्हें बता रहा हूँ ना, द नॉलेज आई एम शेयरिंग now with you all, maybe you get to know this when you will be in the industry for like 3-4 years, then you got to know about all these things. Okay, so if this is your first networking class, so you should be like glad that you are getting this knowledge in the first class itself. Okay, so just check out these websites. So what is your homework, guys? So go and check the websites of all these companies. Okay, because I can only give you direction, but you have to follow your journey yourself, right? I hope you got the point. Okay, so ये बहुत सारी important companies हैं जो आपको देखनी चाहिए. Okay, these are very very important websites. So you should at least visit their website and check what they are doing. Okay, some Chinese products are also in the market like Huawei and all. You can check them also because many companies are using those Huawei and all. Okay, Nokia is also there. Check Nokia, Alcatel and all. Okay, so just to search this also. Nokia, Alcatel and all. Okay. So this is all about firewalls, routers, switches and all. So firewall is also a network device. Router is also a network device. Okay. Then we have a device called a load balancer. तो अब हम जो देखने वाले हैं, okay, the another device in the market we have is load balancer. Okay, which is also additional knowledge is required if you become a network engineer. Okay, many jobs they also ask. ये तो तीनों mandatory हैं. All three things you have to learn in deep, and the best way to learn routing, switching, and firewall. So by learning CCNA, CCNP, and firewalls. Okay, so why you are learning CCNA, CCNP? By the way, if you don't know, so you guys are learning because you will learn about router switches, and if you learn any firewall, okay, suppose you join any Palo Alto batch or any batch, then you complete your router switching and firewall knowledge. Then once you get the good job and these three things, trust me, these courses can help you. So suppose you are a fresher now, within 2-3 years, okay, within 2-3 years, you can go up to 10 lakh CTC with only these three products, CCNA, CCNP, and firewall. Okay, but after 10 lakhs, 12 lakhs salary in India, okay, uh, you can convert in other currency. I'm talking about Indian market. Okay, so you can check how you check your country market. Just go to the job portal of your country, okay, and just check out what is the requirement. Okay, then load balancer. Load balancer. What is the use of this load balancer? Okay, so suppose this is internet and we have a different. So let's take an example. I am working for Instagram. Suppose now Instagram has a server in Singapore. Okay, maybe they have server in India. Okay, so then maybe they have server in USA. Okay, so this is global. You want to load balance. Suppose India traffic. So which is nearest server? India traffic should go to India server, right? USA traffic should go to USA server. Canada traffic, Canada की जो traffic है, Canada traffic is near to US, so Canada traffic should also go to US. Okay, suppose Nepal, Nepal is near India, so Nepal traffic maybe go to India. Okay, or maybe let's call about China or something. Okay, so China maybe can go to Singapore. Okay, so this is like how you want to load balance the traffic. Okay, but on internet today, do you know why AWS, Azure, why cloud solutions are getting popular? क्या आपको पता है AWS, Azure इतना फेमस क्यों हो रहे हैं? डू यू नो? because they are giving you global load balancing services. Okay, you can have same server in AWS Singapore, AWS India, AWS USA, and all the countries will not get delay. You know delay, right? Suppose lag, internet में जो lag आता, okay? Suppose you watch Instagram, but you are not able to watch videos properly. Okay, but if you have good internet connection, then there is no problem from Instagram side, right? That's why, because they are using global load balancing techniques, that is called CDN, content delivery network. Okay, content delivery network, CDN. This is another type of network nowadays. I'm teaching you the latest content. Okay, 2023 चल रहा है भाई. Okay, so you should understand what is CDN, which is very, very important. CDN is content delivery network. So AWS is giving you servers in Singapore, India, USA. So this is very big company. Instagram is a very big company, right? Everybody knows. Yeah. Okay. So load balancing is important. This is global CDN. But what if you have one location inside this AWS Singapore? Now you have 3 servers. Okay. So now all the traffic which is coming to Singapore, so half traffic you want to send to this, second traffic you want to send to the second server, third traffic you want to send to the third server. Okay. और let's take an example in India also. अब इंडिया में भी हमें 3 जगह से ट्रैफिक आ रहा है सपोज लाइक मे बी यू आर गेटिंग ट्रैफिक फ्रॉम नेपाल यू आर गेटिंग ट्रैफिक फ्रॉम इंडिया और ऑल्सो फ्रॉम मे बी नॉर्थ इंडिया साउथ इंडिया लाइक दिस ओके so because India is very big country so we can't handle one server can't handle the whole traffic yes or no yeah so maybe you need 3 servers and then you can use a load balancer device which is very popular nowadays F5 okay big LTM, big F5 or what we call that. Okay, big IP F5. Okay, F5 is called load balancer. Okay, local traffic manager. तो यहाँ पे हम एक डिवाइस लगाएंगे. This device name is like F5. Okay, so this India traffic. Suppose North India traffic go to first server, South India traffic to go to second server. Okay, Nepal traffic will go to third server. So this server or this load balancer device is called load balancer. Okay, where we place load balancer? So one is global load balancing. So global load balancing हमें कैसे मिलती है? How we get global load balancing? CDN. Okay, let me show you CDN. Then you will understand. Okay, so this is example of AWS. Okay, so you can see this is the global infrastructure. Okay, so you can see in almost every country they have small dots you can see here. Okay, so they have a lot of, so they are on 32 local zones, 245 countries. In 245 countries they are providing connectivity. Okay, so they have big network. Okay, so now this is the reason, this is the #1 reason why people are going to cloud. Okay, so don't worry. Okay, that sir, if everything is going on cloud, then what is the use of learning networking? Right? Don't ask me this question. Cloud is also built with networks. Okay, cloud is not actual cloud. Okay, it is like connected with cables, routers, switches, firewalls. Okay, so you can go to it, just type here AWS data center. So data center where we keep our network devices. So what is data center? तो जहां हम अपनी devices रखते हैं. Okay, we add all the network, routers, switches, firewalls in the AWS data centers. Okay, so these are the data center. Okay, so let me give you some 360-degree tour data center. Okay, so let's take a tour of Google data center. इसको तुम चला सकते हो. Okay, so Okay, so this video you can see. This is the first time you are looking at this YouTube video where you can move here and there. Can you see that? Yeah, so these are the cloud data centers. Okay, and these are Google data centers around the world, and you can just have a look here. Okay, so now let me run in 4K so that you get a clarity. Okay, so till the time so he is the senior network engineer. So I'm just showing you that what is the demand of network engineer. So ये बंदा network engineer ही खड़ा है तुम्हारे सामने, ठीक है? Don't ask me that what is the use of networking. So the big companies are also having. So this is the data center in Google, and Google also have a cloud solution. Okay, so all these are big data centers where who is he? He is also a network engineer. Okay. So then these are powerhouses because everybody needs a cooling system. So these are maybe lot of heat is generated and it is to cool down. And this is the use, and this is the data center tour. Okay. So like the same tour you can have of different companies like Facebook, Microsoft and all. And Microsoft is going beyond the limits, guys. Okay. Because they enter lobby. ये तुम देखा करो यार, मजेदार है टेक्नोलॉजी. Okay, so it is like, okay, so where should I go? Okay, okay, so let's go to operation room. Okay, explore operations room. Okay, so these are like network operation centers. Okay, so you can see, right? So let's go to some mechanical area or where we want to go. Okay, so we can see regions. So this is all about Azure and all. Okay, so we can all uh, check all these things. Okay, so this is just explore all these things what I'm showing you today. Okay, and it will help you to understand about the Microsoft networks or about any big networks. Okay, so where is their server room? Actually, I have to find it. Okay, so the same similar way na, I have shown you the Google data center and all. Yeah, this is the server room. Let me show you. Okay, come on. Okay, but yes, the same way AWS and Google. Okay, this is why the CDN thing is very important, because the CDN will, but what is F5 load balancer? What I was telling you. Okay, let's not get distracted, because when I go into technology talks, then I go different in a different direction. So, okay, so you can see here. So lot of clients when they need to have load balance in their network, then we have a device called load balancer. Okay, so you can see lot of user, one server traffic, one computer will go to another server, second user will go to second server, third computer will go to third server. So load balancing means just that from wherever you are getting the traffic, you are just this device, which is this F5, is load balancing the traffic. Okay, let me show you some good pictures now so that you get an idea. Okay, so let me show you some Cisco ASR. Let me show you first ISR series router. Okay, and let's take a root. पहले हमें इस Okay, so this is the router models. Lot of models from Cisco. This is, I told you, this is your homework also. So you can see ISR 4000 series, ISR 1000 series. Because when you go for interviews, people ask you, okay, you have done CCNA, CCNP. Tell me on which devices you worked on. #1 क्वेश्चन है ये. हर बंदा पूछ रहा है आज की डेट में. Okay, everyone is asking. Okay, tell me you have done CCNA, CCNP. Tell me on which devices you have worked on which devices you have done labs. Okay, so you need to understand some model numbers and all. Okay, so ये थोड़ा सा ध्यान देना. So nowadays Cisco has also created some softwares like router selector. You can just give the solution. You can see here we are hiring, looking for enterprise routers. because the small of routers you can directly buy from some companies like TP-Link and all. So these routers, TP-Link, D-Link and all. So these are normal, like they are also good companies. If you have small company, small office, okay, you can buy their routers, like the same router I'm using in my office. Okay, because till the time you do not have more than 200, 300 employees, you do not need Cisco routers. Okay, so we are using also this Omega gigabit VPN router. Okay, so which is like giving you some connectivity. It has a lot of ports and all. Okay, but when it comes to a big company which are called enterprise, so enterprise has a lot of models. Okay, you can see this model NCS. Okay, so ये देख सकते हो आप यहाँ पे. Okay, so there are different models as I mentioned. Okay, and directly you can read about all these things. I'll show you how to read the documentation and how to select good routers for your company. Okay, don't worry. Okay, I will exactly explain you how companies look for those things, and I will also explain you those. Okay, but it is like I will give you some documentation on all. Rest you have to check. Okay, yes, server. Yeah, this is the server room, guys, of Microsoft. Okay, again, so you can see here, I can go here, circular center. Okay, so this is amazing. Okay, so what is going on? They have replicated the same type of things in there. Okay, so I'm just sharing these links so that you can just enjoy in a free time. Okay, so now you got the point, routers, which is and all, and Cisco has a lot of models. You need to go to this Cisco website, go to networking section and go to this section, what we call router. कहाँ दिख रहा है? Okay, router. Yeah, you can see access networking. Okay, wide area services for enterprise. View all network products. Go to view all network products. Okay, then it is asking, okay, what network devices you need. So you need a normal networking devices called access networking. You need a network devices for big data center. You need a network device for industrial IoT. Okay, like suppose petrol pump is there, gas station is there. So these type of devices need more rugged routers. मतलब यहाँ पे temperature control devices which workable in harsh industrial environments. They are called industrial devices. Okay, you can add them in the industry. Okay, like in the petrol pumps or maybe in petroleum gas plants, big plants. Okay, where you can put, but mainly devices are okay, like your normal access devices. Okay, that I am looking for a switch, I am looking for 9000. Okay, so nowadays cloud solutions are also there in the market. Okay, so this is 4000 series as I told you. So I trust me, within one day we can't learn everything because it has taken a lot of time for me to understand everything. तो अभी धीरे धीरे तुम्हें समझ आएगा. So for today class I would request everyone to just focus on the network devices. Okay, so NIC card is done. Okay, so then we have discussed about hub, then we discussed about router, then we discuss about load balancer. Okay, तो यहाँ तक हमारा clear है अभी. So what other devices we have to look for? You can just scroll down. Okay, so you can see here, this is the work of network engineers. Okay, so this one picture will explain you the whole company network. Okay, so इसको समझते हैं. Okay, so now as a network engineer, okay, so what do you see here? Maybe the image is little blurry, but try to understand. Okay, so this is enterprise network. Okay, so what happened? So you can see there are two type of connection. One is called WAN and one is called internet. So in every company, if you work for any company, so normally every company has a network which is called private WAN and one is called public WAN. So public WAN is called internet because that is the internet. Okay. So now you can see internet because from internet, attackers, hackers, lot of people can come in your company and hack your system. That's the reason when you get internet connection, we add firewalls because firewall help us to secure my company network from attacks. So whenever a attacker try to come in my company, the firewall is like a wall which you cannot enter. It is like secure the company network. Okay, then you can see here, these are some routers. Okay, so maybe this is your Delhi office, and now this is your another office, maybe in Mumbai. So you are connecting your this office, Delhi office, with Mumbai office. Okay, and you are using which devices? Routers. Can you see that routers? And there is a router in Mumbai also, and there is a routers on Delhi also. So basically, routers are helping you to connect from head office to branch office. Are you getting my point, guys? तो हम क्या कर रहे हैं यहाँ पे, ये जो मेरे हेड ऑफिस के राउटर हैं, द हेड ऑफिस राउटर्स एंड माय ब्रांच राउटर्स आर कनेक्टेड नॉट ओवर इंटरनेट, on WAN, and this is private WAN, and this is very very costly. Okay, but it is costly. Internet is not costly. Okay, it is like average. Okay, it's not cheap also nowadays. Okay, but it is costly solution. Private WAN is a very costly solution, but it is very very reliable. Okay, so internet connections are cheap. Okay, depends on what internet connections you are using. Okay, means cheap, average also means good internet connections are costly also. But in comparison with the private WAN, they are all cheap, definitely. But it is like average, okay, means not too much reliable. Okay, it is unreliable. Okay, or depends on internet speed. Nowadays, the technology, the internet speed is too high. So nowadays, with internet also, you get reliable connections. Okay, we can't say unreliable. So आज भी हमें reliable connection मिल रहा है. Okay, we are getting reliable connectivity. So then you can see firewalls so that nobody can enter in the firewall. Okay, and then some switches. You can see here wireless access, wireless router or wireless where mobile phones are connected, video conferencing devices are connected, lot of company users and their IP phones, so like where you can call, right? So these all are connected with the device called switch, because all these devices are which devices? End devices. तो ये हमारे end devices हैं. Okay, all these are end devices. And these devices, what do you see here? Whatever you see here, all my network devices. Okay. So these again, we have a LAN network here. You can see lot of switches are connected. Okay. So these switches then further connected to some another switches, and these are called core switches. Can you see core? So core means advanced device. So these are normal devices. Okay. So these are advanced devices where you can have security, you can load balance the traffic, lot of things you can do here. Okay. And then these devices further connected to router, firewall. Okay. And the similar way you can see here inside my company. Okay. We have a data center also. Okay. With data center मतलब यहाँ पे आपके कुछ server रखे हैं. So you have some servers in your company and you can have a load balancer here also if you want. Okay. So there are firewalls over here also because people from internet, okay, if they access the servers, the company will be secure. Okay. Means firewalls are inside the company also and outside the company also. Means firewall यहाँ भी लग रहा है. Okay. Firewall is used over the internet and also used in their internal network also. So, so you can't see one diagram of company and understand, okay, this is the same network we will have. No, every company has a different network design. Okay, so every company has a different network device design. So आज का क्या था आपका टॉपिक? So today we have just checked what is network, and these are some theory parts if you want to understand. Okay, I have already added a little theory, so that because people ask me, sir, you teach, but you give me some content to read and all. So you do not have to refer any book right away. Okay, just follow these notes. Routers. So what are routers? Okay, what are access point? So what are access point? To change the network connection into Wi-Fi connection. Okay, so these are called access points. Okay, we'll discuss about these things in further topics also. WLC. Okay, so एक suppose if you buy a normal WLC. Okay, so let's take an example, guy, of your college or university. Okay, so what happen if you have a lot of Wi-Fi devices? How you will manage all Wi-Fi devices? Suppose you want to change password. Do you think in college or university you change Wi-Fi, every Wi-Fi you will change password? No. You will change Wi-Fi password from one location, and these are called WLC. Okay, so WLC is like papa of all access points. Okay, तो ये देख सकते हो आप यहाँ पे. Okay, so see this picture, guys. Okay, there is a device called a WLC, which is wireless LAN controller. Okay, Wi-Fi कौन दे रहा है? Who is providing me Wi-Fi? These are access points. So we can have all these in my building, in my campus. Okay, all these are buildings. Then they are connected to switches, routers, firewalls. But who is managing all these Wi-Fi devices? This device, which is called WLC, wireless LAN controller. Okay, means you can control all the Wi-Fi in your company with this device, which is called wireless LAN controller. Okay. So if somebody asks you wireless LAN controller, it is just a device which is to facilitate the management of access point. मतलब बहुत सारे access point को जोड़ने के लिए काम आता है. The WLC is used to connect different lot of access point together, and you will able to manage all of them together. Next generation firewall I told you, which is to secure the company network and all. Okay, they are called the next generation firewall. You can have security rules. You can protect your company from attacks. Okay, uh, you can block webs. You can block a game inside Facebook, because suppose you want to give permission that people can access Facebook, but you can't play any games on Facebook. Okay, so you do not want them to give access. So you can block them simply with the next generation firewall. Okay. So now this picture you have to understand. ये photo देख के तुम्हें, okay, just see this picture and at least you need to at least understand every device today. Okay, so maybe one or two device, leave it. So just tell me laptop, everyone understand? Yes. Funny question. Yeah. So let's check mark on the router. Okay, so let's tick mark on the devices what you know. Okay, so you understand laptop, right? This is the symbol of laptop. Then we understand tablet, okay, like iPad or something. Printer, everybody knows. Server, like two types of servers, Windows server and Linux servers in the market. Okay, Linux, there are different Ubuntu, Red Hat. Okay, lot of servers. Okay, then we have virtual server. What is virtual server? Anybody? Virtual machine, VM. Okay, suppose you create a website, and I also want everyone to use a account. Okay, on like okay, I want everyone to be start becoming techie. Okay, so I want everyone to use this website, Digital Ocean. Okay, so go and get it. They will give you $200 credit for your practice. Okay, so enter your email ID. So let me create my, I don't know if I have. Okay, so just go and create a free account. See, overall, holistically, we have to grow in this technology term. We can't say, okay, I have to just learn router switches. आज की डेट में वो बहुत पुराना हो गया बॉस. Okay, so you need to learn lot of things to give competition to the people who are giving interviews with you, right? Hopefully, you will not go together all. Okay, so this is extra knowledge. If anybody wants to sleep, they can go. Because I always give some extra knowledge. This is not part of our CCNA. So if anybody wish to go, they can go and sleep. So I'm just trying to show you that how you can, what is virtual machine. Okay, everyone, my email ID is already created again and again. Okay, let me use this ID. Oh man, I have used all my email IDs. Yeah, sorry, I can't able to create account, but yes, you guys can try. Okay, and try to create account on this digital ocean. Okay, maybe I'm not sure if I'm able to log in. Maybe this account. I can't log in today. I've used almost every email ID today. आज ये दे नहीं रहा access मुझे because I've used all my email IDs. Okay, so but yes, you can always sign up. Okay, and you can just create an account. Okay, let me use maybe I have one account. Maybe I can try this. Yeah, I got it. Okay, so just have to verify my email account. So just go to email ID and verify. Finally, I remember one ID which we never used. Okay, so it is asking me to verify a card because they are giving $200. Okay, so maybe I can use just randomly you can add a card. Okay, so let me add. Okay, but don't forget, okay, that you have to disable the membership also, else they will deduct your money after some time. So the amount will be not be deducted, don't worry. Okay, so they will just take okay, minimum actually I think we have to add 5 or 7. So there are many different websites. So I do not recommend you to pay. Okay, there are Linode also. Okay, you can go and try a Linode also. They give you $100. Okay, there are Digital Ocean also. There are Vulture also. So what are these companies? So they are basically cloud providers. Because if you understand them very easily, you will understand AWS Azure also. Okay, so that's why I'm saying you can just try them and try to check if you can create accounts on these websites, and you can simply log in with your Google ID and try to log in. Okay, the same way. So right now you can see I'm already in the server. Okay, so I'm inside not DigitalOcean, Linode and Vulture. You can use any, and you can say create Linode. So what are they like? Now they are asking which server you want to create. Okay, you want to use Ubuntu, or you want to use a Windows, okay, or Fedora, CentOS, Linux, Arc Linux, which is used for hacking, for all these cyber security and all. Okay, you can use, and you can also use any application like Marketplace. Suppose I want to use Kali Linux. You can see I want to install Kali Linux. I want to create my own cloud. अगर मुझे अपना खुद का क्लाउड बनाना है जैसे गूगल ड्राइव है. Okay, I want to create my own Google Drive. Okay, maybe I can say next cloud I want to install. Okay, means lot of applications are there, guys. Like you can create your websites, you can create WordPress. Okay, you can create your Plesk also, like home streaming server also. Okay, so you can say here the limited sudo user, enter a password. I will enter any password. Okay, disable root access. Okay. Okay, so now it is asking me, okay, because when you log in, it will give you some amount, okay, maybe some amount like $100, $200 for practice. Okay, then you can say that I want to use like 2 GB server, 4 GB server, and the amount will be deducted from those free credits because you will get free credits. Okay, like if you run this for 1 month, 1 month charge is $30, and they will give you $200, $100 for free. So you can use 3 to 4, like one credit card can help you to use this for 2 to 3 months. Okay, so create load. So now it is asking where you want to create a server. I want to create in Mumbai. Okay, so you can see, and then I say create. See, my server is getting ready. Within 1 minute, my server is getting ready. तो ये थोड़ा सा एडवांस हो रहा है, अगर तो कोई दिक्कत नहीं है. कैन आई इट इज देन load balancing is like F5. Sir, all you tell about Cisco Meraki will discuss, don't worry. Are we going to do lab on real devices? Yeah, yeah, Babu. We will use the similar iOS for the labs. Is there any limit of the device on many network they can connect using one router? Baldeep, no, there is no such limit, but depends on router model. Okay, so you can see the server is ready almost. Okay, so this is the IP address. So this is SSH. I have to go to my terminal. Okay, like command prompt and all, and I have to do SSH. Okay, so we'll discuss about all these SSH and all. Don't worry. Okay, so this is the way. I think I have to use something different. Yeah, I forgot the password here. That's the big thing. I can get a password from here maybe. This is my password. Okay, so now you can see, guys, I'm inside one server. Okay, so I'm inside one server here. And what we have done, we have installed, I think, क्या install किया था हमने? Nextcloud, okay? So if you go and open this, okay, so this is like installation of that cloud. So maybe you don't know what I'm doing right now. But it is like whenever you install any application on the cloud, so you need to be little bit good in Linux, okay? So I was showing you that yes, you can see installation is done. Okay, so it is saying it the installation is done. And if I try to open this IP, okay, I have to use maybe HTTPS, maybe been HTTP. Okay, it is. There should be some URL. Okay, so okay. Yeah, docs. You can see docs here. So it is like how to install. So guides. So this is how means it's not a very easy thing. We have to look for that I if I want to install the next cloud because I was thinking to add here install next cloud. So there are some videos and all. Okay, means like I have done this multiple times, and just we need to understand like the configuration, and you need to read some documents, and then we understand these things. So this is my public IP. I should access this. So this is the website setting up installation, and this is the web page I should open. Maybe I have to use any different browser. Okay, it's not loaded. Okay, I'll check it. But this is how you install a lot of applications. I was just saying you that you can test all these things, and whenever the work is done, you can always power off the machine. So why this is important? Because right now you guys are into technology world and you have to learn a lot of things. It's not just a CCNA, CCNP. You because in CCNA, CCNP also there are some topics like virtualization, cloud. Okay, so कुछ कुछ टॉपिक हमारे ऐसे हैं. Okay, because if you go and refer CCNA content, okay, so by the if you don't know, you can go and see the exam content of CCNA, and there is a topic virtualization also. This is why we need to little bit understand what is virtualization. So the same example I was giving you, you can go and try these websites. Okay, try to create some website, try to just explore the things, because I can always like definitely we will cover what is virtualization and all as a theory part, but you have to experience those things yourself also sometimes. So I'm going to explain now, first of all, like what about the network devices. Okay, network device. Okay, so what network devices we have? We have router, switch, hub, bridge, firewall. Okay, WLC, access point. Okay, yes, modem, repeater. Okay, any device. Okay, load balancer. Yeah, so these are network devices. Okay, so we recently just started a drone. Okay, so this is what we call network devices: router, switch, hub, bridge, firewall, WLC, access point, modem, repeater, load balancer. So we are going to understand these things. Okay, but so I'll put this one another device on 11th number, that is NIC. NIC. Okay, so cables are not part of network devices. That is network media. Okay, so let's understand this. So first of all, what is router? Okay, so I told you like a router is a network device which connects different networks. So router is a network device which connects different networks. Okay, तो ये different networks जोड़ने के लिए use होता है. So this is why everyone uses router nowadays, because internet is a different network, and your network is a different network, right? Your network and internet is a different network. This is why we need routers, so that one network can communicate with another network. तो इसी वजह से राउटर लगाया जाता है, ताकि दो नेटवर्क आपस में डिस्कस कर सके या रूट शेयर कर सके. So why we use router? So that we can share routes with each other. Okay. So router has a table which is called routing table. So router has a table which is known as routing table. Routing table is like a brain of router. Suppose there is a router, okay, and router has multiple paths to reach destination. Okay, suppose this is a server google.com, and this is your computer. So now you can see this router has two paths. One is from this side, one is from this side. So router is going to take decisions. Routing table help.
router to take decisions. So who takes the decisions? Routing table takes decisions. तो जितने भी डिसीजन होते हैं वो राउटर का राउटिंग टेबल लेता है. सो राउटर हैज अ टेबल which tells how to go. Like suppose guys, if you want to travel somewhere, so nowadays what you do, you use Google Map, right, to reach your destination, and Google Map will give you the best path. So this is the same thing. Router has a routing table which helps router to take the decision. And router is a device which connects two different networks. Marshall, ARP, or all other things will come later on. Okay. I know how I need to train. So just focus on what I'm delivering. It's not ARP. Routing table is not ARP. Routing table is routing table. Routing table को routing table ही कहा जाता है. Okay. Routing table. We will not discuss routing table right now. Just understand router has a table which is called routing table. Router takes decisions with the help of routing table. Okay. Tell me guys how you take decisions from your brain or from your obviously or without thinking you keep going somewhere. Obviously suppose you want to go to your home, okay, or maybe your friend's home, so you will think about, okay, I have to take left, I have to take right and all, right? So that brain is your routing table. Now you understand router as a routing table from where router takes the decision. Okay, but we will not say in interview. आपने कभी भी इंटरव्यू में नहीं बोलना है. So we will never say routing table is the brain of router. This is wrong term. Routing table is a table from where router take decisions. That's it. But we will not say brain in interview. Clear? Because it's very layman or it's not good language. ठीक है, तो इतना ब्रेन में नहीं बोलना है. Okay. So this is router. So now let's move to another device which is switch. So what is switch? So switch is a device which is used to connect. Even switch and hub both, okay? Switch and hub, which is used to connect multiple computers or servers. Okay, computers, servers are same thing. Servers are just having good hardware. So switch hub is used to connect multiple computers or two or more computers. You can also say that hub and switches which is used to connect two or more computers together. Suppose you have a computer, computer A, computer B, computer C. How you are going to connect three computers? Then you need a device which is called switch. Okay, this is a switch, and switch learns MAC address. So I'm going to explain you IP address and MAC address as well. But switch understand MAC address. So what is MAC address? It's a machine address like computer A, computer B. All computers have their MAC address. So whenever you send anything from a switch, switch stores a MAC address in a table which is known as MAC address table. So switch makes which table? MAC address table. And router makes which table? Yes, guys. Router makes routing table. Switch makes MAC address table. Sanjay, those are called ports. Sanjay has a question. Router has an NIC card. We will discuss. Okay. Because switches works on MAC address and IP address, but as of now, I am telling you normal switch. We are not discussing multi-layer. So the 12th topic we will take multi-layer switch. Okay, I'm pointing here. Okay, so now you understand what is switch. Switch is a device which is used to connect a different two or more computer. दो से ज्यादा computer जोड़ने हो. If you want to connect more than two computers, you need a device which is known as switch. And switch makes a MAC address table, and obviously it learns MAC address and makes MAC address table. So whenever computer A send information to computer B and B will respond back to computer A, so switch is going to store the MAC address of, suppose computer A has a MAC address double A double A. Just imagine, okay? So computer switch will store double A MAC address, double B. So whenever you send anything, switch is going to store the MAC address in the MAC address table. So what is hub now? So switch and hub. So hub is not used anymore, but it also connected two or more computers. But problem with hub is it always broadcast. What is broadcast? If you send a packet from A to B, it will send to C also. Hub is a hub waste bandwidth also. Waste bandwidth. So we never use hub nowadays, and companies have stopped making hub. तो हब अब कहीं भी यूज नहीं होता है और उसकी जगह स्विच ने ले ली है. तो स्विच ऑलरेडी रिप्लेस्ड hub. Okay, so we never use hub nowadays because it wastes bandwidth. How? Because if you want to send from computer A to computer B, it will send to all the computers. Okay, so we never use hub, and hub will never store MAC address. Hub will not make MAC address table. So tell me, hub is a good device or not? Hub is a pathetic device. So guys, tell me, do you have any power extension at your home? आपके घर पर पावर एक्सटेंशन है एक, तो बाय from one plug you can have multiple plugs. Yes. So what is this? So it is passing the current from one port to all the ports. Yes or no? So hub is like similar. Hub is like similar. It is just passing the digital signals to all the ports, but it is not an intelligent device. It is called L1 device, a physical device. It is not an intelligent device. It is also known as dummy device. Clear? Okay, let me repeat again. What is a router? Router is a network device which is used to connect different networks. ठीक है, समझ आया सभी को? Very simple. And router makes a routing table from where router can take the decisions. तो router वहां से उस अपने रास्तों का डिसीजन लेता है. तो router takes decisions from the routing table. Okay. And what is a switch? Switch is a device which is used to connect two or more computers. तो अगर आपको दो से ज्यादा कंप्यूटर जोड़ने हैं, so switch is the device. And switch learns MAC address and it store all the MAC address in which table? MAC address table. And router makes a routing table. Clear everyone? Yes or no? Clear? Very good. Yeah. So we have types of communication. Okay, when you send from one computer to computer or maybe any device, not just computer, maybe router also, when you connect and only you send data or receive data, like one to one communication is called a unicast. So one to one is called unicast. Okay, but when you send data to multiple computers, but not all computers, like you have four computers, but you send data only to B and C, but not to D and E. So that is called one to many. So this is called one to many is known as multicast. Okay. But when you send data, like computer A is sending data to B, to C, to D, to everyone. टू ऑल, वन टू ऑल। तो जब हम डेटा सबको भेजते हैं, व्हेन वी सेंड डेटा फ्रॉम वन टू ऑल, तो दैट इज कॉल्ड ब्रॉडकास्ट। ओके, so these are called types of communication, or you can say that like types of networks, or communication would be better. Okay, one to one is called unicast. One to many, जब आप एक से ज्यादा को भेजते हो, when you send one to many, multicast. One to all, broadcast. So when switch sends the traffic for just for very few time, it send like it send broadcast, but after that it always send a unicast, multicast. So switch uses a unicast, multicast, it is better. But hub is a device where whenever you send any data, it will go to everyone. Okay, so that is broadcast. Okay, multicast comes in real time scenario. We will discuss. Could you give please examples for all? Yeah, obviously one to one, like if you send from computer to computer data, that is unicast. Okay, one to many means if you share, if you are playing game in your home with your siblings, with your cousin, brother, right? But you are not playing with all the guys who are connected to Wi-Fi. So that is called multicast example. And when you send data from one to all, okay, so that is broadcast. It's a very simple thing. Okay, so router switch is clear. Okay, and we almost clear hub also. But if you are not satisfied with the hub explanation, I'll give again. But even in interviews, nobody asks you this hub type of device. So hub is a dummy device. Dummy device, right? Never learn MAC address. MAC address. Always send broadcast. No long, no longer used in IT industry. That's the simple and precise explanation. And it is a physical device. Means it only works on signal. Works on signals. Remember this. It is not a smart device. It only works on signal. Okay. So now let's discuss about a bridge. So bridge is the older name of switch. Why? Because when we used to connect the devices in older days with the hub, because everyone using hub in older days, right? पहले के टाइम में सारे hub use करते थे. Like if you have multiple computers, okay, but there is no intelligent mechanism to learn from where the traffic is coming. Like we used to connect all our hubs with the one device, which is known as bridge, because bridge was a device which learns MAC address. Learn MAC address. And but the problem with the bridge is it has less ports. Ports means where you connect the cables. You can understand, like we used to connect all the hubs with the bridges, okay, so that we will actually store the MAC addresses from where the traffic is coming, from this side or this side, like this. But after hub has ports and bridge, the latest device developed is called a switch. And from last 10 to 15 years, this device is known as switch only. So we never use hub, we never use bridges. Every device, Kamal, सारे devices physical हैं bro. All these devices are physical devices. This is not virtual device. Router switch is still in use, hub bridge not in use. But why I'm telling you? Because somewhere when you are going to read books or somewhere, you will see these terms and you will not get confused what is hub and bridge. So whenever you read any article, whenever you read any book, but whenever it gives you hub and bridges explanation, please consider that book is very old. Yeah, switch is an intelligent device. In short, switch is an intelligent device. Okay. Hub is a dummy device which do not know anything. But we never use bridges because it has very less ports and it is made to connect the hubs and all. But it is not made to connect all your computers. So this is why by using both the technologies or whatever you can say, so we made switch and everyone uses switches. Yeah, switch is advanced version, you can say that. Hub and bridges are older version, which are intelligent device. Okay, so now if we discuss about firewall. Okay, so firewall is a device. Okay, so it is also available in hardware and in software. But mostly I'm talking about hardware right now. So firewall जो hardware आता है, so it's like a device like router only. So which is going, so this firewall type of device, it is going to protect you from internet attacks. Like this is internet, right? And suppose this is your company. This is your company, and company has a servers. Like maybe this company or consider this is a bank. Okay, so all their bank servers are here, but you do not want attackers can come in my bank or company and attack these servers. So firewall is like a protector where traffic means whenever attacker or whenever anyone request for information, so whenever you receive traffic on firewall is going to block the अनवांटेड ट्रैफिक जो ट्रैफिक हमें नहीं चाहिए तो वो ट्रैफिक को ब्लॉक कर देगा ब्लॉक द अनवांटेड ट्रैफिक बट if you want that these users can access google.com because internet has a google.com, yes or no, but you want this company user can access google.com, but when you access google.com, google will also reply you back. तो जब आप गूगल को कांटेक्ट करोगे तो गूगल भी रिप्लाई करेगा. So firewalls are so intelligent that inside to outside traffic is allowed. Inside, अंदर से बाहर, inside to outside traffic is allowed. But outside to inside traffic is बाहर से कोई अंदर ना आ सके. Guys, so firewall are very intelligent devices where they block unwanted traffic. Yes. So there are many companies of firewall. We will discuss about the company names of router switches and firewalls. Okay, because these sessions are not just technical sessions for you. They are going to clear your career goals also. I'm going to explain which firewalls are best, which routers are best, which switches are best, So how you are going to further make your career as a network engineer or whatever? Who send request this IP is allowed? Yes, Arun. So whenever this computer, जब भी ये computer बाहर जाएगा, whenever this computer will go to google.com, so this firewall will store the information who went outside, and it will permit. So we will understand, we will see this. Okay. So firewall is a device which is to secure the network and all. Okay. In simple words, when somebody asks you in an interview, very basic question, what is firewall? You can say that firewall is a network device which blocks unwanted traffic. Okay. And if you want to say more, you can say by default, most of the firewalls inside to outside traffic, when you go from inside company network, inside means inside your company area, to outside means internet. From company to internet, anyone can go, but from internet to company servers or company users, that is not allowed. Firewalls makes tables, but not every firewall makes. That is like stateless, stateful tables and all. So these terms will be little complex for you, but yes, firewall makes some tables also called stateful tables and all. No, my screen is not black. Yeah, my screen is black. I'm writing on a black screen so that it will be black is good for eyes. Do you know? And I do not want to have effect on your eyes. Okay. Means the black wallpaper I am using so that you will actually focus on screen, not that white area. ठीक है, समझ आया सभी को? तो फायरवॉल एक ऐसा डिवाइस है जो फालतू ट्रैफिक को ब्लॉक करता है. So firewall is a device which blocks the unwanted traffic. Okay. And anyone from company to internet can access without any permission. It is allowed. But if anybody wants to come from outside to my company server, then I have to give permission.
On the day one of our course, which is CCNA. So before going into all of these details, it is very important to understand few of the questions. Okay. So let me ask you this question. What is a network? So if someone comes up to you and asks, what is a network? What would be your reply? Hmm? What would be your reply? Oh, you guys cannot unmute. Okay, now you guys can unmute. You can unmute and talk.
It's a connection of LANs, multiple LANs. Makes a
Okay.
network.
Okay, cool.
It is a connection of multiple devices
Connection of multiple devices. Okay.
via any medium.
Via any medium. Okay. So I got two answers. One is connection of
two or more host connect together. Is
okay. Connection of two or more host.
It is a network of networks.
Network of networks. I said what is network, and you are saying network of networks. I asked the definition of networks. Okay. So I got connecting two or more hosts.
Set of nodes that are connected via the communication links that can be wireless and
Okay. So among all these answers, we got some of the technical details. What are they? So some people said LAN, some people said nodes, some people said hosts. Connecting of these basically. So connecting LANs, connecting nodes, connecting hosts, so on and so forth. Okay. So what are these? Why are we connecting to or why are we connecting all of these devices? Let's say LANs or nodes or hosts or whatever it is. Why are we connecting it?
To communicate.
To communicate that.
Devices to communicate each
For
other.
communication.
Okay, so that's where the definition comes, which is connecting two or more devices to share the data. Okay, so just simply if you just connect and there is no point of connecting, so then that's a waste of time and resources. You need to have some meaning to that, and that meaning is nothing but we should be in a position to share the data. Okay, so that's the purpose of a network. Okay, now I hope everyone know what is a network. Now comes the next question: what is internet? If you have studied about what is network, then what is internet? And after this, what is the difference between internet and network?
Internet is a network of networks.
Okay, so please elaborate that. What do you mean by networks of networks in simple terms?
Let's say in a building, you know, many devices are connected through LAN.
Okay.
And then there's another building, and that is connected through different LANs. And if there is a connection between these two buildings, you know, that would be internet.
That would be a big network, but internet is connection or connecting of
Worldwide
all the networks,
network.
all the networks in the world.
Yeah.
Okay. So cool. I got the answer. So internet is nothing but networks of network. And even we have discussed the difference between internet and networks also. Okay. Network. Perfect. So two questions are done. So now how all these things have started. So this particular internet concept has been started in 1980s and all. Okay. So in 1980s, they started this as a some university project. Okay. So some war is happening between Russia and America. So America needs some sort of way to communicate with their soldiers who are fighting in the battleground, which the Russian people cannot trace or track. So they have started these projects with the University of California and Stanford University. So both of them, they did the research on this project, and finally they have sent the first message called as login from University of South California or California, I don't know exactly. I think University of California to Stanford University. Okay. Perfect. So, but actually they have sent login, right? But among these 5 characters, only we have received the other end. That means the Stanford end has received LO. So if you go ahead and type it on the internet, what is the first message on the internet? So it would be LO. Okay. So which has been sent
Hey
between
there.
these.
Continue learning directly from industry experts. You are watching these recorded topics from our master's program, but you can watch it live by joining any of these master's program, where you can become an IT engineer that too without coding. Now you can continue.
So the first message on internet is LO. So that from there to today, where we have seen so many advancements. So like the university project became a commercial project and companies started building hardware for that, and they are selling some hardware and selling the services over the hardware. And here we are even studying that particular project which we have done. I mean, not exactly what has been sent in the 1980s, but there are with the advancements and whatever we are experiencing right now in the market. Okay. So this is how it started, a little introduction to the history of internet. Then yeah, that particular name is called as ARPANET. Okay, ARPANET is the name of that project. Okay, so this is about it basically. And then coming to the next one, so we have discussed that, okay, networks means connecting of devices, but what kind of devices are present in the internet usually? So you name it. Before me saying about it, let's discuss about this components of network. So let me know what are the different kinds of network components which you guys
Router, switch,
router,
firewall,
Router, switch,
firewall, switch,
Access point.
access point,
access point,
firewall,
server,
Firewall.
firewall,
voice gateway devices, IP phone,
Server.
any devices. So any devices.
SFP modules,
So phones, servers, PCs,
Modem.
laptops,
NIC cards,
NIC. Still,
media converters,
those come after this NIC only.
cables, Cat 6 like
Cables.
fiber optical cables,
Different
motherboard,
flavors.
video
motherboards,
conference device,
What?
video conference device.
Yeah, that also comes under the end devices.
Okay.
motherboard, CPUs,
connectors like RJ45.
Yeah, that comes under the okay connectors. Okay. Yeah.
SFPs.
All those
console,
connectors, it comes under connectors.
Okay. Motherboard, CPU,
Hub.
CPU. CPU doesn't comes under the networking component. That's a hardware related to computer.
okay.
Hub.
Hub. Great. That's the first device on internet. Hub.
Extenders,
radios.
No,
extenders,
radio is something else.
extenders,
Extender comes under. It's not an equipment as such, but it is just a booster. That's it. Still, anything more?
Bridge.
Bridge. Good.
Gateway.
Gateway, router, both of them are same. Another name of router, gateway. Okay, you guys did a good job. Okay, so these are some of the devices which are on the internet. Okay, so along with these, we have some new equipments, which is called as wireless LAN controller. So this is not new one. Okay, a controller. So some of the SDN solution. What is SDN? Anyone knows? Anyone knows what is SDN? Software.
There is centralized router manage.
Yeah, I'm just asking what the technical term related to that.
Through SDN, we can manage all routers.
Exactly. I'm just looking for the technical words.
Software defined networking.
It is a software, sir.
Exactly. Software defined network. This is the future of internet, guys.
Right, sir.
Okay. So software defined networking. So what happens is, see, with the time, the number of users are being increasing. Okay. So that means we need to increase the number of devices also. That means when number of users increases, number of devices needs to be increased. It is directly proportional. Okay. So let's say now in the networkings, so in this batch, we have 30 people. I can handle 30 people. Okay. So with the questions, questions and all I can handle. But let's say for my batch, some 150 or 200 people have registered. Yes, I can still handle, but I cannot give much amount of time to each and every people. So what happens? I'll start a new batch, some 3 batches where 50, 50, 50, I'll do it. Okay, so that's I will be starting multiple batches to provide the quality and good experience. It doesn't mean that I cannot teach a class of 150. I can teach, but I want to have it a good experience. So similarly, with time, internet became very popular. Okay, the number of users coming onto the internet, they are keeping their data on the internet, they're using the internet in their day-to-day life. So when number of users increases, the companies will increase the number of devices. And in those situations, okay, so this software defined networking is for us, not for the users. Okay, so we are the one who has to maintain the networks, right? So when number of devices increases, it is very difficult to manage them. And here we have some of the software defined solutions where software will take care of these devices. Like software in the sense, some controller will be there. So based on that, the monitoring and everything will happen. Okay. So some of such solutions which are offered by Cisco only. So in this course, I'm mainly focusing on Cisco solutions, but there are other solutions also. Okay. So Cisco SD-WAN, Cisco DNAC, Cisco ACI, Cisco Meraki. Okay. So these are some of such things. Okay. SD-WAN is used for managing the WAN connections. So DNAC is used for managing the LAN connections. So these are some of the technical terms I didn't introduce, guys. So I will be talking about this in a couple of minutes. Okay, so ACI, we will be using that in managing the data centers. Meraki is for the wireless, managing the wireless network. Okay. So these are the components. So now coming back to this question on what is LAN and what is WAN. So I will be connecting few of the devices. I think before that, we'll just discuss about the components and then we'll go about LAN versus. I'll make a note of it so that I don't. WAN versus LAN. Okay. So now, see the first device on the internet is the hubs. Okay. So how many of them know about this device called as hub here?
Share all information to every port that connected to the hub.
Okay. Also list your group.
Hub is a mediated device which just forwards the data without any.
Exactly.
Yeah.
Exactly. Okay. See, we as a network engineers, we need to design the networks. Okay. So designing means just connecting the networks. Okay. But how we are connecting makes so much of difference. Okay. So if you just directly go ahead and connect in a certain way, your network will not work in an efficient manner. Okay. For example, let's say I have a PC and a PC connected together. Okay. So is this a network or not?
Network.
So two PCs, two end devices are there and they are sharing the data. So the definition of the network is clear. I mean, they are connected over the wired medium and they are sharing some data. So this is a network. Okay. So if you see here, I can cleanly communicate with this PC. But what if I bought one more PC? So I bought one more PC. So now I wanted to have a connectivity. So what would I do? I'll connect like this. Okay, now PC1 and PC3 can talk. But what about PC2? Some if I want to send some information between PC1, 2, and 3. So then what happens? I need to connect like now both of them. Okay, fine. So now what if one more PC came into play? So now I need to connect these to PC1, PC2, PC. Now they can communicate. So what if I wanted to connect one more PC? So if you see, can you understand the problem which I wanted to showcase here? What is the problem here with this kind of approach?
That if the number of devices will increase, the network will become complicated.
Exactly. The scale is not, we cannot scale our networks. So scale means like when we increase the number of networks, these kind of topologies will not work in an efficient manner. See, for every time whenever I I add a link, what is happening? I need to take the connections between all the devices. So the network will become clumsy because too many cables and you don't know where is where and what is what. So this is not a good kind of topology. Yes, this is a valid topology. You can share the data. This is a network. No one cannot, say something about it. It has all the properties of to become a network. But the management becomes very difficult in this kind of topology. So this is called as full mesh topology. So now I'm doing the same thing, but in a different other way. Okay. So now I'll have a centralized device in between. Now I don't connect the devices between themselves. So now what I do is I'll connect all of the devices to that centralized device. So let's say I have a PC. I have a PC. So I am connecting to that. And I have one more, I got one more PC. Okay. I'll connect that also to the same centralized device. And I got one more PC. And I'll connect that also. So if you see now scaling became very easy. So you can connect how many number of devices just by adding one cable. Whereas previously, so if you see here now, I'll have 5 here also. So now both of them have 5. Okay, both of them have 5. And now here I'll add a device. Okay, so I'm adding a device in order to connect to all of these. So now I need to have 1, 2, 3, 4, 5. So I need to connect 5 links just to bring up this device. Now I'm doing the same thing here. So I'll add a device. All I have to do is just this. Okay, that's it. Just one link, and this centralized device will help. So internally, this centralized device will do all this for us. That means all these connections internally there, right? So that will be done by this centralized. Okay, so this is called as star topology. So along with that, we do have some of the other topologies also, which is bus topology. Okay, what that does means, again, bus topology is not used in these days. Okay, so I'm just giving it for information. So that means one particular link will be there, and on the top of that, every particular device will be connected like a bus. So, but at the board ends, there will be the enders. Okay. So like this is the terminators. Okay. So whatever the device it is, so they'll just connect to that link and they'll share the data. So this is called as bus topology. So here also management is very difficult because this is just a link, no brain, no CPU, no software, nothing is present. So it's like the problem here is if one device sends the data, no one cannot send the data. Just like this. Right now, we are like in this particular topology. So I'm talking. So if you also talk, what happens? It will be a noise. That means people cannot understand what I am speaking and what you are speaking. Okay, so that is the problem with this kind of thing. Whereas in these two cases, it is not there. So here it will not be present. So if you send a packet between these two, other devices can still talk. But here also they will talk. But in this case, they cannot talk because all of them are using the same link. Okay, so if one people are sending the data, the others have to be on silent mode, just like how you guys are. So I'm explaining, you are listening. So when you are talking, I will be listening. Okay, so that kind of thing. So these are the different kinds of topologies. Okay, and all these devices, which is hubs, router, bridges, switches, access point, firewalls, so and so, are these centralized devices used for certain so many purposes. The function might be different, but the end of the day, we use all of these devices other than the end devices, whatever I mentioned, the end devices and these cables, connectors, and all these. The rest are routers, bridges, switches, access point, firewalls, wireless LAN control is for other purpose. Okay, so all these are used as a centralized device with some different functionalities. Okay, so now let's talk about the first device, which is hub. So before going into all of this, I would like to know if there are any questions. Any questions or any comments or anything you are open to ask. Pausing here for a minute. Okay, so I'm taking that as a no, all clear. So I'm going to the first device. Okay, so which is a hub. Okay, so for hub is a first centralized device which was used. So right now hub is not used. No one is using hub. Not used more. Okay, so first device, and also it is a dumb, also called as dumb device. Okay, so why it is called as dumb device? Because it has no software on it. So it is just a hardware used for routing, I mean, sending the packets. And so someone has said the extenders or something like that. So it is just like that. Okay. So now what happens here in this case is how does a hub works? Working of a hub is the next discussion to do. So this is one of the centralized device. So I'm making it as a centralized device. PCs or servers. Okay, it can be anything. So now let's say one PC wants to talk to another PC. So let's say these two PCs wants to talk to each other. So I want to send some data from this PC to this PC. Okay. So now what I will do? So the only link I have is connected to hub, and hub is connected to every device. So I'll send the packet to the hub. Okay. So I'll send that packet to the hub. What does hub do here is hub 2 doesn't know where is the PC. Okay. So let me give a numbering to this so that it is easy to recognize. So PC1, PC2, PC4, PC5, and PC6. Okay. So PC1 wants to send some packet to PC4. So it will include some of the details. So we are going to discuss about that in the OSI model and all, what exactly those details are. So some details, just like when you write a letter to your friend, what you will do, you will write from address to address, all this, right? So you'll write from address here and to address also. So this helps the postman to deliver the letter to your friend exactly. Okay. So similarly, the PC will also include some of the details, but what exactly are those we'll discuss. But it will include. Okay. So it will send it to the hub. But I told you, right? Hub is a dumb device. So it cannot read any of those details. It's just like a person who didn't study anything, so they cannot read whatever is mentioned on the letter, right? Because they didn't have the proper study. So similarly here also, hubs doesn't understand all those details. But what does hub do here is it will send it out of, so except the receiving port. So it has received on this port, right? Except that it is going to send it to all the other interfaces. Okay. So now in this case, what happens is, so everyone, the PC2 will open the packet, PC3 will open, PC4 will open, PC5 will open, PC6 open. So among these four, this packet is for PC4. So PC4 will accept it, and the rest of them will reject it. Okay. So now again PC4 has to send a reply, right? So I have written a letter, so I need to get a reply. So PC4 will also send the reply. Okay. So now hub doesn't know where is PC1 because it doesn't have software on it. So what does it do? It will again accept the receiving port. So it has received on this port. So except that it is going to send it out of all the interfaces. Okay. So now what happens again? The rest of the people will reject it. So he will reject because it is not for him. PC3 also will reject, PC5 also will reject, and PC6 also will reject. PC1 will accept. So this is how the communication was happening on the hubs. Okay. So is it clear? Is it clear?
Yes.
Okay. Okay. Great. So now I told you, right, hubs are not used anymore. So because of some problems. So did you identify any of the problems with this kind of approach? Let me know. Drawbacks or hubs.
Message is broadcasted to everyone.
Everyone.
Wastage
So
of bandwidth.
correct.
Single point of failure.
Single point of failure will have in switches also.
Yeah.
So that is not specific to hubs, it's specific to the design. So inefficient use of bandwidth, that is agreed.
So it creates unnecessary traffic in a network.
Yeah, that's what it also comes under the bandwidth inefficiency. So when
Traffic
the number of
filtration is not traffic filtration.
traffic filtration, how, like, explain that.
Collision, multiple collisions.
Collisions, okay, that also comes. So
Crash
I'm
of bandwidth.
thinking
Security.
exactly. I was
Security.
looking at security. Okay, so bandwidth may. So there, I got few answers. What are those collisions? Then still some said some of the things.
Unnecessary traffic, sir.
Unnecessary traffic, CPU utilization of the devices. Say every time PC2 receives the packet, it needs to use the CPU to process it, whether it is for him or not. Like CPU is a brain, right? So again, the CPU on the end devices, we are unnecessarily, we are unnecessarily wasting it. So it's not like one packet. So see, whenever you send a Google request, it is not like entire request will go in a one packet. No. Okay. So let me show you one of the software. So how many of them here knows about Wireshark?
Yes.
Wireshark. So let me capture the live traffic on my laptop. Okay. This is one of the tool. You can install it. It is free of use. Okay. So you can install it and you can capture the traffic live on your laptop. Okay. So if you see, I am connected over Wi-Fi. So if you see on the Wi-Fi, the graph is increasing and decreasing. But over others, it is not because I'm not connected over it. So I'm clicking on the Wi-Fi and I say, click on this blue button. So here, present here.
We cannot see this.
You cannot see this? I have shared my entire screen, right? No?
You cannot see your other screen.
I think it is said just a window. Yeah.
So now if you see, this is a application called as Wireshark. Okay. So Wireshark, you can install it. It is for free of use. So once you open it, you will see something like this. So I'm connected over Wi-Fi. So that's why the graph is going up and down. Okay. So if you want to capture all the packets leaving on your laptop, so you can click on that Wi-Fi and you can go to this blue button here. Okay. So that blue button, that is a starting point. So you can just click on it and it will start capturing all the traffic. If you see, just in some few seconds, so let me capture it for 10 seconds and see how many packets are going. So 10 seconds done. So now if you see, I have captured it for roughly around 11.65 seconds. Okay, 11.5 seconds, something around that. And how many packets are generated just on my laptop? It's 2271. So now assume this PC as my PC, the PC one. So here I am generating around 2000 packets roughly. So that means if I use a hub in my network, what happens? So all the 2000 packets will be going to the PCs. So PCs have to sit and process those 2000 packets. So that means their CPU is a waste of use. So this is just on my laptop. Let's say on the 6 laptops, in some 10 seconds, it is generating around somewhere around 15,000 packets. So these 15,000 packets are being received by each and every PC. So then how does this make? So CPU is also CPU bandwidth. So basically in one word, resource inefficient. I can say that. So there are many resources like bandwidth, CPU. So many things will be compromised. And the main thing is security. So if you see here in this case, they are rejecting the packet, correct? But what if he's not a right person? That means has some wrong intentions. So what he will do? He will accept the packet instead of reject. Let's say the PC one is handled by the manager, a very critical manager. Okay. So he has some important information and the PC2 is the employee. So instead of rejecting the packet, he has accepted the packet. Although he has the packet. So he can open it, he can see it, he can do whatever he wants. So security is also one of the major concerns which we. So based on these two drawbacks, so what happened was like we have updated. So you guys are saying, right, like even our phones are getting updated. So why not network devices? So we are going from Android 11, 12, 13. So right now it is 13 is what it is going on. So our phones itself is upgrading. So these devices will definitely upgrade with time and the market demand. That's right. With the market demand, only these technologies came into picture. I don't know how many of here have attended my initial session. So I mean, where I was explaining about certifications, I have stressed a lot on this because this is the future. Okay, so based on marketing needs, with the along with the traditional devices, they are developing this SDN solution because market is asking it. Okay, so how does a business work? See, let's say you opened a business and your customer comes up to you and say, hi, I don't want to manage it to manage it manually, I'm taking so much of effort. So I want some automated solution. If he comes up and asks you this question, and if you are not able to deliver it and your competitor have delivered it, then all the business will go to him. So if you want to be in the business and if you want to be a leader in the business, you have to satisfy what market wants, and market wants software solutions. They want to automate everything. Okay, so this is about it. Okay, so now what happens was these were replaced with something called as bridges, but bridges and switches, both of them are same. Bridges have two interfaces, that's it, but switches has multiple interfaces. So I'm directly going to the switches. Okay, so now what is the difference between the hub and the switch? So I'm taking the same scenario. I'm taking a few pieces here. Now the same topology but with different device. Now I'm using a switch. Okay, switch has a software. Okay, so switch is nothing but hardware. Like hub only have hardware, but now this is an intelligent device. Why it is an intelligent device is it has software on it. Okay, and it uses something called as MAC address to identify the devices. Okay. So what is MAC address and all? I'll discuss about it. It's just some piece of information which is assigned to each and every device. Okay. So now what happens is switch maintains something called as MAC address table. Maintains a MAC address table. Okay. So what is this MAC address table or MAC address which I have mentioned? So one more new term I have introduced, right? So MAC address is nothing like a name. Okay. So if you see here, we have 27, 28 odd participants here. So if I want to talk to one person alone, how would I ask him or how would I call him or how would I identify him? By his name, right? So here also, we need to filter the traffic. So if you see here, so I say PC, but like when I'm explaining, I say PC, but which PC is that? Even you guys are confused because there is no proper naming convention here. So everyone are PC, but when I said PC, it can be this, 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 or it can be this. So it can be anything. So in those cases, by just adding some information like this, the process will be easy for us to identify. C3, PC4, PC5, PC6. Okay. So now when I say PC6, you know, okay, this is the one which I'm talking about. So similarly, every device have something. So here I said PC, PC, PC. So every device will have something called as MAC address and IP address also. So how to check that? Okay, how to check that? What is the MAC address of that your particular device is? If you are using
Get
a
Mac.
Windows PC, just go to your command prompt.
Get Mac.
Just type ipconfig/all. Okay. And if you are some Ubuntu or I mean Linux or Mac users, so just type ifconfig/all. Okay. So command prompt. So you can just go here. So here you have to use a terminal. Okay. So if you are using Linux or Mac terminal, in the Windows it is this. So here all you have to do is go to IP. Let's type this command ipconfig/all. Now you'll get so many details regarding it. So right now I'm connected over Wi-Fi. So I'm looking at those details only. So these are my details. And if you go here, there is something called as physical address. And this is my computer from Mac address. And similarly for your PC also, you will be having some sort of MAC address like that. Okay. So more about that we'll discuss, but I'm giving a high level overview. Okay. What is MAC address? How it is been identified? How it is been assigned? What are the different kinds of MAC address? All these discussions will be done. Okay. So basically now what does the switch do here is switch will make a note of all these MAC address in a table called as MAC address table. Okay. So let's say the MAC address, just for the example, the MAC address of these devices are
Sir, it is possible to change MAC address of system.
Can you please repeat?
It is possible to change MAC address of any system.
It is possible, but it is not recommended. One second.
I think it's not possible.
Sir, he asked it is possible to change the MAC address of the device?
Yes.
Sir, it is built while manufacturing?
It is built by manufacturing, but there are ways. Hackers use many ways to manufacture. See, it's a piece of software. Let's please be on mute. People who don't have any questions. Everything is possible. Okay. So, but the normal devices, it is not. Okay. As per the software, it will not. It is not. But if you install, say, some of the softwares, excess softwares, yes, you can change. You can do whatever you want. Okay. So in the normal networking, it is not possible, but with some help of some tools, So how many of them knows about Kali Linux here?
Yeah.
How many of them have worked on Kali Linux? Worked, or have some experience on that. They know about all of these ways of changing the MAC address, changing the things. I have heard some people said we are so interested in security. So people, you should learn Kali Linux. Those people who said, I'm so interested in security. Okay. So now what happens is every particular device have MAC addresses. So I'll just write them here. Mac 3, Mac 4, Mac 5, and Mac 6. Okay. So switch have the ports. I mean port numbers also associated to that, just like FA0/1. So there will be a numbers to these ports. So I'll show all of this. Okay. So every port. So switch has 24 ports and 48 ports. Every port will have something. So for FA0/1 and FA0/2 and FA0/3. Okay. And FA0/4, FA0/5, FA0/6. Okay. So some naming conventions will be present like this. Okay. So now what happens is which will store this. Okay. So on my FA0/1, Mac 1 is present. Okay. On my FA0/2, Mac 2 is present. On my FA0/3, it will learn about all of this. It will populate this table like that. How it will do that? That is another discussion to do it. But now with this help of this table, Mac 4, FA0/5, Mac 5, and finally FA0/6, Mac 6. Okay. So with this help of this table, it is going to segregate it. Okay. So now let's recreate the same thing. PC1 sending the packet to PC4. So I told you, right? Whenever we write a letter, we'll include the from address and to address. So now in the from address, so we are sending in from PC1. So in the MAC address field, we'll write it as MAC1 because PC1 is using MAC1 as its MAC address. So we need to send it to PC4. So now in the to address section, so now what happens is MAC address, in the MAC address field, it will be MAC4. Okay, in the to address field. Perfect. Okay. So now this letter will be going to the switch. So now we'll be sending this letter to the switch. Okay. So now switch will open this packet and it will check, okay, it is coming from Mac1, it needs to go to Mac4. So on which interface Mac4 is present, it will go. Okay, Mac4 is present on FA0/4. So it will send it only to that. So now if you see both these problems which we have discussed in the hub, the resource inefficiency by like bandwidth, CPU and all is not present, and the security is also not present. Now the other devices are not sending any of that. Okay, is it clear now? Any questions, ask me. I can see a few other people raising their hands. So now you can ask any of the questions if you have.
Uh,
Yes, anything? Yeah, please say.
in case of switch,
it also broadcasts when you send the packet.
There are some cases, okay? So when this table is not populated, then it will do it. But once this table is populated, then it will not do it. Okay, so there is a separate section called as MAC address learning. There I'm going to discuss it. So now I wanted to discuss about the switch function at a high level overview. This is just the day one, right? So my intention is to explain that concept. Deep level of understanding will be discussed later. How this table is built. So right now, if you see, I have populated by seeing it here, but how does the switch populate in the switch, like the software? That is not possible. Nah? Like that is possible, but how is that possible is what we need to understand. So that
First
is,
time it will broadcast.
yeah, there is a process called as MAC address learning by switch. So there's a section for that. There I'm going to explain about all of it.
Sir, FA01, FA02 means, sir?
Fast Ethernet. So the name of the Ethernet. So based on the speed, so if we have a discussion on this also, but I'm giving again, I'll give some overview. So switches have a speed associated. Okay, so when you're taking any of the links, you will take the speed, right? Like 300 Mbps or something like that. So this is when you take a link, but when you take like the cables, those physical cables, so they comes in set of 10 Mbps or 100 Mbps or 1 Gbps or 10 Gbps, 40 Gbps, 100 Gbps. So this is the maximum. 400 is a maximum thing as of now. Okay. So these are called as Ethernet cables. These are called as fast Ethernet cables. These are called as gigabit Ethernet cables. These are called as 10 gigabit. This is 40 gig, 100 gig, and 400 gig. Okay. So when I say fast Ethernet, it's a 100 Mbps link. So this is a 100 Mbps link which switch has, and it is the first interface. So 0/1. Okay. So this is the second interface with 100 Mbps only. So FA 0/. So just a naming convention, that's it, which is present on the switches. Others, any more questions before going into the next topic, next device? Any more questions? Get it clear? Okay.
Sir,
Yeah.
so there is like for switch there is drawbacks or not?
There are, but still we are using, so they are okay to have those drawbacks. Some drawbacks are there, and we have solutions for that also, which have some drawbacks. And we found the solutions to those also. So it's okay. So not a major things like what we have in the hubs. So based on these, we have completely stopped using hubs, but now we're still using the switches. So that means all those problems which we have are still okay to have. Okay. Okay, cool. So sir, your whiteboard will be available as PDF. Yes, PDF I don't know, but images. I'll download this image and upload it to your portal. Definitely yes. Once the session, by the end of the session, I'll do that. Okay, so now assuming that there are no more doubts, I'm going to the next device, which is a router. Okay. So this is where I'll take the term which is LAN and WAN. This term, and explain it now. What is LAN and what is WAN?
Wide area network and local area network.
Yeah, correct. Okay, but what exactly is that? If someone asks you to explain that, what exactly is that is what I'm going to say.
LAN is for small area and WAN is for wide. It covers countries.
Exactly.
WAN is a bunch of multiple router.
Exactly. Still go on. Good. I'm hearing some answers.
LAN is connection of multiple devices. WAN is connection of multiple LANs.
Okay, great.
LAN, for LAN, we can say private network.
Okay.
Within the office or WAN means is internet public.
Okay. So do you know the difference between private net and public net?
So private is free, and WAN we have to pay for.
Can you please repeat? I'm sorry.
So for private network is free. We can set up easily, and for WAN we have to pay for it.
Okay, okay, got it. Cool. Good. Still any more answers? Based on your research, which you have did, LAN, private network.
Sir, LAN is only
What?
LAN is private network, still low. The communication happens within the network itself, and WAN, if you go means the LAN will actually comes in communication with public network.
Okay, got it. Okay, so I have got multiple answers and everyone are correct. Okay, there is no wrong answer which on what you have said. So, but to keep it and summarizing everything, so router is a device which divides the network. Okay, so now what is a network? Network is, let's say there is a building. Okay, so now one more building is there here. Okay, so now what would I do? So I will take some of the devices here. So I'll take some of the devices here. So some PCs. Okay, paste. So some PCs are there in building one. So all of these will be connecting via switch because that is a centralized device which we use in a LAN. So this is called as a LAN, guys. So all the devices in a network are collectively called as a LAN. So if you see all the devices in the building one are called as a LAN. Now connecting these two LANs is nothing but a WAN. That's it. In simple terms. Okay. But it should not connect a very close thing. So it's like not like buildings and all. So this is, let's say, branch one. This is one LAN on building one. Okay. And we have one more, the same thing. So some more, since this is one more LAN. So it's not like connecting these two, you call it as a WAN. Okay. 1 second. So geographically, they have to be in different places. Okay. So in branch one, we have two buildings. So that means this is one LAN. And this is another LAN. Okay. Both of them are connected to the router, which is sitting here. So router is the one which manages all these things. Copy, paste. So this switch is also connected to the router. And the ones. Okay. So perfect. So we have connected two networks. So I'll take an ISP connection. Okay. So now I'm connected to the internet. Okay. So all of these devices. So LAN, and this is where the WAN part comes into picture. So connecting the devices between geographically, like connecting the devices and the networking components which are geographically very far apart. Okay. So internet or the ISPs is the one which does that. Okay. They will connect the devices using this thing. I don't know how many of them know about this world map of optical. So this is how the things are got connected. So all of your data is being flowing like this. So we are in India, right? So India, we have 4 points. One Mumbai, somewhere in the Kerala, Chennai, and one in here. I think submarine cables. So this was in 1989. So with time, this can you guys hear the sound also? My sound. So the number of cables were only 4 in 1989, and from there, this part of area is getting increased. So I told you, right, first of all, this was increased. This was between the America and Russia. So some part here, they were lines, and then from there, they are getting increased. Now India got connected to internet. So in 1990, in 1995, that is where India got connected, and the connection went from Mumbai. Okay, so this part is from Mumbai. So it is going to south part and all. This is the current connectivity of the cable. So all of your data is being flowing through these cables only. So this is the WAN. Okay. So this is called as a WAN connectivity, and these are maintained by the ISPs. So the price or the amount which you are paying to the ISPs is for maintaining these cables. Okay. So if there is any problem, so all these cables are, if you see, going through the oceans only. So if there is any problems and all, so these ISP will maintain and they will charge you some amounts of thing to it. Okay. So this is the internet. Okay. And how these cables are laid is also, it's a very difficult task. Optical cable lay. So a ship like this will be going, and it will be, so this much big cables will be there. They'll be laying off in this manner. So in the down, there will be something, some hardware. I don't know what exactly is that. So that will be present, and that will lay, and the ship will go like this. So on the top of the ship, the cables will be embedded like this. Okay. So they will they have laid all of these things, and when there is a problem, they'll go deep into the say and they will inspect everything, and they'll get it fixed. So if you see here, they are doing some troubleshooting on this particular. Okay. So this is how the people maintains and the people get communicated between. I mean, all the data is going through. This is how it is going. It is not going wirelessly. Okay. So people, wireless is only within the LAN communication. That means within your building or within your room. That's it. Wireless we cannot use for intercontinent communication. So at some point, all the wireless connectivity should be converted into wireless, and they should be going through these cables only. Okay. So this is about the WAN. So WAN is connecting the networks which are geographically apart. So here my branch 1 is there. So let's say it is in there in one of the city, and branch 2 is there in another city. Okay. So the same connections goes like this, the router. So we'll take an ISP connection there also. So here Airtel. So Airtel. So in let's say Hyderabad, and this is in Delhi. So there also will take Airtel or Jio or anything. So Airtel, Delhi. So between these two, they have the connectivity. So now this is a WAN. This is a WAN. This is a LAN, and this entire thing which we have connected is a WAN. Okay. So and in this entire thing, we use something called as routers. So what are these routers? So if you see, switches are used to send the traffic from one device to another device. Okay, so if you see here, this is where we have learned, right? If I want to send the traffic from one device to another device, so I'm using a switch. Okay, but whereas the routers are also used to send the device, the communication of the data from one device to another device. But switches, the source and destination will be in the same network for the switches. Okay, so if PC1 wants to communicate to this PC3, so then the flow of the traffic is it will go to the switch, and switch will send it to the PC because switch knows where it is. But when PC1 wants to communicate to, let's say, PC5, so now the switch doesn't know where it is. So now what happens is when we send the packet to the switch, switch will not send, we'll directly send it to the router. Okay, so we'll send it to the router, and router know where it is. So router will send it to the switch, and switch will send it to the PC. So that means router comes into picture when two devices wants to talk to each other, which are in two different networks. So connecting the devices in two different networks is the function of router. Okay, so just to write router connecting the devices which are in two different networks. Okay, whereas switch is also used for connecting the devices, but which are in the same network. If we connect any device which are in different network, they cannot do it. Okay, which are in two different, not two different, two same network. Okay, so this is the difference. So we have completed about routers, switches, and hubs. Bridge is a previous version of switch, the same thing. But here in the switch, you have these many interfaces, right? Like Wi-Fi 0/1, 2, 3, 4. But in the bridge, you only have two interfaces. That's okay.
Sir, router knows exactly where the PC5 is.
Router doesn't know where exactly the PC5 is. Router know in which network PC5 is there.
Okay.
It knows about the network. Okay, but the exact device. So what happens? The router will send it to the switch. Switch will send it to the PC5. Switch is directly connected, na?
Yeah. Okay.
So router will. Router also maintains some table. Okay.
Okay.
So which is called as routing table. So in the routing table, it will know. Okay. So PC1 to PC4 are in network 1. Okay, and so that network is connected to, let's say, G0/0. So again, the router also have some names to that. So then PC5 to PC6 or 8 are in network 2, which is in G0/1. Okay, something like that. It will maintain. So now when the PC receives a packet from PC1 to PC5, 1 to 5. Now what happens? So it needs to go to 5. So 5, okay. 5 is in network 2, and that network is connected to G0/1. So
Okay.
this is G0/0 and this is G0/1. So now it will send it out of this. And switch will receive it. Switch will check, okay, to exactly where it is present. So that's how it goes. Okay. So
Okay.
router will have the network picture, like as a group. Okay, let's say for this, I'll give an example. So in your organization, your manager will know what exactly you are doing, but the director level, the one above your manager, he will know in which department you are. Let's say you are in account department, you know you are in accounts department, but he doesn't know what exactly you are doing in accounts department. Your manager will. So here the switch is a manager. Okay, and your director is a router. So when some project comes to your company, which is related to accounts, so he will not check whether you can do it or not. He will just forward it to the accounts department. And your manager will check whether you can do it or not. And he will assign it. So similarly here.
It's maintaining a routing table, right?
Exactly. So router maintains a routing table, which maintains a MAC
MAC
address.
address.
That's it. Okay, cool. So in that case, we'll go to the next particular one. So end devices are nothing but all the end devices, the phones, PC servers. So there is anything about that. These are the devices which we need to serve. Okay, phones will ask the data, servers will serve the data, PC will ask the data, again servers will serve the data, laptops. So these are the end devices. Okay, we have our end goal is to connect all of these end devices. Okay, so coming to the access point. So here we have seen about the wired connection, but how do we connect the wireless? Connection. So that's where the access point comes into picture. Okay, the access point comes into picture. So access point is a device which is used for wireless communication. Okay, connecting the devices wirelessly. So I told you, right, there should be a centralized device. So for the wired connection, these are used for wired connections. Wired. This is also wired. This is also wired. So this is used as a centralized device in wired connection. So the access point is a centralized device, but it is used in wireless connection. Now comes to the firewall. So firewall is mainly used. See, till now our primary goal was to connect the devices. Never ever I had discussed about the security. One part I have discovered, but still here also we can do some things and we can hack the systems. Okay, so how to stop all of those is by using something called as firewall. Okay, not only firewall, even on the router we have some features. Okay, but this is like hardcore security to our network. You don't want to compromise any of your data, go ahead and use a firewall. Okay, so this adds the security to our devices. So end devices I already said. So Nick, I'll talk about this later in the course when I was discussing about the MAC addresses. So I'm just skipping this for now. Okay, so will be discussed during MAC address learning. Okay, so cables also we have a separate section. Once I complete the OSI model, there I'll explain the cables, connectors, NICs, all these things. These three things, there's a separate module. So I'm skipping all of these for now. Okay, so wireless LAN controller. So this is the one. So see, access point will be having many devices in our network. Like if it is a large scale company like Google, Facebook. Okay, so in those cases we'll have many access point like 10,000, 20,000, 30,000, even more also sometimes. So how to manage those many access points? See, if you see the access point case, the policies will be changing every now and then. What are these policies? Policies are like the rules on which traffic should be allowed and which traffic should not be allowed. Okay, so in those cases it is very difficult to manage. That means how do you push a command to the device? First of all, you have to log into the device, type the command and cross-verify it and do it. But the wireless LAN controller will help us to do all of this. What I will do is, let's say I have some 10,000 access points. Okay, so I have some 10,000 access points and so on and so forth. Now I want to push everything. So usually what should we do here is, I should log into first this device, push that policy, commands related to that policy, and exit. Again, log into this device, command, exit. Log into this device, command, exit. Log into this device, command, exit. Log into the device, enter the command, exit, exit. So on and so forth. Okay. So now what happens with the wireless LAN controller is the same number of devices, but now We'll do the same thing in a different way. So now I don't log in all of these many times. So now what I'll do is I'll log into one thing called as wireless LAN controller. So this LAN controller will have the connectivity to all the access point. So now whatever I want to make the changes, I'll say it to the wireless LAN controller, and LAN controller will push all of those changes to the end device. So now my input only goes to wireless LAN controller. Wireless LAN controller push it to everyone. So now my managing, laptop, these devices will work faster than us, right? So some of the manual tasks, these devices are faster than us. So let's say if I take 10 minutes to log into 10 devices, it will take 10 seconds to log into 10 devices. The speed is increased, the management is easy, and all these are very easy. So for this purpose, we use something called as wireless LAN controller, which is also called as WLC.
So how many access point we can connect in a single WLC?
Depends on hardware. There are many wireless LAN controllers. Okay. So depends on the hardware it is decided. Okay. So now coming to the other SDN solutions. So at this point of time, as this is a day one, what I can say is just like how we did in the wireless LAN case, like instead of logging to every time, we pushed it to wireless LAN controller, and that is pushing it to all of these devices. There are many parts in our network where we can automate the manual task. And these solutions are helping us to automate these tasks. As I said, SD-WAN is for WAN. So DNAC is for LAN, ACI is for data centers, Meraki is for wireless network. So in each of the things, there are many things which we can automate, and these solutions are helping us to automate that part and do the same job which we are doing, but in lesser time with few errors. Okay. So with this, the day one of our class comes to an end. Okay. So we have actually discussed all the network components in this particular section. We started with what is internet and what are how the internet came into picture from 1980s to today. And then we went to the components. We have discussed about hubs first, and we identified few of the problems, that is resource inefficiency and also security. So as a solution to that, we got the switches. The switches uses MAC address table to identify the device, and it will solve the two problems which we have identified in the hubs. And later on, we have discussed about the routers and LAN and WAN. And that is a main core part which we have discussed. And along with that, we went up one step and we discussed about the access point, wireless access point, wireless LAN controller, and the firewall. Okay. So this is the introductory session. So okay, all of you guys, you can install this particular lab called as Packet Tracer. Okay. So please install this on your laptops. You can find how to install it. You can find it on YouTube. So just go ahead to the YouTube and find how to install Packet Tracer. There are many videos which can help you. Okay. So this is the one which I use the most in this particular course, and it is free of cost. You guys also can use it. Okay, and practice once I complete the session. Okay. So tomorrow I'll say how to use this particular tool. Along with that, if you are interested, you can download the Wireshark also. If you are interested, not a mandate. If you are interested. Okay. So two things, discussions, tools. So one is Packet Tracer, another is Wireshark. So whoever wants it, they can install these two. Now it's time to download this particular thing. Export image, high resolution, desktop, new folder, CCNA, Jan, week, days. So now going on to your thing. So this is how it looks. It's a image, not a PDF. You can convert to PDF if you want. So whatever I wrote, everything will be present. can use it for reference. So resources again, files, upload, CNA, desktop using the
So yes, as I mentioned, this is our day one for CCNA. So today, mostly we'll be discussing about the basic of CCNA. So what exactly are the concepts and what exactly are the things that or what exactly are the devices that we'll be concentrating on in this whole session. So that is like our 40-day session. So first of all, the things that you have to know are the different kinds of networking devices. So let's start over to that. Okay. Okay, just before that, these are the different topics that we'll be covering, starting with network fundamentals, the network access. Then we'll be moving on to IP connectivity and services. Then we have security part of it. And a little bit of automation and programmability. We won't be covering too much into automation and programmability because as far as CCNA is concerned, what we need more here is about the networking side. So automation programmability will be there, but not to the highest end of it. And then by the end, we'll be having hands-on labs. And for hands-on labs, I would suggest all of you to make sure that you have your own system, not your office systems and all, because you might have to download a couple of softwares and install it inside your system, like Cisco Packet Tracer, etc. Okay, so yes, let's start with today's session. First of all, network fundamentals. So inside network fundamentals, the first topic that we'll be covering is about network components. So what exactly are network components? So yes, when I say network components, the basic thing is that what all kinds of devices that are being used inside to create a network. As simple as that, just as the word suggests. Okay. So some of the examples you might be familiar with, like routers, switches, even your computer can be considered as a network component. Reason being, it is somewhere, like it is part of that network which we are using to access a particular set of resources, right? Without that computer, there is like you can't see what you're accessing from this network. So these kind of things are known as endpoints. Your computer, your mobile phones, all of these are endpoints. Whereas these switches, routers, modems, all those kinds of stuff are known as access points. So you have your endpoints and your access points. We'll be discussing about that in the coming up slides, but I'm just giving you an overview. So yes, that's basically network components. So we'll be looking into different kinds of network components and how they are being used inside a network. So the first component itself, which comes to any network engineer's mind, first one is router and second one is switch. So these are the major components that's always required. Because if you want to have some form of security or something, these two are highly required inside a network. So yeah, we'll jumping into it. So the first network component is a router. So what is a router? And what is its function? So yes, basically, a router is a device that connects and routes data between different networks. What that exactly means is that, let me just show you 1 second. Let's move this from here. Just reduce the size. Sure. Anyway, yes. Okay, so yes. Imagine we have a network where we have to connect, let's say, 3 computers together inside the network. So we have system A, and in between the system A and system B, we are having multiple networks for different systems and all. So if you want to connect from A to B and A to B and C and everything, we'll be using something called a router. Keep this as like a router. The reason why we need this router is because without that router, what happens is if you're sending some data, we won't be able to understand whether it is going from our, let's say this is the sender and receiver. So without this router, if the A is sending something, it won't be able to know whether it is going to the intended receiver or to someone else. Okay. So for that purpose, what we do is we'll be having something called an IP address. So let's say for this, it's 192.168.1.5. Here we have 192.168.1.3 and 168.1.9. Okay. So the IP address of A is here. The IP address of B is this. So what basically happens is when any system is connected to a router, the router will automatically provide them with this IP address and it will be stored inside a table over there. Okay. And then when A wants to send something to B, it will be mentioning, I want to send this particular data to this particular IP address. So it will be sent to the router. Router will be finding out where that particular IP address is and then forward that data to the right receiver. This particular thing is known as routing. Like there are networks when we have to use multiple routers and we have to jump from one router to another router. Those kinds of concepts we will be covering. But for right now, this is the basic idea that you need to get. When you're sending a data from one location to another location, to make sure that it reaches that particular location, we need a router to give it the right details or the right make it understand the right path. Okay, hope that was clear. What a router is.
Yes, sir.
So yeah, so it has like this is the basic function of router, but it does has multiple functionalities which we are going to go through. Some of them are mentioned here. The major ones are mentioned here, like packet forwarding. That is, the router has the ability to forward these sets of packets. These packets are basically the data sent from one location to another, which are divided into small pieces. Because we won't be able to send that entire data in a single packet because the size will be too large. So for those purpose, this entire data will be cut into small pieces and then would be sent through a set of packets and they will be forwarded from one location to another location using a router. And routing decisions, that just means like the router decides which path to take for sending this particular data. And network interconnection. So network interconnection is something, okay. So the network interconnection basically means that by using router, you'll be able to connect multiple networks. So if you have a network, we have like 5 systems in one network and 10 systems in another network. If you want to interconnect them, we can use a router and connect them together. Okay. So that is something called network interconnection. We'll be discussing more on the different types of its functions. So yeah, here we have it. So yes, first of all, we have packet forwarding for router. So packet forwarding, again, as I mentioned, this router forwards data packets between networks based on the destination IP address. That is our intended address. In earlier case, it was D. From the example I showed earlier, it's basically means if you want to send A to B, this packet forwarding makes sure that it reaches B. Okay. The next top point is network address translation. So these routers can perform NAT or network address translation to map private IP address to a public IP for internet access. For example, let's say, all these websites and everything that we access, these are basically some data stored over someone else's computer or someone else's server. So over there, if you want to access it, you saw earlier when I was giving an IP address, these kinds of IP address basically is like 192.168 dot something something or 10.6.5.2, something like that will be addressed. So you won't always be remembering the exact IP address of the data that you have to access. So instead of that, what people do is people will be replacing these IP address with some kind of domain names or URLs. The easiest example that you can understand it would be google.com. So this google.com is basically an IP address which is converted into a domain name. Okay, so when we are giving this domain name, what happens is that this request is going to that router, and router will be translating this google.com into a private IP address. Okay, like 192.168.1.7 or something like that. And it will be requesting data from that particular IP address. So all the data from that server will be collected and then it will be sent back to us. Okay, so that particular way of converting this public IP into this, like able to translate this public IP into this private IP is known as network address translation. Okay, hope that's clear. And next, in case of any doubts, please feel free to come off mute and ask, okay? Okay, so yes, the next one is something called routing. Yes. Yes, we can have other kinds of public IPs other than domain names. I just mentioned that for easier able to understand much faster if you mention just domain name. So yeah, your question is pretty valid. You can have other kinds of public IPs. For example, let's say at your home, if you have a Wi-Fi connection. Okay, so if you go to your browser and search what is my IP, you'll be getting a particular IP. Okay, if you just go to Google and just search, if you have some doubt, just go ahead and search it on. So you'll be getting an IP address. That particular IP address is your public IP. Okay, that would be in the same format as you mentioned right now. Let me just see if I can. Okay, what is my IP? So you see something over here, right? That is my public IP, your public IP address. Okay, that's my public IP. And at the same time, can go to my CMD. And I open my CMD. Give me a second, it's loading. And here you can just find your private IP. Right. So you see something over here, IPv4, that's my private IP. Okay, so my public IP is something that is given to me by my ISP or my service provider when I'm connecting from my Wi-Fi to the outside. And this particular IP address is given to me from my network device. This is the internal. So if I have my mobile connected to the Wi-Fi and I do the same thing on my mobile, I'll be able to find the private and public IP for that as well. Okay, got the basic idea? From the router, the connection goes to outside, right? That part is public IP. When the connection is coming to the inside, for all the devices inside our houses, that connection is known as your private IP. Okay, that was a good question. Okay, so I hope you got the idea on that. And yes, moving to the next one, routing. So this is what I just mentioned earlier. Routers like make decisions on like which path it has to take to travel between networks using routing protocols. So yes, let's go on to that. So basically what it does here is that we draw something. So this is our computer A, and we have computer B, and we have let's say 3 routers here: router 1, router 2, and router 3. So computer A is connected to B in 2 paths, that is R1, R2, and computer B, and R3 to computer B. So basically what this routing does is that, sorry, my bad. I think we need one more over here. This is our computer A, and this is our router 4. Okay. So basically what it does here is that computer A will be connected directly to a router. Okay. And when it's connected to this router, and this router will be having all the devices connected to it and all the paths it takes. All this data will be stored inside R4 in a table. Okay. We'll go further into that later. But at the moment, yeah, let's assume that R4 has this table with all the data of all the connections happening from that R4. And we are sending a piece of data from computer A to computer B. So what R4 does is that R4 will be finding which is the shortest path. In this case, it has to go to R1, then R2, and then computer B. But in this case, it goes to R3 and directly to computer B. So this is the shortest path. So R4 will be able to make the choice of choosing the shortest path from computer A to computer B. Okay. This decision-making ability is known as routing. So this decision-making will be dependent upon multiple aspects, all of them which we'll be covering soon. So I hope this is clear, routing is clear.
So, sir, if I understood correctly, in router's mindset,
Yes, sure, sure.
the shortest path is the one which has the least number of routers connected in between the source and the destination.
Exactly, yes. The least number of devices, not just routers.
Routers of the devices, which can be switches, routers.
It can be switches, routers, hubs, anything.
Okay. I was thinking just routers, but this clears my question. Thank you so much.
Yes, it can be any kinds of access point devices. Okay. If you are having a computer connected to this router, that doesn't count. That won't be counted. But in between this computer and computer B, if there is any kind of
networking device.
Yeah, networking or access point devices.
Oh.
Okay. Again, that was again a good question. So hope we are clear on them.
It will only store the IP addresses of routers, or also it will store the IP addresses of systems.
Everything will be stored. IP address of system, everything will be stored.
Okay.
Like it will be matching that its IP address and its MAC ID. Okay. Yeah, we'll be going through that particular table details. It's called ARP. We'll be discussing that topic. Like it's actually a big topic coming up. So yeah, we'll be discussing about that. No worries. Okay, hope we are clear on that. And then we have interconnecting networks. Yeah, that's what I mentioned earlier, where you can connect multiple networks connected to multiple devices, and you can bring it all together by using a single router. And then subnetting. So subnetting is a process in which, let's say, a router can divide larger IP networks into smaller subnets for efficient address allocation, and you'll be able to easily group different sets of network, different sets of computers as different networks under the same router itself. So by using one router, you'll be able to divide the devices connected into different networks. So let's say if you have one router, inside that itself, you'll be able to run multiple networks. Okay. That particular method is known as subnetting. Again, an important topic that we'll be covering. We will be going through how this subnetting can be done. And all. So then we have firewall. So routers can function as basic firewall by filtering traffic based on rules mentioned by something known as access control list. So it's kind of like, let's say this router will not pass a specific types of protocols, or specific types of connection will be can be avoided by using this ACL or access control list. So in that way, the router can act as a firewall. Then we have gateway. So gateway means that the routers serve as default gateway for devices in a network, directing different traffic from outside or some other local networks. So in the earlier example, you could see I was connecting that computer A to router 4, right? Basically just that. That router acts as a gateway for this particular computer. And then we have DHCP, or Dynamic Host Configuration Protocol. So here the routers can provide IP address and network configurations to device inside a local network. So this is what I just shown you. You could have seen when I opened my CMD, you could see one IP address over there, like private IP. That is done by using Dynamic Host Configuration Protocol. That particular modem that I'm connected to, it's automatically giving me an IP address. So any device in my home that is connected to that Wi-Fi will be having different IP address, which is automatically given by that particular modem, or in this case, router. Then we have logging and monitoring. So these routers generate logs that allows monitoring for network traffic and device performance. So basically, whatever events that happens in case of any kinds of troubleshooting or anything, all those data will be logged and monitored by our router automatically. Or if you want, you can also have the option to set up different kinds of alerts based on thresholds and everything inside these kinds of routers. And yes, next, I'll just go a bit faster because this is basic factors of a router. So in case of any doubts, feel free to ask in between, okay? So security, again, this router enhance network security by controlling the traffic flow, and it prevent any kinds of unauthorized access. Basically what we mentioned in firewall and firewall about ACL. Then we have load balancing. So some routers support load balancing to distribute traffic across multiple links or paths. So basically what happens is if you're having too much data to send from one point to another point, it will find all the different paths that are available and send. It will divide the data into small pieces, and all the data will be sent through multiple ways. So by doing so, the data will be sent faster than it would have gone if you are sending it in one particular path. That particular method is known as load balancing. Then we have virtual private network, or VPN. So here routers will establish this VPN connections for secure remote access or site-to-site connections. Basically for privacy requirements, you'll be using VPN. So yeah, these routers has the option to set up these kinds of virtual private network to make sure that there are no external entity that is looking into your activities. That is the requirement, main requirement of virtual private network. And next we have dynamic routing. So here the routers use dynamic routing for.
Sir, hello, sir.
Yes, go
on. Sir, I'm Deepak.
Okay, go on, Deepak.
Yeah, sir. Access point can do routing or no?
So access points what I mentioned by access point is that different devices, like there are different devices under access point. So for example, router itself is an access point. Okay, so that can do routing, and layer 3 switches. So layer 3, yeah, layer 3 switch again is an access point. So there are two types of devices. One is access points and the other one is endpoint. Okay.
Yeah.
So
we are
sorry.
seeing here some access point is there. We connect Wi-Fi, so it cannot do routing.
Not all access points. No. For example, let's say layer 2 switches. It is an access point, but it cannot do routing. I'm not saying all access points can do
And
routing.
also,
yeah.
And also firewall can do routing, right?
Firewall has the option to do routing, yes.
Okay, sir. Thank you.
And what I mentioned earlier, what not access points can do routing, like routers, layer 3 switches, etc. These are access points which can do routing. There are other access points like your normal modem or your layer 2 switches. So these does not support routing. They only have the option to like connect and use it. So whatever data sent to it could be sent to multiple devices. So it doesn't actually have the option for routing. Okay, cool. That was clear on that. Then we have, yes, dynamic routing. So here the routers use dynamic routing protocols to adapt to changing network conditions. That basically means that if you're adding more routers or more switches into a network, that means the table that we mentioned earlier has to be reset because there are new entities that are being added to this particular network, right? So that means the pathways or the distance from one computer to the other computer might have already changed when you're introducing new routers and like switches, hubs, or anything. So again, so this dynamic routing can be done using routers. So router will automatically identify all the devices added and create a new table. The last one is static routing. So routers can be configured with static routes for specific destinations. So this is mostly done for like high secure systems or high secure networks, which basically means that you have to set up a particular path for sending data from one system to another system. Whatever changes or whatever systems are added in between, the router does not care. If you are setting it up for static routing, it will only follow the path that is programmed into it. That particular method is known as static routing. It's mostly used in financial establishments like banks or military purposes, etc.
For more security.
For more security, exactly. Okay, moving on. And yeah, these are some of the hardware components. Yes.
Sir, what the difference like router and switches are both are same or it's a difference, sir?
There are difference. There are definitely difference when it comes to like routers and switches. So as I mentioned, the basic requirement of a router is like the routing purposes and all for like being able to decide where we have to send this data and everything. When it comes to switches, so it is let's say it is basically used to divide a network into small networks. That is the main requirement of switch. Although it does support sending data from one location to another and all those kinds of stuff, the major requirement of switch when it comes to it is to divide networks into divide network into small subnets. That is a major requirement of switch. And switch it has like a lot of different kinds of aspects. There are multiple types of switches, like as I mentioned earlier, layer 2 and layer 3, which I think we'll be discussing in the coming session. Would that be enough, or do you need to get a complete idea right now? So let me just give you a small on to it. So as I mentioned, there are like different types of switches. So this layer 2 switches basically does is that it will make sure that the connection, or it will make sure that there is some kind of just give me a second. Yeah, so layer 2 switches basically does the connection part. So if you are having like 10 systems connected to one particular switch, and you want to like divide it into two small networks. So what you basically do is that you have the option to access its Ethernet ports.
Sir, we got able to see your drawing session, sir.
Okay, 1 second. Let me just give you an idea. So this is our switch, and we are having, let's say, 6 system connected to that particular switch. Okay, so this is computer 1, computer 2, computer 3, computer 4, computer 5, and computer 6. So all of them are connected to switch 1. Okay, so what we can do is we can just connect one of our endpoint devices. It can be a laptop, something will be connecting onto that switch. It will have a username and password. By using that, you'll be accessing that particular switch. Okay. Once you access that switch, what you can do is that we'll be accessing something called a CLI, command line interface. And inside that, you can access different ports of that switch, because all these systems are connected to different ports inside the switch. Okay. And by accessing these ports, you'll be able to make changes to its configuration. And in that configuration, you'll be setting, let's say, this particular port, this, and all these 3 ports will be adding it under VLAN 6. And according to that, they will be given different, let's say, IP addresses. Either you can statically give them a particular IP address, or automatically when you are giving this VLAN ID and you are starting that particular switch, automatically different sets of IP address will be given to all 6 computers. So what happens is that this will form a subnet, and this again will be forming a separate subnet. So even though all of them are currently connected to the same switch, this system will only be able to communicate with computer 2 and computer 3. And the same way, C4 will only be able to communicate with C5 and C6. So these 3 can communicate with each other, and these 3 can communicate with each other. But if you are trying to communicate from C1 to C4, it will be blocked. So these kind of connections, this is the main requirement of when it comes to switches. Okay, being able to divide the set of systems into different networks.
Yes, I understood about the switch. The router is L2 will not be there, so only L3 will be there.
Router is only on L3, yes, correct.
Right.
Switch we have L2 and L3, and L1 we only have hubs. Okay.
Okay, sir.
So, sir, what is L1, L2, L3?
That is layer 1, layer 2, layer 3. So these are the different layers in which this device works. So when it comes to L1, what it does is you only have the option to connect different devices. But when you come to L2, you have the option to connect devices as well as group them. Okay. And when it comes to L3, we have the option to connect, we have the option to group, we have the option for routing as well as security purpose. So these increasing layers means increasing its capabilities. Okay. So that is basically what's mentioned by layer 1, layer 2, and layer 3.
Sir?
Yes, go on.
So suppose we are having 2 switches, okay? And in
Okay.
one switch we are having 5 systems, and in other switch we have 5 systems. So
Okay.
suppose I want to access a system from switch 2. So for that requirement, do we require a router, or we can directly do a connection from switch to switch?
You can connect from switch to switch, no issues on that.
Okay, yes.
But for that purpose, what you have to do is you have to make sure the configuration done to that particular port is for switch. Like if you're doing switch to switch connection, you have to open that port and provide it with the required configuration.
Okay.
Okay. If it's done, then yeah, there is no issue. You can connect from switch to switch.
Yes. Okay, sir.
You don't actually need a router in between. No problem on that.
Yes.
Okay. So yeah. Okay, and then so these are some of the basic hardware components that you have for routers. I just added it so that you get the idea on what we are actually working on. So when it comes to router, the major components is CPU, RAM, flash memory, and interfaces. So interfaces basically means your ports, okay? The ports, Ethernet ports, serial ports, etc. Where you'll be plugging in your cables. And depending upon the CPU power, you'll be able to like get faster bandwidth and everything. And when it comes to software components, there are multiple types of softwares. So since we are discussing about Cisco, there are majorly three softwares. First one is iOS XE, then we have iOS XR, and then finally we have something called NXOS. So these different types of let's say software components or operating systems will be used depending upon where you want to establish this kind of network. For example, for automation purposes, we'll be using iOS XE. But if you want to set up, let's say, a data center or something like that, for that purpose, we'll be using NXOS and all. So depending upon your requirement, you have to choose what device you need and what kind of software or operating system you need. Okay. Yeah, that's mainly it. Then we have ports and interfaces. So different ports will be having different functions. For example, let's say there are particular ports which we are only using for broadcasting purposes, and there are a particular ports which support security, etc. But when it comes to most of the current routing devices, you actually have the option to like program it so much that you'll be able to change its default functionality. So we'll be discussing about the ports and interfaces soon. So the main thing you have to know about the ports is that by using these ports, you'll be connecting to your different devices. Some of the routers won't even connect. You won't even use the routers to connect to a endpoint. Most of the connections from the router will be going to some switch. Like when you're working inside a company or something, from the router, most of the connections will be going to multiple switches, and from switches, you'll be connecting to your system. Okay, this is done mainly to make sure that the data being sent is being routed correctly. Okay, so yeah, that's basically
Sir,
about. Yes.
hello. Sir,
Yes,
what is
sir.
the function? What is the function of RAM, flash memory?
So that's basically where you would be the RAM and everything. As I mentioned, it has to do some kind of routing. It has to do different kinds of processing inside our router, right? So for that purpose, we need some kind of RAM or some kind of brain inside our router. So CPU and RAM is basically for that purpose, and flash memory is basically where you'll be storing all different kinds of tables. You'll be having something called an ACL. You'll be having ARP files. So all these files has to be stored inside the router. So for that purpose, you'll be having flash memory.
And sir, ROM, what is ROM?
Here we won't be requiring ROM as per se when it comes to router, but ROM is basically your flash. Not flash. Basically your what you say,
BIOS
memory.
memory.
Yeah, memory store. And in this case, comes to like routers nowadays, ROM is not much of an thing that you have to look into much, because the only place where you'll be making any changes is that once you access this router, you'll be getting your CLI, or if you are using a dashboard, there you'll be having access, and all the required automation or all the required programming you'll be doing directly over there. Okay, and in case if you want to increase its bandwidth also, or in case if you want to increase the processing speed, the only thing you might be changing is the RAM. Nothing else would be much of an issue on that.
Okay, sir. Thank you.
Yes, hello, sir.
Yes, this.
Yes, so routers basically, we can directly connect our systems to routers also, no? So basically, switch will be required only for expansion of the network, like to connect more devices. Is that correct?
That is correct. The thing is, like I mentioned it earlier, the other ways, because router is way costly when it compared to switches.
Yes.
Okay. Okay, so when it comes to that, the companies or everything, they won't first like spend on routers. They prefer to use some form of switches. So after, if they are requiring some form of static routing or something like that, they'll be going for routers. But the question you asked is absolutely right. If you want to connect an endpoint device to the router, there is no issues on that. But when it comes to economically, it would be like a little bit redundant. That's it.
Yes. Okay, sir. Thanks.
The question is right. Like if you want, routing, and if you only have like 10 or 15 systems, then you don't have to like get any kind of switches. You can get a router, and then you can set up your network directly on that. No issues.
So,
what is the difference between the switches and the bridges? Is the bridges different? Is the switches different?
So, as I mentioned, bridges basically is something that you only use to connect, let's say, multiple networks. That's why we use bridges. Okay. But when it comes to switches, it's not that. The main reason why we are using a switch is to like connect devices into a network, and also to divide these different devices into subnets or subgroups. But for example, let's say bridges is something that you use to create one network. Switches is something that you use to create one network, whereas bridges is something that you use to connect multiple networks. Okay,
So it's like it's bridges is a hardware and switches is a software. We can think like that.
not exactly. Both of them are hardwares. Like switch and bridge, both are hardware. Let's say. Okay. Give me a second. So let's say we have 3 computers here, C1, C2, and C3. The main requirement here we have, switch. By using switch, we'll be able to connect C1, C2, and C3 into one single network. Okay. But at the same time, and if you are having another switch 2, which has C4, C5, and C6. So this is switch 2, and by using switch 2, we can connect that to form this is network 1 and network 2. So by using switch 1, we are connecting C1, C2, and C3. And by using switch 2, we are connecting C4, C5, and C6. But by using a bridge, you'll be able to connect these 2 switches together. So basically, 2 networks are being connected together using a bridge. I hope you got the idea.
We can connect through router, right?
router also we can connect. Now, if you are requiring programming or if you are requiring routing purposes, you can use router. If that is not required, if you just want to connect two networks together, you will be using bridge. Okay. We won't be connecting any systems directly to the bridge. Bridge is something that we are using to connect two different networks. So either to switches or to routers or to hubs will be mostly connected to the bridge.
And sir, why we are nowadays we are not using bridge?
Because the security in bridge is very low. Like if anybody could easily get access to bridge, there are like literally no security services when it comes to bridge. If somebody has a laptop and you're plugging in your port directly into the bridge, he'll be getting access to the entire system. That is why bridges are not being used nowadays.
So mostly we'll be using switches, not the bridges. So bridges will be using very frequently. Am I correct?
Bridges are something that we won't be using. Switches are what we are using frequently. Okay, we'll be using switches to set up different types of network. But bridges, the reason, as I just mentioned, due to security issues and even sometimes data loss, we are not using bridges much. Instead of bridges, most of the time right now, we are using routers.
So it's an outdated hardware just like hubs.
Yes, bridges are also kind of an outdated hardware. Yes, go on.
What is Adreno?
What is?
Adreno?
Arduino. You're asking about Arduino. So Arduino is just like, how to put this? It's just a chip and it really doesn't come inside CCNA. Anyway, since you asked, Arduino is just a basic, like, how to
It's
say?
a motherboard.
Yeah, close to that. Exactly. That is something that you are used nowadays. Mostly it's used by students for like making small kinds of processor projects and all. It has the ability to run specific set of codes inside that PCB. And yeah, that's mainly what we are using Arduinos nowadays. I'm not sure where you got that right now.
I have it.
Okay, you have an Arduino. Okay. So like it's something that, yeah.
Kevin, this is Roundry. Can you explain what type of protocol that switch is using for routing the packets?
What kind of
protocol? Does switch uses a
Okay, you want to know like what kind of protocols the switch is using
yes.
for like routing network, those kinds of stuff.
Yeah.
So yeah, the switch can actually use almost all the different kinds of protocols, like let's say EIGRP, like IGRP, RIP, routing information protocol. All of them are possible inside switch, mostly. So like you want to know all the routing protocols. Again, we'll be going through that later, but just for the sake of it, like we have RIP, RIPv2, IGRP, all these protocols are possible.
Yeah, Kevin, one question. So basically, the router is a switch, right? L1 or L3, you said?
Router is not a switch. Okay. What I mentioned earlier was that we have two types of switch. One is L2, the other one is L3. L3 supports routing. That's it. It's not a router. That's the switch itself, but it has the option for routing within itself. That's it.
Okay, okay. So what about access points? How can you explain it?
So again, access points are just a few devices which are basically used to connect different systems or different devices inside a network. Okay, that's the example. Like router is an access point, switch is an access point, hub is an access point. Because by using all this, you'll be able to connect different devices together inside a network. Okay, it just gives you access. These are the points which gives you access. The one way you can study is about comparing access points and endpoints. Okay. So as I mentioned, access points are devices which connect different devices together, and endpoints is where the network terminates. The endpoint is where you are accessing the data. So for example, your computer or your mobile.
I want to connect to a different network. Like take an
Network
example.
from what?
Like Airtel, and one more is Geo.
No. What I'm saying is, I understood you want to connect to different networks. I'm asking you, like, so this connection is coming to your home through a Wi-Fi, right?
Yeah.
So you want to connect those two modems together.
Yes.
It's not exactly possible, and it should not exactly. You should not actually do that, to be honest. The reason being, they have a lot of like firewall protocols and everything that they're mentioning. But if your requirement is that you need to connect two networks to your device, like if you have a computer and if you want to access both of them in your computer at the same time, if that's your requirement, what you can do is make changes to your system. Okay. On that system, you have the option to connect to multiple devices. But if you're trying to connect two of these access points together, that could create issues. Like one of them could be faster, one of them will be using a specific set of controls and all those kinds of stuff. So it is preferred not to do that. But if you actually want to like directly connect both of them together, preferably you could try a switch.
Switch.
Yeah, the only thing you could be able to do it, you'll be able to communicate between devices, between these networks, but you won't be able to get any fast net speed or anything like that. Nothing of the sort is possible.
So basically, we can say L3 device and L2 devices, like basically L3 devices forward the IP address and L2 devices forwards the MAC address, right? We can say it in this way.
Yes, you can say that. Yes, that's a very good point.
Sir, access point is L2 device.
L2 and L3 both can act as access point. Okay. So any device that can connect any other two devices together into a network can be considered as an access point.
If you want to connect two different switches, we need a router in between of them, because we can't connect one switch to another switch directly. Is that what I understood? Is it correct, sir?
No, if you want to connect two switches together, it's possible. There is no issue onto that. But you, as I mentioned earlier, you will have to configure those ports correctly if you want to have that connection together. So, like, there are multiple places or companies which actually uses only switches. They won't be having any routers. What they'll do is they'll have a central hub, that is a central switch, and from that switch, multiple switches will be connected.
Yes, we are using the same thing. That's why I asked this question.
Yeah, that's what I'm saying. Like, you don't need a router for that purpose. You can just use this central switch and connect all the other switches directly to that. There is no issue on that. You just have to make sure that the central switch is configured correctly for that particular purpose. If you have the option to access that switch, just go to that port and see the code over there. Okay.
In L3 switch?
Yeah, L3 switch. You can actually see that that particular port will be having a particular set of ports which gives access to whichever switch that port is connected to.
Okay.
From that set, you'll be able to see a set of ports. So depending upon where you're working or who programmed it, there will be slight changes, but most of them will be pretty much same. It's mostly either you are using HP or Cisco, right? You're having a central switch.
We are using Juniper and Aruba.
Sure, no issues. So yes. So as I mentioned, today we'll be starting with switches. So just like routers, switch is also another network component. Switch is also a network component that we use to connect different kinds of our endpoints to establish our network. So basically give me a second. Okay, so basically the switch is a network device that is used to like segment the network into different subnetworks called subnets or LAN segments. So switch is something that we use mostly when it comes to how to put it, small networks or LAN kinds of networks. So there are like different features of switches that we'll be going through. One of the main thing is something that we discussed yesterday. When it comes to routers, you'll be using IP addresses to find the next router or for communication purposes because we are using layer 3. But when it comes to switches, that changes. We have the option to use MAC addresses. That is because we are working on layer 2. So although we have layer 2 and layer 3 switches, most of the time mostly for economic purposes and all, when we are using switch, we'll be using layer 2 switches. So in that case, we'll be using MAC. And when we are using layer 3 switches, we'll be using IP addresses over there as well. So the switches actually have a lot of ports. So when the data arrives at any of these ports, it will be mostly using these kinds of MAC addresses. So MAC address is something that every device has. Okay, so it's kind of like the identification number of any electronic device. Even your mobile phone has a MAC address. Your computer, even most of the time, some of the watches will be having a form of MAC address. I've actually seen calculators having this. So these kind of addresses are there for all kinds of electronic devices. By using that, the packets are being transferred through networks in case of switches. So there are, as I mentioned earlier, there are like mainly two types of switches, that is layer 2 and layer 3 switches. So let's just discuss the basic difference between them. Okay, so what is it? Okay. So like two. Right. Sorry, what was the question again? Collision domains. Okay, so collision. I think we haven't reached there, but it's basically like a scenario in which a device sends out a message to the network, okay. And also, give me a second. Yeah, so right, that's it. Collision domain is a scenario where, let's say, we have a network device and it sends out a message to the network, and all the other devices which are included in it, it's kind of like a subscription option. Like whatever devices are added into a particular collision domain will have to pay attention to what that packets are being sent. For example, let's say, I'll just show you a small example. We have imagine a small network. Consider that as our network device, and we have a system. This is computer 1, we have computer 2, computer 3, and computer 4, computer 5, etc. So out of this, C1 has a particular collision domain in which C3 and C4 are the members. Okay. So when the C1 is sending a message using collision domain, what happens is C3 and C5, these two are not part of its collision domain, so they will be completely unaware of it. But C3 and C4 will have to pay attention to like what kind of packets are going into that particular network. So that particular scenario is known as a collision domain. So we'll be discussing that in a bit when we are discussing about broadcast, unicast, and everything. So it's like part of that. Okay. So that is basically what a collision domain is. Okay, so like where were we? We were discussing about layer 2 and layer 3 switches. Hope I can start back with that. So layer 2 and layer 3 switches. So the thing about layer 2 switches is it operates on basically layer 2. Layer 2 means our data link layer. Data link layer. And layer 3 is network layer. Yes. Network layer. Okay. So before starting with it, I'll just give you an idea about what are the different layers inside our OSI model. There is something called OSI model, which is the basic part of all networking. So it has basically 7 layers. So these layers are physical layer, that is layer 1. Okay. And second layer is data link layer. Third one is, as we have here, network link. Then we have transport layer. So not network link, just network layer. Okay. Then we have transport layer. Then session. Then we have, yes, presentation. Very good. And last we have application. So these are the basic layers that we have inside our OSI model. And the thing about these layers is that each of these layers have different functions. So the physical layer is basically it's the lowest layer or layer 1 of it. And then we have data link layer, basically used for storing our MAC ID and those kind of stuff. And in network layer, we'll be having our network IP address and those kind of details. So these are basically used for connecting. In networking's point of view, this is basically used to make sure that the data is being sent, or it is being, let's say, encapsulated in the right format. Okay, so we'll be discussing about the OSI layers way like in detail. I just showed to you right now because so you can get an idea why these are known as layer 2 and layer 3. So layer physical is the layer 1 and layer 2, that is the link layer.
Hey there.
Since
Continue learning directly from industry experts. You are watching these recorded topics from our master's program, but you can watch it live by joining any of these master's program, where you can become an IT engineer that too without coding. Now you can continue.
They are known as layer 2 switches. And similarly, since there are a few switches that's working on networking layer, which is the layer 3, they are known as layer 3 switches. Okay, if not, there will be a bit confusion on that. So let me just click that. So as I mentioned, we have multiple types of switches that are layer 2 and layer 3 switches. So the thing about layer 2 switches is, as I just mentioned, it works on data link or layer 2 and switch layer 3 switch. So I think you got the idea that this is on data link and this is on network layer. The next thing is that layer 2 switches uses MAC address to send data, and layer 3 switches uses IP address. Okay. So the thing about layer 2 is that it works only on MAC, but in layer 3, it can use both IP as well as MAC. Both are possible for layer 3. Okay, so that's that availability is there for layer 3. And the reason why we are actually still using layer 2 is because it is mostly used to, let's say, reduce the traffic on local networks. So if you have a LAN, then in that case, using layer 2 will easily help us to reduce the traffic there, because it doesn't have to go and check the IP address and come back and everything. Instead, all it has to do is create a packet, encapsulate the MAC ID on it, and then just send it out. So whenever the MAC ID matches, it will be taking that. But when it comes to IP, what happens is that they have to go and find the IP address from the ARP and then decide to send it using with the easiest path and all. So it takes a lot of traffic, and lot of data transfer will be required in between. That is not required for layer 2. And the reason why we are using layer 3 mostly is because it can it is mostly used to implement VLANs. So it basically means is that it is in the layer 3 switches that we will be able to create multiple networks. Okay. When it comes to layer 2 switches, we'll be only able to create switches based on MAC. I mean, connections based on MAC. So we won't be able to set up any kinds of division in between the networks. But when it comes to layer 3, what happens is that we have something called VLAN, that is virtual LANs. So here they only have the option to create LANs, that is local area network. Okay. So it can create one LAN, whereas layer 3, inside layer 3, that means inside a layer 3 switch, we can create multiple VLANs. So we can have VLAN 1, VLAN 2. So basically, both of these acts as different networks. So under that VLAN 1, we can have like multiple systems connected. And under VLAN 2 also we have like we can have multiple systems connected. So thanks to that, what happens is that we can have completely different networks with the help of just one switch. Okay. So by doing so, what we're doing is that these systems will be able to communicate with the systems which are under the same VLAN, but not the systems under the different VLAN, even though they are connected to the same switch. Okay, so that is the main requirement of a layer 3 switch. And when it comes to layer 2, as we discussed earlier, because there is a low traffic, it can work much faster. Like they do not look for any layer 2 portion or any kinds of data packets. So layer 2 switches are way faster compared to layer 3 switches. And when it comes to layer 3, what happens is that it takes time to examine different data packets before sending them to their destination, which basically means it will have to check for the IP address, and it has to find the lowest, the smallest route in which this IP address can be sent. And all those details and all those processing take time compared to layer 2 switches. Okay, so in that way, layer 3 takes more time. If you want a faster connection, go for layer 2 switches. But if you want security, you have to go for layer 3 switches. And another thing is that layer 2, since it has only one LAN under it, it can only have one single broadcast domain. So if a system under layer 2 is broadcasting, what happens is that all the other systems under that particular switch will be getting the results. Getting that particular data. But since layer 3 has the option to create VLANs and all, it can have multiple broadcast domains. So each VLAN, each subnet will be having its own broadcasting domain. So if you are sending that data to the broadcast domain of one virtual LAN or one subnet, what happens is that only the systems under that particular VLAN or subnet will be receiving this broadcast. Whichever system is connected outside of that particular VLAN will not be receiving any of this. So that is again another difference between layer 2 and layer 3 switches. And another main thing is that layer 2 switch can only communicate within a network. Okay, so if the layer 2 switch is connected to a network, it can only communicate to the devices inside that network. Okay, but when it comes to layer 3 switch, it has the option to go outside, and then where the connection is coming from the outside, the layer 3 switch has the option to go outside the network and then communicate with the devices outside it. So compared to layer 3, layer 2 has a lot of, let's say, constraints, saying that it can only communicate using MAC address. only communicate within a network. There is no option to divide other systems and all. But at the same time, if you are working on an open network or anything, then the best option is for going for layer 2 switch because it would be much faster. So layer 3 can be considered if you are requiring security or in case if you are requiring multiple networks to work inside a institution. So these are some of the basic difference from layer 2 and layer 3. I hope you guys got an idea on what this layer 2 and layer 3 switches are.
Hi, sir.
Yes, go ahead.
In layer 3, you're telling we can create VLAN. In layer 2, it cannot be possible. So if I create VLAN in layer 3, whether I want to use different layer 2 switches or same layer 2 switches, I can have layer 3 VLANs can be connected.
That's the thing. You don't need another switch because if you're having layer 3 switch, inside that switch itself, if you can connect like 10 computers directly to that switch. Okay. And these 5 can be added to one network. These 5 can be added to one network without any other extra switches. Directly inside that switch itself, you will be able to create 2 networks. Okay, that is the plus point here. And this will be divided by using the IP address. So they'll be having a specified set of IP addresses. So let's say 192.168.1.1. So up to 1.5. Let's say 1.5. Yes. 192.168.1.5. So without even connecting to any other network device, and so these will be the different IP addresses of computer. So all of this can be added to one particular VLAN 1. Okay, so that means that actually exists inside this particular switch itself in a separate network. Okay, that is possible without any extra device connecting to the L3 switches. And you can create other 5 IP addresses for the other 5 systems, and they can exist in completely different networks. You don't have to add any other layer 2 switches in between. Without that itself, you'll be able to do this. And that particular, yeah, go ahead, ask.
In L3 switch, if I create 3 VLANs,
okay,
in same one switch, I create 3 VLANs. Whether each VLAN required one switch, L2 switch, or
no. You only need this one L3 switch. Nothing else is required. Inside that, it's
employees are more that time. What can we do?
Yeah, if you have like we have close to 256 connections is possible, depending upon what kind of VLAN we're using. So if you have a switch and inside that itself, you can set up multiple VLANs. But in case if you have more employees, what you can do is that, so it actually depends upon that particular scenario. Okay, so if you have like 100 employees and all of them are working on, let's say we have a building here, let's say 1,000 employees. If that's the case, we'll be needing multiple switches.
Yes.
Okay, so what we can do is we can provide one switch for each floor, and all of the switches can be connected to one central switch. Okay. And each of these switches has, like, imagine that this particular floor has 3 departments. So inside this switch itself, you have to set this up as an L3 switch. So this switch itself can create 3 different networks. Okay. So the thing is, one switch can hold, depending upon the switch. I have worked with a couple of L3 switches. So one of them can actually hold up to, I think, 42 connections directly from that. So up to 42 employees, you can add up to, you can set up like maybe 5 VLANs inside there itself. Okay, without any issue, you'll be able to create 5 VLANs on that one switch itself. But if you're having like 100,000 employees and all, then we'll have to implement more switches. You also have the option to use L3 switches if you want. So what you can do is you can use one port from this L3 switch. Your main switch, you can use one port and you can add that port into a particular VLAN. Just that port can be added to one VLAN and you can set up an unmanaged switch or an L2 switch and all the employees can connect to that. Okay. So that is possible. But if you need security, instead of this L2 switch, you'll have to add an L3 switch. I hope you got the basic idea. Like, if you have any doubt, please go ahead, ask again.
I have a bit confusion once again, sir. That's why.
Okay, so just give me a number. How many employees are you expecting?
10,000.
Sir, in a floor, you can think 500 employees are there. Okay.
So we can take it for
So in that 500 employees, they are sitting in the first floor. Ground floor, I have L3 switch. So in the first floor, there is 3 departments. One is finance, HR, and admin. So I will create 3 VLANs in ground floor.
Okay, on the first floor, you have 500 employees, and
500
ground
employees.
floor, you have the L3 switch. Okay,
L3
fine.
switch. So I'll create 3 VLANs in L3 switch. One is for finance, one is for admin, one is for HR. So I think that I will assign 200, 200, and 100 for each in the 500. One VLAN for 200 employees, another VLAN for 200 employees, and another VLAN for 100 employees. So whether I need to go for L3 switch only or I need to go for L2 switch, that's enough to me. Because to save the cost.
So if you want to scale the cost, it depends. So out of this, the main requirement that we have to know is does any of this group requires high security or not? So if you don't require high security, then you can use L2 switches.
Okay.
But if you require high security, then you have to use L3 switches because that can help you make sure that no one else will be able to use the other person's network. You'll be able to do something called MAC binding.
MAC binding. Okay, sir.
Yes. So if security is required, what you have to do is, if I'm right, I think like we have up to 52 ports on most of these kinds of switches. And out of that, some of them are already like predefined ports. So you can use up to 48 ports from one switch.
Yes.
Okay. So if you have to create like 100, then we'll have to use close to 2. This is my suggestion. Okay. 2 L3 switches and 1 L2 switch or an unmanaged switch, which can be used for sharing purposes. Because if you are spending more on an L3 switch, that would be close to like very wastage of an extra switch. So, and then from one of these L3 switches, like you'll be connecting both of those L3 switches to the ground floor.
Yes.
Okay, from this central hub. And from one of these L3 switches, you can connect this L2 switch. So it will be, what happens is that you'll be having a closed security. So only the person from that particular group will be able to access these 2 ports. No one else will be able to. So as a department, you will be having very good security. Okay. Got the idea?
Yeah, got it, sir.
Okay. And the similar can be done for all the other layers as well. So if, as I mentioned, if security is highly required, go for L3 switches. And if you, in this case also, like you can go for like 4 L3 switches. And after that, you'll be having close to, I think, 8 extra ports should be required after this 4 L3 switches when it comes to 200. So what you can do there is like implement 1 extra L2 switch. In that L2 switch itself, this 8 will be covered. So you only have to bring in 1 port from any one of these L3 switch, and inside that you can connect the L2 switch. So again, as a department, you'll be having a secure network, but and these extra 8 can also be included. If not, what happens is you have to go for like 5 L3 switches, and that could create like unnecessary economic requirements. When it comes to like a normal company and all, it won't be that much of a requirement. Like you'll be having some kinds of interns or assistants or somebody will be using the systems, right? So they'll be given a less secure one. So that's basically the process that we follow in the corporate side. The only thing is that these L2 switches that we connect, or that the ports in these 8 ports in these L2 switches, anybody from that particular department can access. They can connect there, but for that they'll have to like take their system and connect it to that port inside the server room. If the server room is secure, then no issues. You don't have to worry anything.
Okay, sir. Hello, sir. I do have one query.
Go ahead.
Sir, can we use for each floor L2 switches, and can we connect all those L2 switches into L3?
That is fine, but the issue is that if all of them are L2 switches, what happens is any other person, like you'll be having other departments, right?
Okay.
So they have the option to bypass like port security and access your information. They have the option to do that if it's only connected to like the central hub. I mean the central switch. Because everything else is L2 switch. So, and also when you are sending some data, there is chance it could be going into broadcasting. That could create an issue. So it's preferred not to do that.
And the port security can be only configured on only L3 switches, not in L2.
Like there is a little bit security on L2, but that's not something that we can configure. So it's always preferred to make sure that you have L3 switch if you're looking for security. Reason being that there you have the option to set up your required passwords or and all those kinds of stuff. When L2 switch, if somebody is connecting their system directly to that port on L2 switch, there is no password or any credentials required. You can just directly log in. Okay, so that means pay less security.
Thank you, sir.
Okay, so no problem. So yes.
In lab,
Yes.
in the lab, we'll have more experience on this, sir. We can learn on L3, L2 switches.
Yes, definitely. You'll be working on Cisco Packet Tracer. So I'll be giving you guys the link to download it. If you already have it, then no worries. We can work on that. If not, I'll just send you the link mostly by the time we are starting on labs. So I think that comes close to 6th or 7th module. But no worries, I'll be creating a few images so you can just upload it and then work on that directly. And if you want, I can also help you on creating like topologies on as well. No issues. You want to know about Unicast and Multicast, right? Sure. No worries. So, okay. So you want to know about Unicast and Multicast. So it's just the basic thing. Okay. Unicast means, okay, so let's just start with Multicast. So it will be easier to explain Unicast. So multicast is just a procedure, which means that if you are sending a data into, let's say, your switch or your network device, it will be sent to everyone inside that particular network. So imagine we have a network with, let's say, this is our switch, and we have C1, C2, C3, C4, and C5. So if this is our system, this is our unmanaged switch. So what happens is that in multicast, if you are sending a data into that switch, it will be sent to everyone. Okay, that particular method is known as, this is what I just mentioned is broadcast. Okay, if you're sending a data onto that switch, it will be going to all the systems connected onto this. That particular method is known as broadcast. broadcast. Multicast is a method where this C1 can decide which all should be getting. That basically means one to many. So if it's deciding C2 and C3, then what happens is C1 will be sending the data. It will be going to both C2 and C3. Okay. But not all the devices connected to that one. It can be configured and it can be decided by the sender. That particular method is known as multicast. And the next one is unicast. Unicast, as the name suggests, uni means one. That means one to, instead of one to many, it will be one to one. That, yeah, it will be one to one. So C1 is deciding I want to send some data to C4. So it will be sending it to the switch and it will be going directly to only to C4. Okay. So, and everything else will be not considered. And that method is known as unicast. This can be done with the help of IP address. So we'll be discussing about that when we are going through subnetting. And I think we had a doubt regarding.
Kevin, actually, I was confused about this broadcast and multicast. Can you repeat it again?
Okay, sure. So the thing about broadcast is all the okay. Let me just read it. So the thing about broadcast is you have a switch and you have like you have like 5 systems connected to it. And if C1 is sending some data into that particular switch, it will be going to all the devices connected to it. Like it won't be checking anything, just sending data to all the devices connected to it. That particular method is known as broadcast. Okay. And multicast is a method where C1 will be deciding to which all devices this connection should be going to, which is more than one. One to many. So it's deciding C2, C3, and C4. Okay. If C1 decided it's C2, C3, and C4, all this C2, C3, and C4 will be getting the data sent by C1. But C5, although it's part of the network, will not be getting it. Got the idea? That's the difference between broadcast and multicast. And just before that, there was a doubt between about L3 and L2 switch, right? Could you just ask me that again? Yeshwant, I believe, was the one who was asking.
This is Naveen, sir.
Okay. What was the question regarding
In
L2 and L3?
multicast, which switch we need to use, L2 switch or L3 switch? Because you told that multicast, we can have only 2 ports can be configured, where C2 and C3.
No,
and
multicast, you can configure, it's not configuring that particular ports. Instead, what happens is that C1 can decide which all devices are getting this data. Okay.
Okay.
So if C1 is deciding C2, C3, and C4, then all of them will be getting. If C1 is deciding only C2 and C3, then only those two will be getting. That's it. That wasn't the question I was talking about. There was another question which I have noted over here, L2 and L3.
Yes, sir.
Yeah, what was that question?
Actually, in my company, Cisco switches are implemented, but how?
Okay. Hello.
How I can identify it? That switch is to be L2 or L3 switch.
So, do you have access to its interface?
Yes. Actually, I am here for IT support and services to third party, and I am the whole person here because there is a I'm working here in a small plant. In a small plant, there is a small plant which implemented. They have implemented to third party IT infra for they have connected many Cisco switches like 5 Cisco switches connected 3500 series. But I open the interfaces of switches. But how I can identify that switch is to be worked L2 or L3 switch?
You got the like series of that switch, like the
Yes,
name of it?
350. Cisco
Three
350.
Cisco 350.
Yes.
Okay.
28
There are
port.
like
PoE
you have
port. PoE
28.
port.
Okay. Let me just.
I think
Actually,
it can.
actually, we have a system, also surveillance system also, and
Okay.
there
So
is a
the thing,
routing. There is a routing implemented in it, but I don't understand the routing.
like, okay. So first of all, if there is routing, then definitely it's an L3 switch. There is no doubt on that.
Okay.
If routing feature is available, then definitely
Yes,
it's an
yes,
L3 switch. You don't
yes.
have to doubt anything else on that.
That's why I'm asking you.
So just a simple thing, like first of all, if you are seeing something like that, just try to log into it. If you are having a login and password, most probably it would be an L3 switch. Because when they are setting up L2 switches, 90% of the time it's like unmanaged. Okay. And another thing, like if you are actually getting the ID, just go ahead and Google it. You'll be getting pretty much all the details online regarding what if you have the serial number. Like now you just said the thing is like you got the name Cisco 350, right?
Okay, right.
Just go ahead and try and Google it whether Cisco 350 is L2 or L3. You'll pretty much get the answer right away. Okay. So those kinds of stuff, it would be much easier. Like if you try to find it out by yourself, then you'll be getting an idea. Okay, this is where I should check for to getting a little more information on that.
Okay.
Okay.
Kevin, I have one more question about this. L3
Yeah.
switches and L2 switches. If there is a L3, L2 switches, we have any login ID and password in L2 switches also, or only in L3 switches that can be possible.
L3, L2 switches can have passwords, but the thing is like if you're directly connecting to it using a port from your system, then you can bypass it.
Okay. So how can we identify that without any C that switch? So how can I identify that there is a L2 switch or L3 switches?
How you can identify whether it's an L2
Yes,
or
yes.
L3 switches?
How I have a both of that login ID password of L2 and L3 switches. I generally asking a question there of this. I generally am asking a question that I have a password of L3 switches and L2 switches, both of them. So how can I identify that this is the L3 switches and this is the L2 switch?
Oh, just with the user ID and password, you cannot do that. The only thing you can check is that if it's you have to access it and check if it does store IP or if it just store MAC. Only by doing that you'll be able to understand. Just by getting, because anybody can change the user ID and password. So just by seeing that, you won't be able to identify whether it's an L2 or L3 switch.
Sir?
No.
Yes. What was the other doubt?
Yes, sir. Sir, can we say that like unicast is one to one and multicast is one to many and broadcast is one to all?
Yeah, definitely. That's the pretty much the most accurate answer. Yes, that's right.
Okay, sir. Thank you.
Okay. I hope all the doubts are clear. So yes. So right. Yeah, we were discussing about switches. So yeah, we just discussed pretty much all the different aspects of switches as well. So I believe you pretty much got the idea, right? So the only difference from like the previous time routing to here is that when it comes to switches, you'll be using MAC, and instead of packets being sent from sent through routers, when it comes to switches, we'll be forwarding something called frame. So that is just like a smaller version of packets. So everything else is practically the same. And this virtual LAN support, that is something only for L3 switches, not L2 switches. Okay. I think pretty much everything else is same. Spanning tree, link aggregation, frame forwarding. That's
Sir, I
yeah.
have one question. So
Go
actually,
ahead.
what is the difference between the IP address and the MAC address?
So IP address is something that comes with the device. You don't have to like add it to the network or anything. When an electronic device is created, it is given a unique ID that is known as a MAC address. So if you have your system, just put it upside down, you'll be able to see the MAC address over there. Or if you have your phone, just go to settings and about phone, you'll be able to find the MAC address over there. Okay. So that remains constant. Nobody can change it. The MAC address is a constant ID for your system. Okay. But IP is not like that. IP keeps on changing depending upon which network you are in. So if you're connecting your laptop to your home network, you'll be having the home network IP address. So if you're taking that same laptop or mobile to your office and connecting to the Wi-Fi or network there, then you'll be getting the IP address of that particular office. So IP address is basically a network-oriented ID, not your system-oriented ID. Okay.
Okay, thank you, sir.
Hey, great.
Sir,
So
what is port security?
port security. So port security is basically something that you do to make sure that there is no other person who does not have authorization accessing your system through that particular port. So if you have like a L3 switch and you have, as I mentioned, close to 48 ports which you can actually use, and each of that port can be configured to accept only one device. There is the option to do that. This particular option is known as MAC binding. So once you do that, your port is secure. If somebody else is bringing their system and trying to connect to any of those ports, they will be completely banned out. They won't be able to access it. Access your switch, access your network, nothing. That particular method is known as port security. This can be configured by the administrator of that particular switch, whoever has access to it.
Okay, sir. Thanks.
This is mostly done in colleges or maybe in offices where they do not change your seat or anything like that. Okay, so yes. Next, we are going through switch management. So as most of you are asking how you can configure switches and all those kinds of stuff, these are the different things that you can actually use to configure your setup. So first you can see something called a console interface. So a console interface is basically your direct interface of that particular system. For example, if you have a server, if you have a router and all, or even a switch, what you can do clearly is that each of those console will be having a one particular port, which you can directly connect to a monitor or an interface. Okay, so over there, you can just if you have visited any server rooms or something, you can see somebody will be pulling out a monitor, pushing it up, and then just start typing. Not right now. So basically, the use of that is that you don't have to like connect to it, gain access to it. Nothing is required. You can just open it because it's directly connected to the switch, and you can just start working on it. And the other ones are basically remote accesses like Telnet, SSH, web-based interface, SNMP, etc. So for Telnet and SSH, you can just open your computer, which is already connected to the network. Just type in the IP address of that particular switch for connection. It will be asking you for a user ID and password. So you can do this in your normal CMD itself. So then you have to give the user ID and then you have to give the password. Once that's accepted, you'll be getting a display where you can access all the different ports or set up different commands and everything. So basically, what you can do is like if you're using SSH, you give SSH space the ID of that particular switch, then username, then password. Then you can type in config. So configuration option will be opened up. There you can select which port you want to configure. Most of the time, it's either fast Ethernet or either gigabyte Ethernet ports that will be available on these kinds of switches. You select it, you can give the MAC ID or you can give the IP address which you can set up for that. So all of this can be done other than the control interface. Everything else you can just do it from your own system once you have access to that particular switch. So the web-based interface is the only different one compared to the telnet SSH and everything. Here what you do is you just type the IP address on your URL area on any browser. Okay. Once you give it over there, it depends like whether your switch has a web-based interface. It kind of acts like a GUI. In case of routers and all in your home, I think you can just type in 192.168.1.1 or 0.1. You'll be getting a small interface where you can give your user ID and password. So that is basically the web-based interface. I think let me just see if I have it here. 68.0.1. Yeah, this is basically the web-based interface for the one, for the modem in my house. It won't look exactly like this for switches. It will be a little more different. So I just wanted to show you what this web-based interface is. So that's basically it on switch management. So what do we have next? Servers. So I'll just start with the server anyway. So server is basically a computer or a software
Sir,
system.
excuse me, sir. Sir, you have not mentioned about different types of switch and different types of switch series.
You're talking about what all series of switches are there?
Yes, and you explained about router, right? You also not explained different types of router series and router boots up process.
Yeah, the reason I haven't mentioned like each and every router is because like these are like the basic part of what we are going to go through. And even when it comes to CCNA, we'll be only going through like one or two routers or switches. And also like if you are trying to explain about each and every router, that is going to take like 40-50 hours. So explaining about each and every network devices, that won't be possible during our session because of the time limit. Not just because of time limit, because it's not actually covered inside our curriculum as well. But what we can actually do is that I can give you some idea. Okay, so you can see something called a Cisco packet tracer here. And when we are working on labs, I can try to give you more labs on different types or at least 4 or 5 types of routers and switches. I think I opened it. 1 second. So let me just show you a small demo on that. So this is the Cisco packet tracer. So in here, you have the option to set up different kinds of topologies. So for example, here I can set, I hope you can see my mouse. So here I can see select the network devices. So here you can see routers. So here itself, you can see, this is not even all the routers. Okay. So here itself, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 routers. So if I start to explain about all the routers, that itself is going to take our entire time for the CCNA session. So for example,
at least 2 to 3 series you should explain, right?
The thing is like,
and also switches. If we know about series, then we can find layer 2 and layer 3 switches.
Okay, by knowing the series, if you want to find layer 3 and layer 2 switches, that you can actually follow my first suggestion. The easiest thing is like if you know the series number, for example, yeah, you can see this kind of, okay, when I'll take this switch from here. So yeah, you just put that. So if you can see the series number or something like that, you just copy that series number, know about the series number, go to your Google and just give it a search. That actually gives you a much easier idea and also the consoles and all the different kinds of commands you can use over there. Okay. As I mentioned, explaining about all this, that could take like a very huge time of our session. So let me see if I can make some time to explain about this. But right now I don't have like all the, I actually haven't prepared all the required slides for that, for different series of switches and everything. Okay. So what I can, as I mentioned, so these are what you see here are the different kinds of ports and everything that you have for switches. Okay. So what I can do right now is go through this session, and if you want to know about different types of switches and different series of switches, depending upon that, I can set up one small session just for that. But in between this session, I'm not really sure how much I can cover. Like if I started to explain about one router, that is going to take one entire day. I mean, like one entire session. That's 1 hour. Okay. I hope that is fine with you guys.
Sir,
Yes.
what is the use of Cisco packet tracer?
Cisco packet tracer. Yeah, Cisco packet tracer is basically used to emulate networks, which means so if you want to check if a topology is going to work, if you want to like implement a topology at your office or something, then you have to know it should be work. It can be implemented or it can be working, right? So for that purpose, we'll be using Cisco packet tracer. So if you want to have like earlier we discussed about setting up an L3 switch and connecting multiple L2 switches to it and everything, right? So for that, you can come here, find a switch, set it up, and then go ahead and check, find out which all are L2 switches. So set multiple L2 switch. Okay, so that's a bridge. Like that. Yes, you find a couple of L2 switches, and then try connecting this switch to that switch. So you'll be connecting it over there. Okay, for this, I'll be needing straight connection. And then to here, console. You got the connection. And the next one, you'll be connecting from that switch. And you'll be connecting to the next switch. Also, connection established. So you'll be checking like this, whether it's going to work or if anything can fail in between. All those details you'll be checking like this. Okay, and if you want to set up a computer, then fine. You'll be finding an end device. You'll be setting up a PC. And then you'll be trying to connect it from that particular switch to that PC. All these details you'll be able to do. So yes, from here you can connect to that PC, fast Ethernet. So you can see, right? So in this way, you'll be able to check whether you'll be able to connect a particular switch to a particular system and all those kinds of details. Just to make sure, you have the option to get it working if a particular topology is deployable. That's why we'll be using this kind of Cisco packet tracer. There are other kinds of things like GNS3, etc. But when it comes to Cisco, it's always preferred to use this option.
So, sir, it's just used for testing.
Testing purposes, yes.
Okay, okay, sir.
Okay, and I remember your thing about switch and explain different types of switches and routers. So I'll make a note of that and try to give you a little more content on that. Possibly, hope that's fine. Okay. So next we have servers. So as I mentioned, okay, I think we are a bit out of our time. I hope we can sit in like for five more minutes. Okay, so a server is basically a computer. Just assume the server as a computer, which is running in somewhere else. So the only thing that you have to know about this is that it will be able to store data inside servers, unlike routers or switches. Routers and switches are some devices that you're using for networking purposes. That is to connect different devices together. So server is actually kind of an end device where you'll be storing different types of data or running different types of services, etc. So this is where you'll be requesting data from. Okay, so when you are trying to open Google, if you're trying to open Amazon and everything, all this data is stored inside some server. Okay, so when you're requesting something, the request will be going through a router or a switch and it reaches the server. and then whatever you requested will be sent back to you the same way it went back. So at that time, that particular device is a server, and you will be marked as a client because the client requests data from the server. That's the order how it's going. And as you can see, these are the different uses of servers. It's used for file storage and file sharing. So if you're working in an office, you must have something called a PC sharing or something like that, where you share all your data locally without storing it online. So that can be considered as a server. And it is used for website hosting, web app hosting, for email services, database management. So wherever you have the requirement of storing data and sharing them, that can be considered as a server, or it can be considered as a server. I hope the idea of server is clear.
Sir, we can call it endpoint.
You can call it in
Endpoints.
Yeah, as an you are talking about end device.
Yes.
Yes, it can be an end device. Yes, just like a computer or mobile or something. This is an end device. The server is an end device. It's not an access point. So I think you got the idea of what the servers, right? Any doubts on servers?
Sir, how the server in server, how the cloud computing is coming?
How the cloud? So the thing about cloud computing is that, yes, we are thinking like when we hear the word cloud, it is being stored somewhere, like totally cool and all. Nothing like that. Cloud computing is basically we using someone else's computer. Cloud computing just means that instead of using our personal system's computing power, we are using the computing power from some other device stored somewhere else. For example, AWS. So these are all some devices stored in some other location. And we are just accessing that through remote connection and then doing the computing just using an interface. So all the computing will be done in that device or server, and it will be sent to you.
So, sir, we can like I want to say about in a example, like in server there is the AWS, and we are using AWS like a cloud computing.
Yes, you're taking remote access from that system on that server and doing all your work and all your requirements. That is cloud computing. What you said is absolutely right.
Okay, sir. Before I was thinking like it's separate from server. Now I
No.
understand.
It's
Okay, sir.
same. It's pretty much the same. Yes. Any other doubts on servers? Yes. So again, just like our routers and switches, you have CLI. CLI means your command prompt to access servers and manage it. You also have the dashboard. Dashboard means you'll be having a web dashboard where you'll be able to manage all the details of the server, its storage, and all those kinds of details. And then the last one is remote access. Remote access basically means you'll be taking access of that server from your system. So it can be done by something called, let me just show it to you. Okay. So remote desktop connection. So you can gain that remote access just by using this. You can give the IP details of that computer here. If you have a username or password, you'll have to add it over something like this, like username and all these details will have to add. If no username is required, just give the IP and try connect, and you'll be connecting to that remote desktop connection, having access to that particular server, and you can use it basically like a normal computer. And by doing so, your computer's resources are not being used, only that server is being used at that moment. This is something.
Sir, even we can use any desk also, no?
You can use AnyDesk for this, but the thing is like, for that purpose, you have to install AnyDesk in that client server. I mean, that server as well.
Okay.
Sir, can we use remote desktop connection to log in for devices?
Can we use? I'm
Only
sorry.
for servers.
Could you repeat that?
So can we use remote desktop connection to access for devices, I mean network devices, or only for server?
Remote desktop connection is only for servers. You cannot use it for other devices because it does not have like a remote access. It has remote access just based on, it doesn't have an interface. For server, you can actually have either some Linux OS or some Windows OS installed over there, and you can actually use it as a computer because the server is a computer. Okay, server is basically a computer. Most of the time, you won't be setting up a monitor, but some servers comes with a monitor as well. So there you can directly use it on the console as well, no issues. But when it comes to routers and switches, it doesn't. It has an OS, but not as it like a computer. It has like a base OS which is used to do some kind of basic computational requirement. That's it.
So what is the topic which we are starting at what? What is network? So I need everybody to speak onto this. What is network? Quickly, one by one.
Interconnection of computers or local area networks.
Okay, good.
Network is interconnection of different devices over a single protocol.
Okay. What is that single protocol called?
OSI model.
OSI model. Okay, good. So somebody else, quick.
Ma'am, sharing information over devices is network.
Perfect, good.
Network is a global of billion of computer and other electrical devices.
Very good.
Group of multiple devices, we can say network devices as well, to transform or to transmit the data and the information.
Okay. Data and information. Someone else.
Network is a medium to communicate between different devices.
Medium. Communication. Good. I'm just picking the words what you guys are saying, right? In my class, you need to speak. I'll not be the only one who's speaking.
But basically a group of interconnected computers like to share data and exchange resources. That's it.
Okay. It's not a group of human beings.
Can I say
I mean,
more?
a group of human beings, that would be a different network. Like, but on the internet, it's a group of devices.
So that will be a social network, right?
Yes, that will
Right?
be, yeah.
And I just asked you what is network.
Yeah.
I didn't ask you computer networks, right?
Yes, exactly.
It's also interconnection of network.
Interconnection of networks. Perfect. Yes, we can say interconnection. Good. Interconnections. Perfect. I like this as well. Someone else now.
Is also a path of network.
Path of network. Okay. Try those guys, those they haven't spoken yet. Please continue. Those they have not given even a single word until now.
It is a collection of devices or maybe the nodes which can communicate and share things with each other.
Okay,
It's
devices and nodes. Good word.
It's like, for example,
Sharing.
we
Yes,
are
yes.
right now we are network. We are like people of 20 people of network right now. We are talking to each other, we are communicating with each other, we are sharing the information. So it's a human network, as you said earlier.
Okay. It's a human network now by which we are connecting, right? So can you tell me what is the thing which we are using to connect?
We are using internet services to connect.
Okay. Try to be little more closer to it.
Internet.
Okay, one
Resources
thing
of
is internet. Okay, other thing,
resources.
Multiple devices.
multiple devices. Okay, what else?
Zoom.
Wide
Zoom.
area
What is
network.
Zoom? What is Zoom?
Application. It's an application.
It's an application. So similar way, when we are looking at what is network, everybody has correctly answered me that it is a group of what? Connected nodes in which we can do what? We can have sharing, right? But before the sharing, we need what? Some of its components, right? So we must know the component of the network, then only we'll be able to talk about the benefits of it, right? So the next thing which we say, that is what components of network. What could be the components of network?
It could be infrastructure.
End user.
It
The
could be
first thing,
devices. Yeah, for
right?
use, obviously users, cables, connectors,
Right.
infrastructures. Yes.
Perfect. Then we'll come on to the infra, right? So when we say infra, infra is big, right? It's not small thing when we say infra. So infra will consist of what? Physical
Routers.
devices,
Yes, physical devices, access points, routers, switches.
right? When we say physical devices, we can say that these are endpoints. Like example, you might be connected with your iPhone, or you might be connected with your laptop, you might be connected with desktop, right? So those are the endpoints. Then we must need servers, right? Then we must need some set of what? Physical medium, have the physical connectivity, right? Then we must need the interconnecting devices. Right? We must need connectivity in terms of either LAN or in terms of what? WAN. Right? Or even though sometimes we say that we are connected with internet. Like right now we are connected with what? Internet. This all is what? This all is what? Connectivity. Is it okay? And once we do this, like these physical components we needed, endpoints, servers, physical mediums, connectivity devices, then we say we must need on this physical components, we must need some set of what? Software components. So what are those software components we need it onto these devices?
Zoom.
Where we
Zoom
would be hosting Zoom?
on the internet cloud.
On the
Okay.
server.
How are you able to access the Zoom? What exactly from your system you are using to access the Zoom?
Wireless or wired connection.
That is under the connectivity, LAN, WAN,
Ma'am,
internet.
actually we need the interpreter. We
Browser,
need
okay.
interpreter to connect the device, hardware to device.
Okay.
Use Zoom application.
Yes, sir.
Okay.
Like operating systems.
Perfect, Akhilesh. We must need what? Operating system, first of all, onto all this endpoint physical components. Be it is endpoint, be it server, be it is what? Interconnecting devices. Every device will have an operating system. So what is the operating system of your mobile phones?
Android.
Android and
Android or
Mm.
iOS, right? For iPhones, it is iOS, and for other, it's Android, right?
Ma'am, we can say the interpreter who can communicate with the hardware to user.
Yes, yes, you can say. But that could be the combination of everything. It will be the combination of hardware abstraction layer. It will be the combination of what? kernel, everything. So more specifically, which can be understood by everybody, we call it what it is, an operating system. Right? On the top of operating system, we install the applications. Like example, you are accessing the Zoom via the browser. Browser is also an application which is an inbuilt component of an operating system. And Zoom is an additional application which can be accessed via the browser. And correctly said by somebody that Zoom is hosted onto the cloud where there are a lot of servers. Right? So I can just simply say the applications. Right? And when we are talking about right now about the operating system and application, there is a new terminology which always we hear it, that is what APIs. Have you ever heard what is APIs?
Yeah, they are the connectors.
Yes, they are the connectors. Those they are connecting the logical components, which is software. So we call them what? They are the application programming interfaces. These interfaces are what? These interfaces are logical interfaces. The way we have the physical devices, connectivity of physical devices via the physical medium, the similar way the software components are connected via the APIs. The logical connectivities are through the APIs. Like how the Zoom server is connected with the Zoom client. They are connected with the help of APIs. Are we okay? So these are the components, and in case if I in case if I need to draw a diagram of the network, how can I draw that? So what I should say that what I'm having right now.
Physical cable.
Endpoint.
Endpoints. Good. So let's draw the endpoint. So let's say that we have an endpoint. A
Cable and cloud in between.
Okay, so we have an endpoint. So I'm taking it as a desktop only, right? So we are coming back to the computer networks from the social network too. Is it okay?
Yes, ma'am.
So let me draw another endpoint. And in the middle, you said there is what? There is something.
Cable.
Media. Media, which is internet.
Media. Interconnecting devices, right?
Yeah.
Or media. Let's draw the media also now. Is this okay? I can say this is the endpoint 1, EP, right? This is the endpoint 2, right? And they are connected with a physical medium. Is it okay? So is this a network?
Yes.
Yes. So what
Yes, we
kind of
can say the
network it
network.
is?
Peer-to-peer network.
Good.
Point to point.
Is this the link, ma'am?
So few people, they said
Link?
point to point. So what is link? Somebody was saying something.
Yeah, link, ma'am.
Nishant,
can
what
say it as a
link it
link.
is? Okay, it is a link. Okay. Somebody else would like to say that what kind of network is this?
LAN network.
Okay.
Ethernet.
Good. So I can hear the word point to point. I can hear the word LAN. I can hear the word Ethernet. Anything else? Okay, whatever I've written in the component of network is every physical component is part of it. Guys, quick.
Sorry, I didn't get what you asked. Can you
Okay.
repeat?
I'm asking whatever I've written in the physical component of the network is every component is the part of it.
Like
Yes, of
host?
course. Yes.
Yes.
Let's come back over here. Here are some physical component of the
Yeah.
network, right? So
Yes.
when we are coming back to this diagram, is every physical component has been covered over here?
No.
So we
No.
can say this is an example of the network and it could be a personal area network because it
Right.
does not have all
Yeah.
the physical components. So we can call it what it is, a PAN, personal area network. Yes. And
Yes.
this PAN is only connected with two devices,
Right.
right? So I can say with two endpoints. Is it right?
Right.
So this is just a simple example of personal area network, which is with two endpoints. And what have not been covered until now here, that is what the standards by which it is connected.
Right.
Right? So what is that standard? When I was asking what is network, somebody talked about that standard.
OSI layer.
OSI. Right? Or sometimes we call those standards are internet protocol suites. Right? So we give two kind of names to it. The first name is what? OSI standards. When we say OSI, it is Open System Interconnect Standards. Right? So this is the one type of standard. And there is another type of standard which we say that is what Internet Protocol Suite. So do you know the name of this Internet Protocol Suite?
TCP IP.
TCP and IP.
Perfect. TCP IP. Right? So we generally used to say that TCP IP is a protocol suite under the standards, wherein this open system interconnect is a reference. It is a reference, right? So when we say we have standards, so what does it mean that we have standards? That standards is both OSI as well as TCP IP protocol suite. Both are the standards, wherein whenever we need to get some references, we follow the OSI. And whenever we need to do the practical implementation, we follow what? TCP IP. Like example, if I need to deploy a network, I'll be using TCP IP. But when I need to teach somebody, I need to give some examples, I need to refer, I will be using OSI. So that's wherein I've mentioned or in the middle of them, not and. Right? So either you will be referring OSI or you will be using TCP IP to deploy the network. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yep.
Right? So as per the example, right now we are only showing you only one personal area network which is connected with two endpoints. That's it, right? So when we talk about the kind of networks, we generally use to say the networks could be what? Personal area network, local area network, based on the way we are defining their topology. Based on the way we are defining their topologies. So as I told you, personal area network is only belongs to me, right? Or it could be who is the owner of these endpoints, who is the owner of this physical medium. It will belong to that particular person. Wherein, when we talk about the other type of network, that is what? That is the local area network. It would expand, right? It would be expanding beyond the personal area network, right? And when I say expansion could be what? It could be within a home, it could be within a building, right? So that's wherein we used to say that it is a local area network, and it will have more number of devices, more number of endpoints. There might be possibility there are servers, there might be possibility there are interconnecting devices. Or this LAN could be what? It could be a wired network, or it could be a wireless network. So when we say wireless, there are access points coming into the picture.
Ma'am, what is the minimum number of endpoints to consider it as a LAN network?
There is no minimum endpoint numbers. The consideration is based on the location, you can say that, or the coverage area.
Okay.
Right? And that coverage area depends on to the connectivity of physical medium. So let's take an example. I need to create this local area network within a single building, right? So if I say single building, in that building, let's take there are 10 floors, right? Now in that 10 floors, I can have the local area network within one floor as well. And I can expand it, this local area network, to all 10 floors as well. Right? Now, there is another building which is very close to this particular local area network building, right? And if I'm having an interconnecting device that can expand on the basis of physical medium, the connectivity from this building, the previous building to this new building as well, then still it is a local area network. Right? So that's wherein we say that there is no limitation of the endpoints within the local area network. Only the thing what we need to see, the compatibility or the support which is provided by the interconnecting devices and the physical medium. Let's take an example. I'm using a physical medium which somebody talked about, Ethernet, right? So I'm using an Ethernet cable, right? And that Ethernet cable is giving me the connectivity up to 100 meter. I'm just taking an example, right? So if it is giving me the connectivity up to 100 meter, so 100 meter, can you guess that what will be the geographical area of that 100 meter?
Made a house or something.
Within a house, right?
But
And
ma'am, we can extend the LAN network to connecting switch or hub.
right, that's what I was about to say. I can connect an interconnecting device, and after that again I can connect that the 100 meter cable, right? So it will be extending up to now 200, right? Now both the ends of these two cables, I can connect another interconnecting device. So it will be extending again to 400 meters, right? So it depends how you can extend that local area network, or the support is provided by that devices, interconnecting devices or physical mediums. That's wherein we cannot limit the number of devices. Is it okay? So we generally used to say that it is within a building, or or what we can say that whenever somebody has to establish a small, medium business, they are creating the local area network. And when we talk about the small, medium business, they generally used to have up to 250 devices. Right? But we never say that for a local area network, it is up to 250 devices.
Actually, it's depend on IP classes.
No, you can extend the IP classes also as many as you can connect a router. Router will provide the routing between those IP classes.
Yes.
Yes. Right? So that's
Yes.
wherein there is no limit. It depends the support which is provided by the physical medium and interconnecting device. Right? Now, after the personal area network, we have talked about the local area network. After the local area network, there is another area network which we used to say CAN, campus area network. So which could be within a university campus, within a college campus, within a society where we have multiple buildings, right? So that is what a campus area network, right? So then there is another type of network which we used to call it what? Metropolitan area network, MAN, right? So it is metropolitan area network. And when we say metropolitan, generally it is within a city. And this cannot be owned by one particular owner. So PAN could be owned by an owner, LAN could be owned by an owner, campus area network can also be owned by an owner. But when we are talking about metropolitan area network, which is expanding within an entire city, that cannot be owned by one particular owner. It is based on what? It is based on the connectivity which is provided by the service providers within that particular city. Who is digging the land, who is laying down the cable and then giving the connectivity to the devices within that particular city. Right? So what is the difference if I say PAN, LAN and CAN? They are almost similar, only the geographical area is what? Expanded. Wherein MAN, it has what? An extra component, that is what? The connectivity provided by a service provider. Are
Any
we okay?
example of man?
Yes, I can give you an example of MAN. If I say this is personal, this is okay. So until this, it is what? Same, because we generally used to say it the owner, right? But wherein the metropolitan area and the WAN, wide area network, which is across globe, this cannot be owned by owner, right? For these, we must need what? Connectivity from service provider. Now, what is this service provider? Let's look at those service provider. Then you'll be able to reach to the examples of the MAN and examples of the WAN, right? So when we look at the service provider, so there are two different type of service provider. One is local service provider, another one is what? Global service providers. So local service provider, which is only giving the connectivity within that local area. Like example, who has asked me what is the example of MAN?
Ashish.
Ashish. So Ashish, you belongs to which particular part of India?
Kolkata.
Kolkata. Okay. So can you tell me that within the Kolkata, which society or which city or which you can say that town you are staying in? Okay. So Do you know that what are the internet service provider in your area?
Yeah, Airtel, Jio.
Airtel and Jio. Right. So apart from Airtel and Jio, do you have any another service provider?
I don't know, but it may be.
There is a multiple BSNL, Tata.
Okay. There is a
But
BSNL,
these are
there
the
is a
local.
Tata.
These are the local.
Which
Yes,
one
I
local?
don't think BSNL and
Tata. Tata is a local. Tata using BSNL on their backend.
Okay.
Reliance.
Reliance, Jio, right?
Yes, Reliance Jio also using the BSNL connection on their backend.
Okay. Okay, what is the difference between Airtel and Jio?
They are
Those
not
are the different
they have
service providers.
different
Just think and then answer me.
tiers, tier 1, tier 2, tier
Have
3.
different kinds of packages.
Okay. Okay.
With
Do we
respect
have
to the
do
bandwidth.
we have do we have the reach of Airtel outside India?
Yes.
Do we have the reach of Jio outside India?
Yes.
Okay. Do we have the reach of Tata outside India?
Yes. Tata is tier 1.
Okay.
Yeah, tier 1.
And Airtel is?
Tier 2.
Airtel is tier 2.
And Jio is?
Tier 3.
Tier 2.
Tier 3.
Tier 3.
How you have differentiated them tier 1, tier 2, tier 3?
This is based on the speed.
No.
On the basis of geographical area.
On the basis of their coverage, on the basis of their reach.
Yeah, actually,
Reach to reach to the entire globe.
yeah, actually, some of them like Reliance, Geo, they have submarine coverage. They pull up some links through the under the ocean for connectivity across the globe. I think that's where it is defined as tiers, where you have
Right.
Tata
Right.
has come initially, and then later on everybody took from Tata. That's why it's tier 1.
Okay. So let's do one thing. Let me share.
Yes.
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 Tier 1 internet service providers. Right? So if I write it down this, I'll be able to reach to a Wikipedia page. Right? Here is the complete internet diagram where you'll be able to see tier 1 network, tier 2 network, right? And then tier 3 network. Tier 3 network, those they have multi-home, those they have single home. Can you see this? And there is another word which is here, point of presence, POP. So these point of presence are the locations where these service providers, they have their devices available so that they can provide the connectivity. Like example, when I was talking about the reach of the local area network, I was telling you that we can do what? We can place the internet or we can place what? The interconnecting devices, and we can extend the cable. And that's wherein the location or the geographical area will be increased. Right? But there are some authorities in every location. Like example, let me reach back to Ashish. Ashish, is it okay if I ask some question from you?
Yes. Sure.
Yeah, okay. Ashish, can you create your own company who can provide internet connectivity? Yes, how? Like the way Airtel is there, Jio is there. Can you create your own company who can provide similar way that internet connectivity? Will you be able to dig the land and lay down the cables? Tell me,
Like,
Ashish.
It's very tough basically. Initially, it is very tough.
I think you need government approval just to be registered.
Okay, what kind of government approval is required, Hanu Prasad?
Oh God, there is some need some telecom something.
Okay, okay. Is it possible for anybody to go onto the road and dig the land and lay down the cable? Is it possible?
No.
Yes, it is possible if you have the manpower and money.
Basically, ma'am, we will take the information from the tier 3 infrastructure, that too from tier 2 infrastructure, and then we will relay this information to the customer, because we will be on the tier 1 infrastructure. We will have our own devices, we will have our own routers, but it will be contained on the tier 1 area.
Infrastructure. So you cannot create your own infrastructure. Thank you, Shashank, for sharing this. You cannot dig the land
Why we
because
cannot
that
create?
is, you cannot. You need to have a license from the telecom authority. There is already, there are, you can say that infrastructure available. For that infrastructure, always there are, you can say that telecom is giving you bid orders. So whenever they need somebody or whenever they wanted to, like right now in India, we have 5G, right? And we are even though listening that very soon there is 6G coming in.
No, that is related to spectrum, but we are talking
But
about
that's
the
okay.
fixed.
That's okay. That is an example, right? That is an example. So
But
5G is already there and the 6G is going to come. So who will be distributing 6G?
no, government
Tata,
authority is
Reliance or Airtel, who will be?
no government authority is releasing the spectrum.
Yes, government will release the spectrum, but who will be the service provider of that spectrum?
Whoever have the money, they can bid for the spectrum.
They can bid for the spectrum. The similar way, whosoever has the money, they will be able to bid the similar kind of parameter from the government when the government will be releasing that, okay, we need another company who can dig the land and go for it. So do you remember in past, you can say in the past 5 to 10 years back, if we talk about, we were not having fiber network in India, right? We were only using copper networks.
Yeah.
So who has laid down the fiber cable within the India?
Would be under the telecom authority government.
That is telecom authority government, but telecom authority government has given or has released a bid. Who has acquired that bid?
Tata, I
Which
believe.
company?
Tata.
Think about it.
I think Reliance.
You're talking about the copper line, should be BSNL.
Copper was BSNL. Now I'm talking about the fiber lines. Initially, we were only having copper lines. After that, we lay down the fiber. So who has actually laid down the fiber cables within the
Jio.
India? Yes, that is what Reliance and Jio. So they receive the contract from the government that they will be laying down the fiber cable. Other service providers, those they are in the telecom industry or those they are within the internet parameters, when they need to use this fiber, they have taken it on the lease from the Reliance. So we are getting fiber net from the Airtel as well. But that infrastructure is not for the Airtel. That infrastructure is, the base infrastructure is of Reliance. Are we okay? That correctly said by Shashank.
So basically, ma'am, Airtel is also getting internet from Jio. Is that correct?
No. We cannot say that they are getting it from Jio. They are using the fiber infrastructure of Jio.
Okay. Okay.
Okay. They are using the fiber infrastructure of Jio so that they can supply us fiber internet.
Madam, can I say like this? Like tier 3 is getting network from tier 2 and tier 2 is getting from tier 1.
Tier 1, yes, you can say that. Within the diagram also you can see it is like that only. So tier 1 were few companies, those they initially created the global internet. And when we see that, when we would like to know the names of those companies, within this page only you will be able to see those names as well.
I think Tata was there.
Yes, Tata was there at initial stage itself. So these are the names. As per their headquarters in which country, you'll be able to see all these names. You can see that Tata, previously it was BSNL, right? Within the India, right? So that is actually the tier 1. From India, this is only the tier 1. The rest of the companies are from US, Europe, and there are few from the Asia Pac as well, like entity from Japan, PCCW from the Hong Kong, right? So that's wherein you'll be able to see the entire tier 1, and similar way you will be able to even though find the tier 2, tier 3, right? So you can find out that information, right? Who has actually laid down the cable. So that's wherein we say, now let me come back to my whiteboard. I'll not be extending the information now from here. I'll be coming back. So when we are talking about MAN and WAN, we need what? Service provider. So now when we are talking about this fiber example, that who was able to lay down the fiber cable within the India? Jio, right? So Jio becomes what? A WAN, wherein Airtel was taking the infrastructure on lease from the Jio. So Airtel becomes what? MAN, because it was taking the infrastructure within a city and then was able to provide the fiber connectivity within that city. Then it has extended to another city. Then it has extended to another city. So slowly now, Airtel is able to provide fiber connectivity to almost entire India. But infrastructure is of Jio. Is it okay? Any questions around this? About the type of networks?
Ma'am, then what
No.
is so Tata called? Is it Tata also WAN?
Tata is tier 1. Tata is something who is bringing all this within the India.
So can we call it as WAN?
Yes, you can call it as WAN. Yes, Akhilesh, you can take lease for bandwidth from tier 1 as well, but tier 1 bandwidth will be expensive than tier 3 bandwidth. Okay. So there is another question which is pending. What is more example of APIs? So I'll give you more example of APIs in some time. Okay?
मैम
Okay,
Yes,
ma'am.
please.
मैम इन केस जो P2P लिंक लेते हैं, इन केस बैंगलोर टू मुंबई या मुंबई टू बैंगलोर लेते हैं, तो उस कंडीशन में क्या होता है मैम?
उस कंडीशन में क्या होता है?
हाँ,
आपने
मतलब
बैंडविड्थ
कैसा?
लेनी है।
या मैम जैसे 50 गिग का हमारा बैंडविड्थ है, मतलब कंपनी का है, ठीक है, तो
राइट।
कंपनी के मल्टीपल क्लाइंट है, जैसे एक क्लाइंट है रेप्रो करके हमारे यहाँ, ठीक है, तो उसका मुंबई से ऑलमोस्ट 60 to 70 किलोमीटर डिस्टेंस है हमारे यहाँ
राइट।
से, तो उसका लिंक है 100 गिग का, मतलब पेयरिंग टू
राइट।
है, एक लैंड वैन का है, एक संस्कार का है, ओके, दो
राइट।
आईएसपी है,
राइट।
ओके। तो इसके अलावा भी हमारे कई क्लाइंट है, ओके, तो हमारा डाटा सेंटर है मैम, तो वहाँ पे मतलब मल्टीपल क्लाइंट है, तो ऐसे हम लोगों ने पेयरिंग दिया है P2P। तो क्या उनका मतलब कनेक्शन कैसा रहता है मैम? क्या एसएपी वगैरह में कुछ चेंजेस रहते हैं या फिर क्या रहता है?
Okay.
Yeah, ma'am.
उनका connection कैसे रहता है? Please, this will be something outside the CCNA, right? But everybody will get benefit of it, right? So that's wherein I'll be drawing this. क्या होता है? एक service provider क्या करता है? If I talk about the service provider. यहाँ एग्जाम्पल ले लेते हैं हम सर्विस प्रोवाइडर का, किसका? एयरटेल का, बिकॉज एयरटेल इज इनटू कॉर्पोरेट मार्केट, राइट? एयरटेल बहुत ज्यादा इंडिया में कॉर्पोरेट मार्केट के अंदर है, विच इज प्रोवाइडिंग internet connectivity to almost all the you can say that companies, be it is local Indian company or be it is MNC. So Airtel is providing most of the you can say that background. So if we look at it, what exactly Airtel does? Airtel, I'm just taking an example of Airtel, or I can say any service provider, right? So what the service provider does, they are creating their own network. Like how they are creating their own network? Is there anybody who is having any idea? Like I know that there are few people, those they are from Orange, from BT, from Capgemini, right? Do you have any idea how the service provider they are creating their own networks?
Using routers.
Using devices, and those devices are available at different point of presence, right? So let's take an example. This service provider is having a point of presence available here. Let's take this as the location. Let's take this. This is something like the square-like structure, right? Can you see now this?
Yes.
Right? Okay.
Yes,
So
ma'am.
let's suppose that this is what something which is the location where the service provider they have their reach. We call it what? Point of presence. So this is one, and it is somewhere located in Delhi, right? Then another point of presence which is I'll say that this is two, and it is somewhere located in Calcutta. I'll say that KAL, Calcutta, and this is somewhere and this is the point of presence which is somewhere available in you can say Mumbai, right? This is another point of presence POP4, which is somewhere in Chennai, right? So I'm not writing full form. You can understand Delhi, Calcutta, Mumbai, Chennai, right? This is another point of presence which is available somewhere in. Give me some name of India.
Hyderabad.
HYD, Hyderabad. Okay. Point of presence 6. It is in Bangalore, right? So all this is what the different city point of presence that service provider has already created their network. Now on these point of presence, they have their devices, and they have created what? They have created point to point connection between these devices, these locations. Already they have you can say that connectivity between this point to this point. So this is now the service provider network. Now, whenever the service provider has to give the connectivity to any of the customer, it is very easy for the service provider to provide the connectivity because their network is already ready. They have the reach available in Delhi, Bangalore, Hyderabad, Chennai, Mumbai, Calcutta, or any another city of the India. They have already have the reach. right? And they can easily connect their customer to the nearest point of presence. Like example, now I say there is a customer who is having one branch available in Calcutta, right? And one branch in Bangalore, right? Now this customer would like to connect these two branches, right? So customer branch 1 and this is the customer branch 2. So now this, the circle is what? Customer branch 1 and customer branch 2. Now the customer would like to have the connectivity between these two branches. So what will happen now? How this connectivity will be? It will be so easy for this service provider to establish the connectivity between customer branch 1 and branch 2. They'll be connecting it to nearest point of presence. It will be just nearest point of presence. And from here also, just to nearest point of presence. This connection is already there in place. Between Bangalore and Calcutta, there is already connection, right? So they just need to just do what? Lay down the cable quickly from the Bangalore point of presence to the customer branch 2 and Calcutta point of presence to customer branch 1, and they can quickly provide what? The connectivity. Is it okay?
Yes, ma'am.
So is this answer your question?
Yes,
How
ma'am.
you are able to provide 50 gig connectivity or point-to-point link from your data center to your customers,
Yeah, ma'am. Right.
right? So it is very
Right.
easy because already the service providers, they have their reach available within the location they are residing in.
Okay.
Okay. And now
Yes,
we
ma'am.
used to say what? We generally used to say that now the service provider is having what? A VPN connected, right? And this VPN is
Right.
having what? 3 different physical connection in the middle, right? This is the first
Right.
part of it. This is the second part of it, which is the service provider network. And this is the third part of it. These 3 physical connections are bringing a virtual connection. And we used to say it what? Now the branch 1 and branch 2 is connected through a
Okay.
VPN,
Um,
right?
right, ma'am.
So this is a virtual private network which composed of 3 physical networks, right?
Yeah, right, ma'am.
Okay, done. So this is, as I told you, that it is something outside the CCNA. It is not the part of CCNA, but still it will give everybody a good understanding, right? So let me now come back to the previous part where we were talking about networks. So are we okay with this different type of networks? Personal network, local area network, campus area network, wide area network, and metropolitan area network.
Madam, can you explain the span LAN CAN MAN WAN concept in the previous example? What is
In which
span?
example?
The previous example, can you explain? What is
What is
span
this?
here? LAN, CAN, MAN and WAN.
Okay. PAN LAN CAN does not need to have service provider connectivity.
Okay.
Okay. So man and when I'll be able to explain in this example.
Ah.
Okay. So man means what? That there is a branch which is in the same city. So when we are connecting customer branches in the same city, it is man. But when we are connecting customer branches in different cities, it is wide area network. So let's take an example. There is another branch of the customer which is again in the Kolkata only. So both the branches, branch 1 of the customer and branch 3 of the customer, if they are in the same city, it is metropolitan area network. Okay. And
Same city.
yeah, for the WAN, it is in different cities, right?
Cities. Okay.
And
Ma'am,
PAN,
what is the
LAN, and
relation?
CAN does not need what? Service provider.
Ma'am, what is the relation between CAN and intranet?
Yeah, that is different type of network. I'll come on to that in some time. Okay,
So,
just allow me some time.
okay, ma'am. Just one thing, that intranet is always contained on campus area network or
No,
organizational area network, something like that.
no. No, it's not like that. I'll let you know what is internet, intranet, and extranet. These
Okay.
three are different type of networks.
Okay.
Okay, so I'll be parking this for some time. I'll answer you this. I'll make sure that it needs to be answered. Okay. Okay. So are we okay, guys, with this?
Ma'am, I have one question.
Yes, please.
Ma'am, Tata being a tier one, it's not popular among ISPs in India like Airtel and Jio.
Right.
May I know
Because it is tier one. It is just giving their infrastructure on lease to tier 2 and tier 3, and then they are earning. Why they need to come to the retail market? Think about it. There is a factory manufacturer. That factory manufacturer will go to the end point to sell their products.
Okay.
No, right? They'll just be selling to the wholesalers. And then wholesalers will be selling it to the shopkeepers, and we will go to the shop and buy the product. Is it right?
Yeah.
So they don't entertain the retail market, but they are the main wholesale earner of the infrastructure.
Hey there. Continue learning directly from industry experts. You are watching these recorded topics from our master's program, but you can watch it live by joining any of these master's program, where you can become an IT engineer that too without coding. Now you can
That's the reason
continue.
Tata is not so popular because endpoints are not directly buying the connectivity from the data. That's
But
wherein we are not aware it that, but actually that is the main source who is providing the entire infrastructure within the India.
but they do give broadband connections.
Yes, they do give broadband connections. They provide everything. There is one vertical they have created who is dealing into what? Endpoints. Right
Okay,
now,
ma'am.
if you see, Tata is into what? Every business.
Yeah.
Right? So
Yeah.
they have created one, you can say that vertical within their organization who is dealing into what? Retail market as well. So that's wherein they are providing the broadband as well. And that's wherein their broadband is what more cheaper. Remember when the Tata Sky? What is Tata Sky?
Dish.
Dish. Is it popular now?
Not much.
But that was the Dish TV first introduced, right?
Yes.
Yes. Okay. So Tata is into what? Every market. When they are bringing something, they are coming into what market, and then after that they are doing what? They are selling that thing or they are leasing it to the other providers.
Tata is king of networks.
Right, you can say that. Okay, next thing is what? Let's take an example. There is a company who is manufacturing healthcare products. So if that company is manufacturing healthcare products, their main focus onto their own business, right? Into healthcare products only. So will they do something related to networks?
No, ma'am.
No, they will outsource their network
Yep.
to some organization. You take care of my network because my main focus is into what in my own business, which is healthcare. I need to focus on the products. I need to focus on to the quality of the products which I can give to my customers, right?
Yes.
So that's the you can say that life cycle chain of life which is there in the market. Okay.
Okay.
So let's now come back again to the span, LAN, CAN, MAN, WAN, which we have covered as a type of network, right? Now somebody talked about point to point. Was also one word which came in when I was talking about what kind of this network. So we sometimes even though categorize network into what point to point networks and point to multi-point networks. Now point to point network, it is a interconnection between two devices. And wherein when we say point to multi-point, it is an interconnection between multiple devices or multiple nodes, right? So when we say interconnection between multiple nodes, we need a central device for this so that it can be a multi-point connection. So when we look at this type of network, it is clearly an example of point to point because direct two devices are connected, right? So when we'll be having multiple devices, we would need a central device in the middle to have point to multi-point connection. Like example, Zoom application is giving us point to multi-point connectivity. Then the other type of the things which was here, that is what Ethernet. So Ethernet is based on the physical medium. If the type of physical medium is Ethernet, we will call it what it is an Ethernet network. So Ethernet network can be an example of PAN, LAN, CAN, MAN, and WAN. So Ethernet cable is available for personal area network, for local area network, for campus area network, for metropolitan area network, and for wide area network, right? So we generally used to say Ethernet until this. I need to come back with the pen. Until this, we used to say it Ethernet, and here we used to call it what it is, Metro Ethernet. It is Metro Ethernet. So there are different cables for Metro Ethernet, and there is different cable for the Ethernet based on the bandwidth required. Okay. Different devices for Metro Ethernet, different devices for the Ethernet when we need to connect these kind of networks. Okay, so these were the few words which you have used. So I wanted to explain these words. So that's the reason I'm giving you something like this, point to point and point to multi-point, Ethernet and Metro Ethernet. Now coming back to the another question which was being asked, that was related to intranet. Now there is a term we used to say intranet, and there is a term which we used to say extranet, and there is a term which we used to say that is internet, right? So internet is, everybody is aware, the connectivity of
Networks.
www. What is www?
World Wide Web.
World Wide Web. It means you will have the reachability of everything which is hosted on World Wide Web. So we are calling it, it's a public network. It's a public network, right? Wherein intranet and extranet, they are the private networks. They are not the public networks. Private network is private to somebody. Public network, anybody can come and connect to the public network. So internet is public network and private network is what intranet and extranet. Intranet, when we are connecting same organization. It is intranet. Wherein when we are connecting different organization branches, it is extranet. Now, why do we connect different organization branches? There might be possibility they are partners, business partners, right? That's the reason we are connecting different organization branches. Or sometime like one organization has acquired other organization, then we need to connect both the organizations together because they have acquired it. So we are creating extranet between them. Is it okay? What is intranet,
Ma'am,
extranet, and internet?
ma'am, I have one thing to ask that in
Yes.
internet itself is a network of different networks, right? But so if any data flows in internet, there are multiple different routers that pass on those data. But in extranet or in intranet, there will not be different devices that will help the information to pass on. So how the information will pass on in intranet on extranet?
See, where is my diagram? Here. When I say the customer branch 1 and branch 2, they are connected. It is an example of intranet.
That is what am asking कि let's take an example. इंटरनेट में मैम बीच में बहुत सारे नेटवर्क्स होते हैं
यहाँ भी तो बहुत
बहुत
सारे नेटवर्क्स आए ना, देखो कोलकाता का पॉइंट ऑफ प्रेजेंस है, बैंगलोर का पॉइंट ऑफ प्रेजेंस है.
बट विद इन ऑर्गेनाइजेशन में हम लोग वो सारे
There might be
सारे
possibility. There might be possibility. This line is down. They are transmitting this connectivity via Calcutta point of presence to Delhi point of presence, and then they are sending it to the Bangalore point of presence.
मैम
What
आप
number of devices are there, right?
मैम लेट्स से कि मेरी खुद की कंपनी है, ठीक है, और मेरे 4 ब्रांचेस है, दिल्ली,
Right.
कोलकाता, बैंगलोर और मुंबई, ठीक है.
Okay.
तो और मुझे इंफॉर्मेशन पास ऑन करना है दिल्ली टू कोलकाता और
Right.
वाया वाया इंट्रानेट, ठीक है. और जब मैं
आप
इंटरनेट
सिर्फ इंट्रानेट के थ्रू ही इंफॉर्मेशन पास ऑन कर पाओगे.
हाँ, तो अगर मुझे इंट्रानेट के थ्रू अगर इंफॉर्मेशन पास ऑन करना है, अगर मैं इंटरनेट का हेल्प नहीं ले रहा हूँ, अगर मैं इंटरनेट का हेल्प नहीं ले रहा हूँ, तो मैं इंटरनेट के थ्रू कैसे इंफॉर्मेशन पास ऑन कर पाऊंगा?
This is
क्योंकि
intranet.
इंटरनेट में तो बहुत सारे
Think,
नेटवर्क्स.
think about it once again. Look what I have written it. Intranet is a private network. Internet is a public network,
Yes, ma'am.
right?
Ma'am, I
In this
think he's
in this
getting
diagram,
confused.
wait,
He's
wait,
getting
wait, wait, wait. Wait, 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 wait. Don't make him confused. Once again, I'm explaining him. In this diagram, it's a private network, right? And private network is always an expensive option, but it is secured.
नहीं, मेरा क्वेश्चन ये नहीं है.
अभी रुको,
मेरा
अभी रुको,
क्वेश्चन
अभी रुको. Wait, wait. Think about it. Whenever you need to pass the information, you have two ways: private or public. If you would like to pass it through the private network, it will be secure. If you want to pass it through the public network, it will be unsecured. In both the condition, it will pass through multiple devices. In both the conditions. You are using WhatsApp. So when you are transmitting your message through WhatsApp, WhatsApp says what? Have you ever seen the WhatsApp ad?
Yes.
So what is the message they are giving you in the WhatsApp
Those are
ad?
end-to-end encrypted.
It is end-to-end encrypted, right? So it means it is secured. Your information is passing through multiple devices or not? Answer me.
Yeah. क्या
Your
मैम?
information is secured, right?
हाँ जी, yeah.
If in
Yes.
case you will send the same information through a different messenger, which is not providing you end-to-end encryption, still you are connected with the internet only. Still you are connected with the internet only, right? In the WhatsApp also you are connected with internet. In other messenger also you are connected with internet, but one is giving you private connectivity and other one is giving you public connectivity. In both the scenarios, your information is passing through with multiple devices. So what is the difference between intranet and internet? Internet is insecure, public. Intranet is private, it is secured. And you need to pay extra for private network. Okay. Now once again ask your question in case if it is not clear.
और एक कंप्यूटर है दिल्ली लोकेशन पे, ठीक है, और एक दूसरा कंप्यूटर है कोलकाता लोकेशन पे। तो दिल्ली लोकेशन वाला जो कंप्यूटर है वो अपना इंफॉर्मेशन पास किया अपने अपने राउटर को, उस राउटर ने इंफॉर्मेशन पास किया अपने नियरेस्ट जो सबसे बेस्ट पाथ पे जो राउटर है उसको किया। लेट सपोज दिल्ली ने वाया गाजियाबाद करके फिर कानपुर होके वो इंफॉर्मेशन पास होते होते वाया राउटर होते होते वो कोलकाता चला गया। और वो जितने भी राउटर्स होंगे वो डिफरेंट डिफरेंट नेटवर्क्स के होंगे, ठीक है। तो एक ये कॉमन अंडरस्टैंडिंग की इंफॉर्मेशन कैसे पास ऑन हो रहा है। लेकिन अगर हम इंटरनेट की बात करें तो वो इंटरनेट जो है वो तो डिफरेंट नेटवर्क्स की हेल्प तो ले नहीं पाएगा, क्योंकि वो तो सेम विद इन द ऑर्गेनाइजेशन इंफॉर्मेशन पास ऑन हो रहा है। तब वो अपने इंफॉर्मेशन कैसे पास ऑन कर पाएगा दिल्ली टू कोलकाता, क्योंकि वो तो अब राउटर है। राउटर अगर दिल्ली वाला जो राउटर है वो डिफरेंट नेटवर्क्स जो दिल्ली में
दिल्ली वाला राउटर किसको देगा? अपने नियरेस्ट पॉइंट ऑफ प्रेजेंस को। वो किसको पास कर देगा? सर्विस प्रोवाइडर को। और सर्विस प्रोवाइडर किसको पास कर देगा? डायरेक्टली उसको।
सिक्योर्ड कैसे होगा अगर ये भी डिफरेंट डिफरेंट नेटवर्क्स यूज कर रहा है तो?
बट आप इसके लिए पैसा दे रहे हो ना इसको, सर्विस प्रोवाइडर को। इसकी रिस्पॉन्सिबिलिटी है आपके इंफॉर्मेशन को सिक्योर करना। इसकी रिस्पॉन्सिबिलिटी है आपको वीपीएन प्रोवाइड करना।
Within organization, like if it is passing through various ISP, right? And that is not our ISP, and it is going through various routes, right? But that is not within the organization. But what is the exact within the organization and intranet? Is that any VPN that we are using?
Yes.
Okay, so for everything that is VPN, and when it's go to router or any specific routes, it will be encrypted.
Think once again about it. Private and public. Right? I'll just say it right now, only focus onto these two words, private and public.
Ma'am, are we currently on a private network on secure end-to-end?
Yes, we are on private network. But that private network is connected through the internet.
Okay.
Because you are connected to internet, I'm connected to internet, right?
Yeah.
When you have joined today this meeting, were you able to join by yourself?
Yeah.
Or it was giving you a message that wait, host will allow you.
Oh, yes. Before yes.
Yes?
Yes.
So as soon as it said that host will allow you, it means it becomes what?
Private, more secure.
Private network, ma'am. Secure network.
Okay.
Right?
Understood.
Understood? So that's
Ah.
wherein I don't want to go in depth. I wanted to just bring your focus here. Think about private and public. So there is that. Now I'll come to that shit. We used to say there is a public toilet and there is a private toilet. Which one you'll prefer to use?
But it is
Depends on
costly.
the situation.
Okay, but it is more understood, right? So now you have the your own benefits with the private and public one, right? So
Yes.
private one will be expensive, yes, but public one will not be expensive. But there are lot of disadvantages of the public one. Come back now again. So I'll give you more examples in case if you are unable to understand the complete connectivity of intranet and extranet, because I need to teach you a lot. I need to teach you protocols. I need to teach you routing. Then after that, you'll be able to understand what is intranet and extranet, right? How do we transmit the complete information? What is the packet flow within the VPN or within the physical connections? So all this needs to be explained. Then only you'll have more insight of intranet and extranet, right? So maybe when I'll be teaching you that, I'll make sure that this needs to be again go through in depth, right? So as of now, you just focus onto the private and public one. What is private? What is public? When we say private, it means the service provider will provide you a private line to pass the information. When we say public, service provider will give you public connectivity. It's your packet will choose what is the path available. I'll go by myself. Okay. I hope it is answered now.
Yes. तो मैम
Yes, ma'am.
बेसिकली क्या है कि जो सर्विस है वो सर्विस जो इंटरनेट है वो सर्विस प्रोवाइडर के ही थ्रू मिल रहा है.
Right.
इट्स जस्ट कि इंटरनेट के लिए उसके पास एक अलग सिस्टम है, प्रीमियम सिस्टम है, जिसमें वो एक डेडिकेटेड रूट आपको प्रोवाइड कर देगा और
Right.
बोलेगा कि आप इसी रूट के थ्रू अपना इंफॉर्मेशन पास ऑन करो और आप दूसरा रूट यूज नहीं करोगे. और
नहीं,
बाकी
दूसरी
के लिए
ऑप्शन हो गई उसके पास. अगर पहला राउट डाउन हो गया तो वो आपको क्या करेगा, सेकंड राउट पे रीडायरेक्ट कर देगा, बट वो भी
लेकिन
आपके लिए प्राइवेट रहेगा.
हाँ, वो भी सिक्योर्ड रहेगा. और
राइट.
पब्लिक के केस में क्या होता है कि वो जनरल रहता है कि आप किसी में भी इस रूट से चले जाओ, XYZ कोई भी रूट से चले जाओ, दैट डजंट
राइट.
मैटर.
ओके. एंड
समथिंग
अनदर
लाइक दैट.
एग्जांपल इज व्हाट, आपने उबर लिया and you went to your destination, right? And that becomes what, private to you. And public means what, you are taking one bus, then another bus, then maybe metro, then you are reaching to your destination.
मैम तो उसके बीच में एक चीज और बस कंफर्म करूंगा. उसके बीच में दिल्ली से कोलकाता के बीच में कानपुर भी आता है, पटना भी आता है और हावड़ा भी कोलकाता आता है, मतलब कानपुर,
Right,
इलाहाबाद.
let's take many locations, right?
हाँ, तो मतलब मैं मेनी लोकेशंस के ले रहा हूँ. तो एक आईएसपी के पास मैंने रीच आउट किया, बोला कि मुझे एक सिक्योर्ड कनेक्शन चाहिए. तो उसने बोला ठीक है मैं आपको दूंगा और वो सिक्योर्ड कनेक्शन मुझे प्रोवाइड करता है. और वो जो कनेक्शन मुझे प्रोवाइड करेगा वो दिल्ली से शुरू होके इलाहाबाद जाएगा, फिर कानपुर जाएगा, फिर पटना जाएगा, फिर होते हुए वो कोलकाता पहुंचेगा. तो
Right.
डिफरेंट बीच में डिफरेंट हाँ
Right, routers रहेंगे,
डिवाइसेस रहेंगे, बट वो भी सिक्योर्ड लाइन में रहेंगे.
secured
दे
line में
ऑल
रहेंगे.
दे विल ऑल बी इन द सिंक वाइल
Yes,
सिक्योर्ड कनेक्शन.
by secured connection.
Computer networks, what, why, and how. We all know that we always use internet. Okay, we always use internet to do some of our basic stuffs. Nowadays, without an internet, we cannot even kill our time. Right? So we use Facebook, we use Google, we use Netflix, we watch sports. All of that is running over the internet. So all the discussion that I'm going to do today is based on real-time examples. So on the screen, you can see there are two people. You can imagine one as yourself and the other person as your friend. So this is you and this is your friend. Right? Now, basically, what we always see is that even now you are connected to you are connected to internet via mobile. I'm connected to the internet via Wi-Fi router, right? And that is all that is visible to us, right? So my laptop is connected to a Wi-Fi router and it is sending the signals, right? That's all that is visible. Similarly, your laptop or your phone is connected to your Wi-Fi router and it's sending some signals. That is all that you are aware of. But there are lot of things that goes after or beyond the Wi-Fi router. So here, these are the Wi-Fi routers of our homes. And what happens between these two Wi-Fi routers? How do they send a message? For example, your friend or me or yourself, you send a hi over Facebook or over WhatsApp. It goes to your friend's mobile phone or whatever application that he is using, and he can read your message. Also, you will be able to find out if he has read the message, if he has seen the message, or if your message has been received to your has been sent to your friend's phone or not. All that information that is being exchanged between your friend's phone and your phone is what computer networks all about. The study of that, how two devices talk over a network or a wire, is the study of computer networks. Okay. Now, before we jump into that discussion, and if you guys have any doubts, feel free to ask me anytime, interrupt me anytime and ask question, right? Now, before I move on, I wanted to know what you guys understand by the word internet. All of us always use this term internet in our daily lives, right? What do you understand by internet? Can someone tell me?
It's like a network of networks.
All right. Someone said network of network. Let me note that down. Network of networks. Anyone else? What do you mean by internet? You can speak up. It's like, sometimes I may not be reading the messages. So someone has said interconnection of networks. Yes. Interconnection of networks. Anyone else? Let's make this interactive.
Yeah, hi.
Yeah.
Yeah, hi, good evening. So, basically, network is networks of network. So, we can communicate to each other with the help of network.
All right. So, communication with networks. All right. So, all of these answers are subjective. The word internet itself is a very subjective. Okay, there's no definite answer to it. So that's why all these answers are correct. Right. Now, before we actually jump onto the actual definition of internet, let's just look into this diagram. Okay. So you can see that there are a lot of devices, right? You can see laptop, you can see a mobile phone, sorry, a telephone, a mobile phone, a server, right? And not just this, servers are connected to each other. These devices are connected to each other. Similarly, not just them, there are other devices who are connected to each other and they're forming their own small group of interconnection, right? And these small devices themselves are forming a group, and that group in computers, right, in the terminology of computer, is called as a network of devices, right? So let's take the example of your home, right? You have a Wi-Fi router, right? And that Wi-Fi router is sending signals. And using the Wi-Fi router, your mobile phone is connected. You have a smart TV that is also connected. And If your parents are using a mobile phone, they are also connected to the Wi-Fi router. You are using a laptop, that is connected to the Wi-Fi router. So what is happening? All of these devices have formed a small network of their own, right? So not only these devices can talk within themselves, they can talk to a network which is outside their Wi-Fi router's connectivity, right? So for example, you are talking to someone, let's say you're talking to your cousin. Your cousin obviously is not living with you, he is living somewhere else, right? So even he or she has a Wi-Fi router in their home, right? And that Wi-Fi router is again connecting different smart devices together, right? So this itself is a small network, and these two, so you can talk intra network, you can talk among themselves within your own network, and you can also talk inter network, right? And that is what you mean by internet. Interconnectivity or intercommunication of networks is called as internet. So many people think Google is internet. That is what people say. Go to Google. Google is internet. No, Google is not internet. Okay. Internet is a connectivity of two different networks. Internet is, in other words, is a path to reach Google network. Google in itself is a small network, not small, it's a big network, right? Google is a network. Amazon is a network, right? Netflix is a network. Our Network King's website itself is a network, right? So connecting these networks is what you call internet. And how are these devices or how are these networks connected together is the study of computer networks, which basically is told in your CCNA, CCNP, and CCI subjects. Okay. Any question up till here? So when I say, okay, so we have in our school days, right? We had inter-school competitions. Inter-school competitions. What do we mean by inter here? That means this is school number 1 and this is school number 2. So the competition is between two different schools, and that's what we call it as inter-school. Similarly, international. When we say international, that means two different countries, right? Now, when I'm talking of intra, when I say intra, it means within the same school. So when you have, like, we in my school time, we had 4 different houses, right? House number 1, 2, 3, 4, right? So the competitions was happening between the 4 houses. So basically the competition is happening inside the school, and that's what we call it as intra. So similarly, intra communication means communication within the same network. Intercommunication means communication between two different networks.
And coming to the other layers, I think up to 5th layer, the PDU will be data, and at the section layer, it will be packets, and transport layer, it will be frames, right?
No. Yeah. So coming to the first layer, the physical layer. Okay. On the screen, you can see there are different type of cables, right? So you can see we have an audio video cable. This is a fiber optic cable. This is a USB cable, HDMI. Sorry, this is an HDMI cable. This is a RJ45 CAT cable, etc. And this is our USB B or C cable, right? So we always use cables in order to transmit data. In order to transmit the data, we use a lot of cables, right? And where have we witnessed these cables the first time? Probably when we when at our home we had a landline phone, right? In our landline phone, right, the connection would have been something like this, the landline phone. And in our computer labs, we would have seen a LAN cable like this. Or for our TV, when we have the satellite cable TV connection, we would have had this kind of cables, right? So without even today, 90% of the world is connected through wire. Without wire medium, internet is not possible. Interconnectivity is not possible. I will not be able to talk to you. You will not be able to hear me without internet and without wires. Okay. You can ask, you can say, I'm using phone, a mobile phone. I'm connected through the Wi-Fi. I'm not connected through a wire. You can also say, I'm connected through my data, internet data. I'm not using my Wi-Fi modem. I'm directly using my internet. I'm still not connected to wire. But again, let me just give you an example. My laptop, right, is connected to my Wi-Fi modem. Right? The Wi-Fi modem at your home also is connected through a cable, probably a fiber optic cable or an RJ45 or a what do you say? Forgot the name. Sorry, I forgot the name. It is connected to a cable.
Copper cable.
Copper cable, fiber cable, or an RJ45 cable, any Ethernet cable, right? So, and then it is then sending these signals to the nearest device. Again, this is a wire. Your wireless connectivity is only limited up till here. The second scenario is you're using internet, your data internet, not your broadband internet, but your data internet. Your phone is basically sending information to the nearest mobile tower, right? And this mobile tower is then receiving that information and sending information through a wire to the next mobile tower. Again, they are connected through wires. So as I said, most of these devices or your networking devices are connected through wires, and without wires, internet today is not at all possible. Coming to the second layer. Okay, coming to the second layer, that is the data link layer.
सर RJ45 और कॉपर में क्या डिफरेंस है?
Basically देखो RJ45 एक just you see this not yeah ये वाला this one RJ45 मैं diagram दिखा देता हूँ. I'm sure you would have seen these cables. These are your RJ45 cables. Okay. Now, there is no difference between RJ45 and a copper. The thing is, the wires, the way they transmit the information, right? This is only RJ45. This part is only RJ45, right? And inside these wires, they are made of copper wires. That is why they are called as copper cables, right? So if you ask me what is the difference between RJ45 cable and a copper cable, a copper RJ45 cable is made of copper cables, and there are different types of copper cables. You have twisted copper cable, untwisted copper cable. You have all those things you would have read, right? And we'll see that in tomorrow's class.
इंटरनेट केबल है ना, इंटरनेट प्रोवाइड करने वाली.
ये ईथरनेट केबल बहुत ही कॉमन टर्म है. ईथरनेट केबल नहीं बोलते, टेक्निकल टर्म इसका RJ45 केबल है.
तो मतलब ईथरनेट केबल कुछ नहीं होती, वो RJ45 केबल्स होती है जो राउटर से कंप्यूटर पे लगी होती है.
हाँ, नहीं, राउटर से कंप्यूटर पे कंसोल केबल लगती है.
अच्छा, फिर मतलब वो जैक से जो राउटर पे आ रही होती है वो ईथरनेट केबल है.
जैक से
I think like she's talking about that cable which we always get from the when we buy the Wi-Fi routers and all, we always get a set of cables. That's the RJ45 which gets connected with the router to these computers.
She's talking about the cable which is connected on the NIC card.
Yeah, might be.
Okay, probably I may be getting confused, or
That is
I may be right or
that is
not wrong.
RJ45 only. That is RJ45
Yeah,
only.
it's an RJ45 only. Exactly.
Yeah. Okay.
Basically, we call it Ethernet and all.
All right.
Dual names.
Okay. So मैं यही बोल रहा था कि ईथरनेट केबल और RJ45 केबल दोनों एक ही होता है, ठीक है। ईथरनेट केबल हम कॉमनली बोलते हैं, ठीक है, बट उसको वो एक्चुअली उसका एक्चुअल टर्म RJ45 केबल होता है।
RJ45 is just a connector, right?
That is also true. That is also true. But we call it, again, as we call it as an Ethernet cable, we call it as an RJ45 cable also.
Okay.
Yeah. Now coming to our data link layer. Right. Now let's first of all let's go behind the history of connectivity. So I believe the computers, okay, I believe the computers were invented to do faster mathematical calculations. Okay, faster maths. Okay, and we achieved it. Obviously, computers were able to do faster mathematical calculations. We were able to even stop World War II with the help of computers. What happens is, as your technology started to develop or go beyond, we wanted two computers to start sharing their mathematical information with each other. Okay, so what we did, we created some mechanism where they could talk to each other. So we gave them some ports, we connected them through wires, and they started sharing information. How do they share information? Why do they share information? Let's ignore that or keep it aside. Let's just understand some history through a story. Right. Now, as again, more and more computers started to come up, we thought, let's have these computers share information with each other. So what we did, we started interconnecting these guys together. Right? So what happened was, as more and more computers started to come up, as more and more information wanted to be shared, we wanted more and more ports or interfaces or facility to connect different or multiple wires into one single computer. With just 4 computers, we can see that PC number 1, okay, needs 3 wires to connect to these 3 other PCs. Similarly, PC number 2 needs 3 wires, 3 and 4. Both these PCs need 3 wires to connect to all the other devices. Right? Just imagine if there are 1,000 devices, 10,000 devices. Right? We know computers started to evolve very quickly. With that, we could not afford, if there are, for example, if there are, just imagine if there are 100 computers in a room and you want 100 computers to talk to each other. On PC number 1, you should have 99 different ports. Was that feasible? No, that was not feasible. So what we did, we said, we invented or we created one device called as a hub. Okay, called as a hub. Hub was the first unintelligent device. Okay, why unintelligent? I'll tell you just now. Unintelligent device, but it had a useful purpose. The purpose was, if any information is sent by PC number 1, okay, what the hub will do is, hub will copy it and create duplicates of it. And send it to PC number 2, PC number 3, and PC number 4. So any PC sends any information, it is basically duplicated by hub and shared with all the other devices that is connected to the hub. So if I connect 2 more devices here, right, these devices will also receive any information that is shared by, for example, PC number 4. PC number 4 sends some information. This information is then sent to PC number 3, 5, 2, 1, and 6. Okay, this was going okay, perfectly fine. But then we said, we came up with a requirement that I do not want PC number 3 and PC number 4. I do not want them to send some information. I want to send information only to PC number 2. What can I do? Okay, so for that purpose, we created another device. That device was an intelligent device. Okay, now why did I call switch an intelligent device? The reason is that when I connect multiple devices to a particular switch, okay, but for now, just imagine, just understand switch is a networking device. Okay, what we, with the help of a switch, if PC number 1 wants to send some information to PC number 2, all it needs to do is it needs to add some information. It needs to provide some information, and that information is the address. Okay, the address of PC number 1 and PC number 2. So in computer networks or in computer terminology, we call this address as MAC address. Okay, all our PCs have an address, a unique address that is called as a MAC address. Where does this MAC address reside? We'll talk about that in later class. So PC number 1, all it needs to do is it needs to give a source MAC address. Basically, what is a source? From where this information is originating. That is the source. So that would be PC number 1's MAC address. Destination MAC is going to be PC number 2's MAC address. And PC number 1 will send this information to the switch. Switch will read only this information and forward it to PC number 2. And hence, PC number 3 and PC number 4 will never receive this information. Okay, so switch was intelligent enough to forward your data according to the information you provided. Hub did not do that. Hub, what it did, whatever information came, it just copies it, creates multiple information, and sends it out to all the devices. That was what Hub used to do, and that is why it was called as an unintelligent device. It did perform what we wanted, but still it did it unintelligently. Switch does it in a better way. Now, with the invention of, or with the creation of switch, okay, what we could do is we can expand our network. We can expand our network to any length, meaning that I can connect multiple devices to a particular switch. For example, this is switch number 1. Okay, so these are different PCs connected to a switch. Okay, now let me assume that I am sitting in an huge college campus. Okay, obviously, when it is a huge college campus, one switch cannot be connected to all the devices in the college campus. So if I need all the PCs in the college campus to talk to each other, what I could do is I can connect multiple switches together and expand the network. Okay, so here there will be multiple PCs connected. This is switch number 2. Switch number 2 will be connected to switch number 3. And these PCs can then talk to each other. Okay. So all here, let's imagine PC number 1 is sitting here and PC number, for example, this is PC number 99. If PC number 1 wants to send some information to PC number 99, all it needs to do is write the source MAC address. That would be PC number 1's. Destination MAC address is going to be PC number 99, and it will forward it to switch number 1. Switch number 1 will forward it to switch number 2. Switch number 2 will forward it to switch number 3, and it will go to switch number 99. Now, let's imagine if there are many physics teachers or maths teacher, for example, you're talking maths. Okay, there are a lot of maths teacher in the college. Here you have a maths teacher, here you have a maths teacher, here you have maths, again a maths teacher, this is a maths teacher, and this is a maths teacher, right? Now, if PC number 1 math teacher wants to share question paper with all the other math teacher, what he is supposed to do? He will write his source MAC address and the destination MAC address of this guy. He'll send it. After that, he'll write the destination MAC address of this guy. He'll send it. After that, he'll write this and this guy and this guy. So one by one, he has to write these source MAC address and destination MAC address multiple times. It's a repeated work. Do I need that? No. For that purpose, we created something called as a VLAN. We have heard of the word LAN, which is basically called as local area network, right? Now, VLAN means virtual local area network. With the help of VLAN, this PC number 1 math professor, what he will do is, he will say, all you people, all the math people you guys are maths teacher or professors. So whatever information I will send, it should be received only by the maths professor, not by any other professors. So with VLANs, what he could do is, he would say all these math professors are part of one single VLAN network. For example, that VLAN name, for example, that VLAN name is maths. So whatever information he sends into the maths VLAN, it will be received only by the maths professors and by no one else. If there is a physics teacher sitting here, he will not receive this information. It will be received the information will be received only by the maths professor and not by the physics professor. This was the use of VLANs. Okay. Now, as I was saying, these VLANs, these MAC addresses, how these switches or how your PC or your mobile phone sends information through MAC addresses is what we see in your data link layer or your layer 2. VLANs could be understood like your WhatsApp group. You have a WhatsApp group number 1, WhatsApp group number 2. So any information that is sent by inside WhatsApp number 1 could be heard only by the people who are part of WhatsApp number 1 group. WhatsApp number 2 group can talk to each other, but these two groups, WhatsApp number 1 group and WhatsApp number 2 group, cannot talk to each other directly. That is how WhatsApp has created the application. Similarly, VLANs also work the same way. A person or a user in one VLAN cannot talk to another person in the VLAN. All this, how is this done? That is the study in your data link layer. Now, if you guys have ever been into a server room, okay, you would see that usually in a server room, what is done usually is that all these cables are part of one single VLAN to avoid confusion. Okay, they are all part of a single VLAN. These guys can be part of single VLAN. These guys may be a part of single VLAN, but these wires may go to different users who are sitting somewhere. But eventually, they all will be connected via this switch, and all these switch ports will be part of one single VLAN. For example, VLAN number 10 here, VLAN number 20, VLAN number 30. Right. So this is how basically your two devices are connected using a switch.
So जो multiple switches लग गए तो multiple switches के भी MAC addresses नहीं होंगे?
होंगे ना.
जैसे मैथ्स आपने कंप्यूटर 1 जहाँ लिखा है उसके पास सोर्स और डेस्टिनेशन एड्रेस है दूसरे कंप्यूटर का, तो स्विचेस का भी होगा ना?
स्विचेस का भी होगा, बिल्कुल होगा. पर स्विच कभी भी अपना मैक एड्रेस जो है, अपना मैक एड्रेस सिर्फ अपने नेबरिंग स्विच के साथ ही शेयर करता है। ठीक है, सिर्फ एक दूसरे के साथ, सिस्को के हिसाब से, सिस्को डिस्कवरी के लिए, बस एक दूसरे के बारे में जानने के लिए कि मैं कौन से डिवाइस के साथ कनेक्टेड हूं और मेरा कौन सा इंटरफेस दूसरे डिवाइस के इंटरफेस के साथ कनेक्टेड है। स्विच का मैक एड्रेस अभी तक मैंने जहां भी देखा है सिर्फ और सिर्फ स्पैनिंग ट्री प्रोटोकॉल में काम आता है। डेटा फॉरवर्डिंग में स्विच का मैक एड्रेस काम नहीं आता है, वो हमेशा एंड यूजर का मैक एड्रेस ही काम आता है। अगर स्विच कोई डेटा क्रिएट कर रहा है, अगर स्विच कोई डेटा क्रिएट कर रहा है तभी स्विच का मैक एड्रेस काम आएगा। अगर स्विच डेटा क्रिएट नहीं कर रहा है, स्विच सिर्फ वो डेटा फॉरवर्ड कर रहा है, तो स्विच का मैक एड्रेस काम नहीं आता।
स्विच भी डेटा क्रिएट कर सकता है, मतलब क्या डेटा क्रिएट मतलब?
स्पैनिंग ट्री का डेटा होते हैं, स्विच स्पैनिंग ट्री का डेटा क्रिएट कर रहा है, कोई प्रोटोकॉल चल रहा है, ठीक है, वो डेटा क्रिएट कर सकता है। HSRP एक डेटा है, वो डेटा क्रिएट कर सकता है, तो उसमें स्विच के मैक एड्रेसेस लगेंगे। तो
So it means that switch is like behaving there a bridge.
yes, switch behaves like a bridge.
Okay, thanks, sir.
Okay.
I got your point.
Switch behaves like a bridge. It only helps to pass on the, but if, as someone had asked, switches have MAC addresses, if switch is generating a traffic, that time switch will have a MAC, that data will have a MAC address of the switch. Otherwise, the data will not be of the switch, it will be of the originator of that data. So here in our scenario, when PC1 was creating this question paper, so the question paper will have the MAC address of PC number 1. Switch 1 will never add his MAC address to this data. You can see this is a kind of a LAN switch, or imagine this as your Wi-Fi router, which has signals or antennas. Okay. Now you can see, if you ever have seen your Wi-Fi modem, if you ever have turned it had turned around and seen its port numbers or ports, it might look very similar to this. Not, it's similar, not exactly the same. This is a LAN switch. LAN switch is different from your Wi-Fi modem. Okay. So all these are basically your interfaces. We call them as interface, or we call them as ports. Okay, interface or ports. And only in these interfaces you connect the wire, right? Wires like these RJ45. Okay, so if you see this RJ45 connector is basically plugged into one of these ports, and you will hear a click sound. That means it is connected, and the other end goes to the other side of the switch. Other side meaning the other device. It can be a router, it can be a PC, it can be a switch, anything. Now what happens is that when you buy a new router, okay, a big router, I'm not saying a small router or switch, when you buy a big switch or a big router, okay, it basically comes empty. Okay, empty meaning, for example, imagine you are buying a car. You are buying a car and the manufacturer just sends you the skeleton of the car. It does not have any steering wheel. It does not have it does not have gears. It does not have seats. It does not have engines. So when you are buying a big router or a switch, it comes empty. Okay, so imagine you bought a car and only the skeleton or chassis of the car has come. Okay, then what you do, you pay money to buy the seats, you pay money to buy the steering, you pay money to buy the gear, you pay money to buy the tires, etc., and then you assemble them together. Similarly, when you buy a switch, it comes completely empty. These ports are also completely empty. You do not have anything inside. But what basically is inside them is basically such kind of a motherboard, okay, or we call them as NIC, NIC, meaning network interface card. Network interface card. Okay. So until and unless you have a network interface card, you will not be able to connect these cables to any kind of a router or a switch. You need an NIC card in order for you to plug these cables. Otherwise, it's not going to work. Or in another way to explain this is, you drill a hole on a wall. I hope you guys have drilled a hole and hammered a nail. I hope so you have done that. Okay. So what you do, first you drill a hole on the wall, right? And in the hole, you put a wood or you put a plastic cap, and then you put the nail and hammer it, right? It's just the same. So basically, this is an empty hole here. You put in a wood or you put in a plastic cap there, and then you plug this nail into it so that you can hang a portrait or hang a clock, something like that. Okay, so everything that you see in computer networks is taken as an example from your real-time world. Okay, and it's always better to understand computer networks through real-time scenarios.
If, for example, if you take a switch as an example, it have 24 ports and 48 ports, right? So each and every port will have different MAC address, or?
Yes.
Okay, each port will have different MAC address, right?
Correct.
Okay, thank you.
Hello, sir. I have one query.
Yeah.
You explained that each port, inside that port, that NIC card is assembled, right?
Yes.
Okay. So those many ports and same will be the NIC card, right?
Correct. So if you see here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, even for this 17, 18, 19. So you will have 19 NIC cards.
Oh, okay. Got it. Thank you.
Someone has raised their hand. Someone? No. Okay. All right.
So for each NIC card, there will be a unique MAC code.
Correct.
Okay.
That means a 48 port switch has 48 NIC cards in it.
Correct.
Okay. So when we are buying a new switch from Cisco, like if we need only 24 ports, so they will give us only 24 NIC cards, rest of the ports will be left blank.
Yes.
Okay.
You have to buy them. That is
And
how companies make money.
Okay, so this is like maybe a business level switches like that.
See, if you are buying a small switch which has just 24 ports, you'll get 24 ports.
Okay.
If you're buying a 48 port switch, you'll get a 48 port switch. But if it's a huge switch, okay, for example, let me show you. Okay. So this is one big router. If you're buying this big router, obviously you're not going to buy each and every single port and NIC cards. You will only buy what you need. And you are buying such a big device because you are thinking from a business point, saying, I will use all the other ports in future. So for example, you bought only first 3 lines of NIC cards. The rest of the line you left it because you don't need them for now. But in future ever you require them, you can buy them individually. So if you see here, this basically is an empty chassis. There's nothing inside. You need to buy these things.
So such type of routers, I think most probably are
this
used by ISPs only, right? Or some bigger
Yeah.
company.
So that's what. If you're buying a very small router, or a very small, or we call that as a pizza box router or pizza box switch. Basically, it's just one single router. It does not look like a big router. It's just one single router like this. There you will have all the NIC cards already installed. But for such a big router, it will come empty.
I have seen the only till now 48 ports switch maximum.
Yeah. So such big routers, you do not have all the ports. You have to buy them individually.
Can NIC cards be shared between ports?
No.
Okay.
Okay. So as now we have already seen different kind of wires: Ethernet wire, fast Ethernet, gigabit, 10 gig. These are the different types of cables. Now you have two types of such connectivity. Okay. One is a straight cable connectivity. The other is a crossover cable connectivity. Okay. The difference between crossover and straight is that in straight cable connectivity, on both the ends, someone had asked here, right? In just before, I probably around 15 minutes before. This is node 1 and this is node 2. Okay. So here what happens on node 1, inside your cable, you have 8 wires. Okay. On one end of your cable here. Okay. These have 8 wires inside them. 8 wires inside them. Okay. So what happens is that when you are connecting two different nodes, or when you are connecting to nodes, meaning devices, or devices meaning switches or routers or computers, anything you can think of like that. So when you are connecting two different nodes together through a straight cable, what happens? The wire number 1 and 2, okay, of the cable, RJ45 cable, is connected to the port or interface number 1 and 2 of that NIC card. So this NIC card that we saw, okay, when you plug this cable, into here, okay, and you will hear a click sound. Okay, so what happens? These wires get connected to the wires here. You also have wires in this NIC card also, so that these electrical signals can flow together. Okay, so what here in this diagram, what it is depicting is this 1 and 2 wire of your RJ45 cable gets connected to the 1 and 2 wire of your NIC card. Similarly, 3 and 6 wire of your RJ45 cable will be connected to the 3 and 6 wire of your NIC card. Similarly, on the other side also. This is what straight connectivity or straight cable connectivity means. And straight cable connectivity is done done on two different devices, meaning if you have a switch and if you have a router is a different device, switch is a different device. So between these two devices, you have different devices, you will have a straight cable connectivity. Okay. And where does crossover come? If you have same devices, you will have crossover connectivity. What is crossover connectivity? Let's see that now. So in a crossover connectivity, as I had explained 20 minutes back, on your RJ45 pin, this 1 and 2 will be transmitting, okay, will be transmitting to the 3 and 6 port of the other side. So here in this diagram, you can see when I connect them using an RJ45 crossover cable. Okay, so what will happen? The wire 1 and 2 will transmit from here, and wire 3 and 6 will receive on the other end. Here also 1 and 2 will transmit and 3 and 6 will receive on the other side. They are single wire. Inside your single wire, you will have different inside your single cable. You have 8 wires. Out of those wires, 1 and 2 will transmit on one side, 3 and 6 will receive on the other side. Similarly, here 1 and 2 will transmit and it will be received on 3 and 6. So let me show you RJ45 in a zoomed manner. RJ45, yeah. So if you see here, it would look something like this only. You have 1, 2, 3, 4, 5, 6, 7, 8 wires, right? These 8 wires will be connected to your NIC card. Okay. And inside your NIC card also, you will have such 8 connectivity. So in your straight cable, if 1 and 2 are sending traffic, if 1 and 2 are sending data, on the other side, 1 and 2 will receive the data. Obviously, on a cable, if you see here, on a cable, you have 2 ends, correct? This is not RJ45, this is right. But just from examples point of view, if 1 and 2 on this end is sending data, 1 and 2 here will receive the data in straight cable. But in a crossover cable, if 1 and 2 are sending data, the other end, 3 and 6 will receive the data. This is how crossover cables are designed, and straight cables are designed. All right. Any question till here? Anyone?
I have one question.
So why there is a need for this crossover and straight connection?
Okay. The reason is that we use, so what happened is, see, these devices, okay, whatever you see in networking, they are developed or they are evolved slowly. Okay. First, computers were developed. After that, hubs were developed. After that, switches were developed. Now to connect these guys, you needed a cable. So what happened is the evolution of the cables and their connectivity has not changed at all. Okay. The way switches receive traffic, the way their ports work, it has not changed at all since their birth. Okay. Now, when obviously a router was created after switch, a router was created after switch. So what happens is that we said for 2 switches to talk, we need a crossover cable. The reason is both the switches, if you see here, 1 and 2 here is transmitting. 1 and 2 port of this switch is transmitting. 1 and 2 port of this switch is also transmitting. So if line or wire number 1 and 2 is transmitting on both the ends, who will receive it? Which line of wire should receive the traffic? That is why we said we'll create a wire or we'll create a crossover cable to connect same devices together. Because on both the devices, the transmission points and reception points will be same. So we need to cross transmit. But if you have 2 different devices, for example, you have a switch and then you have a router, okay, they can talk through a straight cable, because if 1 and 2 is transmitting here 1 and 2 will receive. Here, if 3 and 6 is transmitting, here 3 and 6 will receive it. So as things got evolved, right, they started making few changes. And this is why we came up with straight cable and crossover cable.
I have one query.
Yeah.
Different devices cannot be connected with crossover.
Okay. Here is a good diagram. Okay. So if you see here, switches, all these switches, okay, if you see here, these 2 switches and these 2 switches are connected using crossover cables. Okay. Why? Because their pin numbering is same. All the switches have the same pin numbering. 1 and 2 will transmit here, 1 and 2 will transmit here, 1 and 2 will transmit here, 1 and 2 will transmit here. So obviously, if you use straight cable, right, here 1 and 2 will transmit, here also 1 and 2 will transmit. and who will receive. The data will collide, correct? So if 1 and 2 is transmitting, on the other end, someone should receive it. That is why on same switches or same devices, okay, you use a crossover cable. But for different devices, see here, the computer and a switch. The computer and the switches are connected through straight through cables because they are different devices. Their port numberings are different. Their transmission wires and reception wires are different. So you can connect different devices through straight cables, but same devices you need to connect through a crossover cable.
I have some question over here.
Yeah.
Like I have seen in an office network, like there are 3 switches of HP Aruba, okay, 48 ports. So what we have done, like if we have purchased patch cords of D-Link, suppose, okay, the same patch cords we have connected. They are, I think they are straight patch cords. What I assume, because I do not know the difference between straight and crossover. So if you are buying patch cords of 3 meters, I think they are, so the same patch cord is used to connect switch and computer, and the same patch cord they have established uplink between the 2 switches.
Probably what you are seeing this in the book is
Right.
probably the oldest or legacy network. Probably now how devices are working. Okay, probably in nowadays 2 switches can be connected using straight over cable. Okay, I have not been to a server room since long time, so even I'm not sure. But when back in 2015, when I was connecting 2 different switches, I used crossover cables. In today now, how 2 switches are connected, if they are using straight over cables, I am not sure. Probably different vendors or different platforms or different products might be using different technologies. For example, Cisco might still be using crossover cables, but as you said, Aruba devices, they might be using straight cables. Right? We
Like
cannot say.
one question.
Yeah.
One question from my side. So the each switch ports, right? Is those are kind of half duplex or like a full duplex? It means if a full duplex, if you take, right, it'll be a kind of transceivers, right? We don't have that concept in switch ports.
Correct. In olden time, they were half duplex, but now they are full duplex.
Right. It will be kind of transceivers. It will do a
Yes.
TX and
Yes.
RX both
Yes.
in a single port. Yeah.
Correct.
Thank you.
Correct.
Sir, what I have heard is like, in olden days we have used this technology, but right now these switches and these computers are getting adapted to either we can use straight through or crossover cable. That's not an issue. They'll adapt to they'll interchange their roles while they are transmitting and receiving. So there will be no issue even if we use crossover or straight through cable.
Yeah. So that's what I said. Evolution is happening. Even back 9 years back or 10 years back, we still use the same thing, straight cables or crossover cables. Now things would have evolved. Okay. Now coming to our fiber optic cable, I will share this document with you. Just go through it. I'm not going to go much deeper into it. The only thing is, in your optical cable, till now, whatever we were reading were copper cables. In copper cables, information or data is sent in the form of electrical signals. But in your fiber cables, the information is sent in the form of lights. Okay. And please go through this. I'm not going to put in my effort explaining the cladding and how refraction works or reflection works in fiber optic cables.
So you'll be sharing this PDF, Laksh?
Yes.
Okay.
So similarly, for just like we had copper, for copper wires, we had some standards and their distances, etc. Right? For fiber optic cables also, we have different distances. So you can see for different fiber optic cables, you have their distances: 400 meter, 300 meter, 10 kilometer, and 30 kilometer. So your 10G base E, this is your IEEE name. Okay, this is your IEEE name, and this wire can go up till 30 kilometer distance, and the speed is 10,000 gigabits. That is what you call it as 10G base E.
I have the question.
Yeah.
Why we use the crossover cable?
I want to understand. Like we have the straight cable for to connecting the switches. So why we use like is for easy connectivity or so?
No, as similarly as I said, it's like if you're using two switches, two similar switches, okay, and you connect them using a straight cable.
Okay.
What is a straight cable? This 1 and 2 wire or wires in this RJ45 or straight cable is transmitting data. Is transmitting data. On the other side of this wire also, the port 1 and 2, or sorry, wire number 1 and 2 is also transmitting data. So what is happening? If it is straight, this guy is sending data at 1 and 2. This guy is also sending data at 1 and 2. So who will receive? If switch number 1 connected via RJ45 straight cable is transmitting data via 1 and 2, this guy is also transmitting data via 1 and 2. How will both the switches receive the data? That is why we are using crossover cable to connect two similar devices.
Okay. Now I got it. Yeah.
Laksh, are we using crossover connectivity or straight connectivity to connect router from switch?
Straight.
Straight? Okay.
Different devices, if different devices, straight cable, similar devices, crossover cable.
Different devices cross cable and
different devices straight over cable.
okay. And other one, what you said?
Same devices crossover.
Devices.
Okay, so this question is to those people or folks who are completely new to the world of networking. Are you comfortable with my speed? Are you comfortable with my speed and explanation, or should I go even more deeper or slower?
For yeah, for me, like kind of the not like I said like you talking with very speed, but like kind of like not like too much, but like kind of little extra speeds you have.
Extra speed up or
Yeah,
slow down?
just like yeah. For when I try to get understand what you said, but like then I suddenly get to know next topic is coming.
So you want me to slow down?
Yeah, little, not like much amount of, just kind of little.
No, we are
You
trying
can
to.
raise your hand. You guys can raise your hand who wants me, people who want me to slow down. And also, again, as I said, this question is specifically to those people who raised their hand yesterday saying they're completely new to networking. And they said, we are completely new. We do not understand what is a device, what is a switch, what is a router. Okay. So I hope till now, whatever I said is clear. I hope so.
Hello.
Yes.
So I'm actually completely new to this thing, and I was not able to attend the yesterday's webinar. I was traveling, that's why, and I don't have any scratch knowledge of networking and all. So it is kind of difficult for me to understand these routers and switches, things like what are you explaining. I understood that RJ45 and that crossover and straight through connections, but I'm not that familiar to networking. So I don't understand the basic things, like why I'm doing this course and what will be the scope of it. And I was not able to attend the yesterday's webinar, so I was not. So that's why I'm not too familiar with it. One of my friends suggested me this course, so that's why. So can you please guide me through this thing? Like what is CCNN? What will be the thing I have to do?
Okay. For that, I'll ask you to go through the recording of yesterday. You will get everything.
Yes, recording. Okay.
Yeah,
So you
have I
have
explained
explained
everything? What is CCNA? Why not CCNA? What is computer networks? Why do we study it? And what we will be learning in CCNA? Yesterday, I have explained it.
and if I have any personal doubts, like when I study these things, so can I personally contact you whenever you are free, right? Like that?
No, there is no such
Because
facility. Okay, I think there should be some facility like that in our
yeah, like
learn
some
dashboard. Okay, you can
yeah,
ask question there, pointing me,
okay,
right, and then I can
yeah.
answer there.
So there you can answer the questions, right? Because I have just completed my BSc degree. I'm new to it, so
No problem.
I don't have any knowledge about this CC and anything. I just know
Yeah,
that
yeah.
it is a networking field,
No
so
problem.
that's all.
Yeah.
So if I will basically if I will see yesterday's webinar, I will be familiar to this thing, right?
Yes.
Yeah, and yeah, you are explaining really well. I understood those things, RJ45 and that all thing. Okay.
No
Just
problem. Thank you.
if it will be great if you will go slowly because I'm new now, so I don't quickly catch up with these things.
Sure, sure.
Yeah. Thank you.
All right. Okay. Again, to Kriti and Ahmed Riza, I'm not saying that you should understand what is a router, what is a switch, but whatever I have explained till now about the wires, I hope you have got those things. Okay. I hope so.
Yes, sir, I understand, but sometime some matlab, students asking some new questions, which
Yeah,
is
do not
experience
worry
question.
about those. Do not worry about the questions that they have asked. Okay. If the question is related to what I am asking or what I have taught, okay, if the question is related to that, if you do not understand that those things, you ask me there. But if the question is something that they are asking which is not from the discussion that we had, just leave it, because at a later point of in this course you will understand everything.
Yes, sir. So I sir, for yesterday and today I learn new things, and it is easy for me now.
Thank you. No problem. Okay. So now,
Sorry to interrupt, Laksh.
yeah.
I just have one question regarding this RJ45 pinouts. We only used 1, 2, 3, and 6, right? And what happens with 4, 5, and 7, 8? I guess there are 8 slots, right?
Yeah, as per the diagram, they're not being used. Okay, probably because for simpler explanation, they would have not given the use of the other wires. The other wires are similarly being used, just like how port number 1, line number 1, 2, 3, and 6 are used. Okay, I would say that these explanations are very old. Okay, and the diagram that they have used are very old. The reason is to keep things very simple.
Laksh, one out of the box question I have. So, as we know that there are multiple, or I would say 100 of books written by different authors for CCNA in the market, but can you suggest anyone which we can go through?
Now, what we are going to start discussing is first. Till now, we were discussing about layer 1 wires. Okay, the physical layer wires. Now, what we are going to discuss is layer 2 devices, and that is switch. Okay, switch. Now, what is a switch? First, switch basically is a device. Okay. Usually in computer networks, we usually mention or draw switch in the form of a rectangle. Okay. Switch basically is a device which helps in switching the traffic. Now, what do I mean by switching of traffic? It means, okay, there is a wire connected to the switch. Okay, and there is another wire connected to the switch. Okay, from here it is receiving traffic, and from here it is sending the traffic. Okay, this is receiving, this is sending the traffic. Now, if what does a switch do? Switch will basically switch the traffic from the entry interface to the exit interface. Okay, that is basically the work of a switch. It will switch the traffic from its entry interface to the exit interface. and that is how the word switch was given to the device itself. Okay, because it switches the traffic from entry interface to the exit interface. Now, obviously, sending and receiving of data is bidirectional. So it can also receive traffic from this side and send traffic out of the other side. Okay, so a switch basically switches the traffic from an entry interface to the exit interface. Okay, now imagine your post office. Okay, you have a post office. A post office received a letter. Okay, a post office basically received a letter, right? And this post office, for example, is of Pune, and the from address on the post office, the from address on the post office is from Delhi. Okay, and the to address is to Bangalore. Okay, now from the Delhi office or from the Delhi's post office, right, or from Delhi, a letter was received in the Pune's post office. Now, what will the post office person do? He will see the to address, correct? He will see the to address and send it to the next city, correct? He will send it to the next city. Probably the next city between Pune and Bangalore is there is Kolhapur, there is Hubbali, there is Devangiri, etc. So, right. So let me take Hubbali as another city, Hubbali, right? So what is happening? This Pune post office postman, he checked the to address, right, the Bangalore's address, and he saw, and he made a decision. What decision did he make? He said, if I need to send this letter to the Bangalore's post office, I should send this to the Hubbali post office so that they can send it to Bangalore, because Hubbali and Bangalore are nearby. Correct. So this is how basically post offices make these forwarding decisions. Similarly, your switch also make some forwarding decision based on addresses. Okay, if a switch is receiving a traffic or a data or information, okay, it needs to send. Obviously, if you remember, if you had seen, the switch has lot of ports, correct? You see here the switch, or this in this case this is a router. Okay, just think of this as a switch. This switch has so many ports. Obviously, there will be many receiving ports, there will be many exit ports, correct? There will be many entry ports and there will be many exit ports. So if the switch wants to decide, which exit port should it use. So in this diagram, let's say switch has so many exit ports. How will the switch decide through which port or which wire should it send out the traffic? In this case, let's imagine this is Pune's post office. Pune's post office is connected to Hubbali. It's connected to Devangiri. It's connected to Kolhapur. Okay, it's connected to Bombay. Okay, or Mumbai. How will Pune's postman decide to which post office should he send? Based on some address, right? Based on the house address of Bangalore. Similarly, a switch will decide how to forward this traffic out of which wire or which interface or port through an address, and that address is called as a MAC address. Okay, is called as a MAC address. Give me a minute. Right, we always say MAC, but to be very honest, even I forgot the full form of MAC. So MAC full form is Media Access Control Address. Media access control address. Okay. Now, what is a MAC address or a media access control address? Each of these interfaces or ports of a switch, okay, has a MAC address. This switch itself has a MAC address. Okay. These devices that it is connected to has a MAC address. So obviously, just like our house has an address. My house has an address. My neighbor's house has an address. My society has an address. My office has an address. Your house has an address. Right? So all these are addresses, and based on these addresses, we are able to go to those destinations. Similarly, this switch will forward to the Bangalore office or the Bangalore switch based on the Bangalore's switch's MAC address. Okay. So again, our data comes on the entry interface. The switch reads the MAC address, and that MAC address would be basically the to address, correct? And in computer networks, we call this to address as your destination MAC address. The switch reads the destination MAC address and checks on which interface is this destination MAC connected to. The switch checks on which interface is this destination MAC connected to, and based on that decision, it forwards or sends the data to the Bangalore switch. This is just a simple overview of how switch basically forwards the data or switches the data from the entry interface and sends it out of exit interface. Any question for here?
Switch can have multiple entry points.
Yes.
Okay, so these
not for
points,
a particular data, for multiple data. Okay,
coming from different servers.
Yeah, coming from different sources, not for one data.
Okay, these 4 points that you have mentioned at switch will have a NIC card attached to it, and will have a MAC address.
Yes.
Different, right?
Yes.
Then this point is attaching to H point will have another MAC address. Then how will this switch will relate this point to H part?
I did not understand your question.
If data is meant to be received by H point, right? If data is received by switch, is further to be sent to the H point.
Okay.
And the particular point joining the H at switch will have different MAC address, and H will have different MAC address. Then how switch will relate that this point I have to send the address through this point to H, that is directly connecting to H, na? Getting?
Yeah, that is our next discussion. Don't worry. That is going to be our next discussion. So I hope everyone understood the basic working of a switch, how switch basically forwards the data by looking at the destination MAC address. Okay. Now let's look into what is basically a MAC address and how it looks like. So we have house address, right? We have a house address. So for example, my Cisco office has an address, Cisco Private Limited, Hinjewadi phase 1, something like that. Phase 1, some area name, and Pune, and the pin code, right? So this is how you usually write an address. Okay, it can be more, it can be less, anything, right? Similarly, you write to address and a from address so that you can send a letter from your place to some your friend's place or the destination that you want to send to. So this is a human readable address, but your switch understands MAC address, as I was saying, media access control address. This MAC address is basically a 48-bit address. 48-bit address. Bit meaning it will be either 1 or it will be either 0. The value will be either 1, 48 bits of ones and zeros. Okay. It's a combination of 48 bits of ones and zeros. So if you want to see how a MAC address looks like, let me show you. So if you see here, this basically is your MAC address. Okay. And your MAC address is written not in binary format, not in the binary format. It is written in your decimal format. Okay. I hope you guys have studied how to convert binary to decimal and decimal to binary. Okay. So if you do not know, let me just write down 4-bit binary numbers: 000, 0001, 0010, 0010, 0011, 0100, 0101, 0110, 0111, 1000, 1001. Wow, there's so much. 1010, 1011, 110, 1101, 1110, 1111. Okay. So this is your 4-bit binary numbers. So starting from 0 up till all the digits turn to 1. These are the combinations of 4-bit binary numbers. Starting from 0, you write it as 0. This is 1, 2, 3, 4, 5, 6, 7. This is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So starting from 0 up till 15, using 4-bit value, these are the binary numbers, and this is their decimal number. This is binary and this is decimal format. Okay. Now, usually what happens is, in your decimal format, we do not write 10, 11, 12, 13, 14, 15. Instead of that, we write as alphabets: A, B, C, D, E, and F. Okay. So your 48-bit MAC address is basically a combination of multiple decimal numbers that you see here. You see here, this is F4A47507. So if you see here, F4, F is 1111, 4 is 0100. Like that, if you convert this into binary format, it will be a 48-bit value. Okay, it is going to be a 48-bit value. If you convert all these decimal numbers into binary, their equivalent binary numbers, they will be a 48-bit number. All right. Now, this MAC address, just like our house address, it's unique. It is unique. So my laptop's MAC address is unique. No other device in the world will have the same MAC address as my laptop. There is a MAC address for your phone. There is a MAC address for your smart TV, right? All the MAC addresses for any networking device are non-duplicate, meaning they are unique. They are unique and they are uniquely designed also. Okay, they are basically designed. MAC addresses are designed by who? There is an organization, IOU. Let me again, I'm bad with full forms. Not IOU. No, not again this. I'll let you know the full form for
So
this
I
organization.
think it's INA, Internet Authority of
No,
something like that.
no. That is IP address. I'm talking about MAC addresses. Okay. So there's an organization IOU, which basically assigns MAC addresses. Okay. So if your computer has a MAC address, and if you want to check the MAC address of your computer, you can go into your command prompt of your laptop or your PC. Okay. And do IP config. I hope this command is correct. Okay.
We can use getMac, I think so.
Yeah. So if you see, these are the MAC addresses of my device. Okay. So this may be a MAC address of one of the ports of my laptop. This is for another. This is for another. So I have 4 ports on my laptop. For all the 4 ports, you have these MAC addresses, and these are uniquely designed by the organization IOU. They designed the MAC address, and these MAC addresses are hard coded on your motherboard. They are hard coded on your motherboard. You cannot change them, no matter what you do. You cannot change them. Okay. So based on these addresses, based on these unique addresses, the switch is able to forward the traffic from, or switch the traffic from entry interface to the exit interface. Okay. Any question?
What content should I go through? Like conversion of this?
Yeah, if you just search on YouTube, so you will find a lot of articles which tell you how to convert binary to decimal. It's very simple. It's very simple.
Sir, one doubt. I think IP address is represented in decimal format, but I think so this MAC address is represented in hexadecimal format.
Okay, the hexadecimal value is these A, B, C, D, F. Yeah. So here this decimal value is 15, hexadecimal value is 1, F here. You see here, decimal value is correct, as I was saying. Okay, so till here, this is decimal. After this is hexadecimal. Okay, so someone asked how to convert this. You have a lot of YouTube videos. You can go through Google, read articles. It's very simple. You can learn in 15 minutes how to convert them. Okay.
This conversion required in this course? Do we need to learn it?
No.
Okay.
Lakshya, I have one doubt. You showed that in the command line that PC has 4 MAC address. So those many ports will be equals to that number of MAC address, right?
Correct.
Hey there. Continue learning directly from industry experts. You are watching these recorded topics from our master's program, but you can watch it live by joining any of these master's program, where you can become an IT engineer that too without coding. Now you can continue.
Equal to number of MAC addresses.
Okay, so each individual port has a MAC address itself, right?
Unique MAC address, individual MAC address.
Okay. But while we see that in our PC, if we check by going to the properties, it will show that 4 MAC address of our PC or a single MAC address.
Not sure. Okay, so if you see, these MAC addresses are different. This may look the same, but the last value is different. This is 01, this is 08.
Okay, total number of ports of the laptop is equals to total number of MAC address.
Correct.
Yeah, okay.
Lakshya, actually, the MAC addresses, right, divided into 2 parts, right? The first 3 are kept
Yeah.
for,
I'm not explaining that. That's not also needed. That is also not needed.
Okay.
That's why.
Yeah.
Now,
sir, one question. Like I have heard about Mac spoofing like that. Okay. Do we learn here or it's not required?
No, it's not required.
Okay.
It's not even in the part of CCNA.
Okay.
So, could you just give us an overview of the content of the CCNA course and like what will be the path which we'll be following?
Yeah, let me finish this today's lecture. I'll show you.
Okay.
So, as I was saying, these switches, they use these MAC addresses to switch the data from entry interface to the exit interface. Okay. So the switches, they read these MAC addresses. They read these MAC addresses, and based on the destination MAC address, you can see here it's written as destination, and this is a source. So based on the destination MAC address, it will switch the traffic from entry interface to the exit interface. Okay. Now, just imagine you are walking on the road. You're just walking on the road. Okay. And some guy, right, asks you for a direction. Some guy asks you for a direction to some place or to some destination. So let's say that, let me take my example. I live in Pune. Okay. Some guy who's coming from Delhi. Okay. He stops me. Okay. He wants to go to Bangalore. Okay. So he asks me, how do I go to Bangalore? Now, I should have the information already. Correct? I should have the information how to reach Bangalore. Then only I can help this guy. Otherwise, I will not be able to help this guy. Correct? Similarly, switches should know the destination. Switches should know the destination, then only they can switch the traffic. Otherwise, they will not be able to switch the traffic. Okay. So, as I was saying, in this diagram, when the data is coming from this side, that is the Delhi side, and it is entering this switch port, entering the switch. Switch should know about the destination MAC address, then only it can forward the data. Okay. So how does the switch know about these destination addresses? So there is a switch. Okay. There is a switch connected to my PC. Okay. I am saying google.com. Okay. Switch is receiving the traffic and it is sending the traffic to the Google server. How does the switch know the address or the MAC address of the Google server? Right? If and only the switch knows the MAC address, then only it can forward the data. So our discussion now, a very small discussion, what is going to be how the switches learn or know about the MAC addresses. Okay. In short, you have a switch. Okay. And there is a PC number 1, and you have another switch, PC number 2. Okay. So as I showed, my laptop has a MAC address. Obviously, this PC will also have a MAC address. I'm assuming that if we saw the MAC address are a combination of different decimal and hexadecimal numbers. Like, we saw F4, 4F, 70, something like that, right? And it's a 48-bit value. What now I'm assuming is in all my classes, in all my examples, I assume PC number 1 MAC address as all 1111. So 48 bits of 1. For switch number 2, everything is 2222 to make things simpler. Okay. So as I said, switch PC number 1's MAC address is 1111. PC 2's MAC address is 2222. Okay. So let's assume that you have another PC number 3, whose MAC address is 3333. Now, if this PC number 1 is sending data to PC number 2, okay. So we just saw something called as a destination MAC address. So PC1 says my destination MAC address is 2222. obviously PC1 is sending the data. So the source MAC is going to be 1111. I hope everyone is clear till this point. PC1 is saying my MAC address is 1111. The destination which I want to reach is 2222. Then what it does, it sends the data. The switch receives the data. Okay. Now, how will the switch know on which interface should it send the traffic? Should it send via this interface or should it send it via this interface? Okay, that's the confusion for this switch. As I said, just like the human scenario, if someone is coming and asking me the direction to go to Bangalore, if I do not know how to go to Bangalore, how will I give the direction to someone else? So I should know how to reach Bangalore first. Then only I can guide someone. So switch should know how to reach 2 and 3. Then only it can help 1, right? So switches learn their MAC address when they receive the traffic. Okay, switch learn the MAC address when they receive the traffic. So as I was saying, this guy is Delhi, I am Pune, and this is Bangalore and Chennai. So the Delhi guy came to Pune and he asked my help. So I said, where are you coming from? I asked him, where are you coming from? He said, I'm coming from Delhi. Okay. So I say, he came from Delhi and he came from Delhi via, for example, I don't know the correct national highway number, example, NH30. Okay. So I make a note of it saying anyone who wants to reach Delhi can go via NH30. Similarly, switch makes a note of it saying if anyone wants to reach 1111 MAC address, he can go via NH30. Okay, he made a note of it. So if anyone else who is coming from anywhere, if he wants to reach Delhi or the MAC address 1111, I will say go via NH30, or the switch here will say go via NH30. Okay, so as I said, switch learn the MAC address when they receive the traffic. Switch learn the MAC address when they receive the traffic. Now, he has received the traffic. He made a note of it. After that, he checks the destination MAC address. He says, I do not know. I do not know how to reach the destination MAC address. What will I do? What he does is, he will forward this data or he will forward this information out of both the interface. Out of both the interface. It's like, I do not know how to reach. Someone came and asked me, how do I go to Bangalore? Go via this way also, go via this way also. Whichever reaches Bangalore is your destination. This is how humans will work. In this scenario, what the switch do is, switch will forward it out of all the interface. So let's say this is NH48. Okay, and this is NH15. Okay. So he will forward the data out of NH48 also. He will forward the data out of NH15 also. So now this data is received by PC number 2 also and PC number 3 also. Both these devices, both the PCs, they will check their destination MAC address. So just like this, when you receive a courier or when you receive a parcel, okay, you check, is it for you? You check the to address, correct? Is it for you or is it for someone else? If it is not for you, okay, so someone is sending me a courier. I will check my name, correct? I will check Laksh mentioned there. If, for example, Rahul is mentioned on the parcel, I will not accept the parcel. Similarly, in this case, PC number 3, when it receives this packet, it will check the to address or the destination MAC address. It sees that PC number 3's MAC is 3333 and the destination MAC is 2222, and it will not accept this data. And it will not even respond to this data. Okay. Then PC number 2. When it receives this data, it sees the destination MAC address. In the destination MAC address, it matches the destination MAC address and PC number 2's MAC address. They both match. Correct? When they both match, PC number 2 obviously has to respond. If I am sending you some data, you need to respond back to me. That is how what we saw in our yesterday's class, acknowledgement. Correct? The acknowledgement should be there. So PC number 2 has to acknowledge this data. Now, when PC number 2 acknowledges the data, the source MAC and the destination MAC completely changes. Source MAC becomes 2222. That is PC number 2's MAC address. Destination MAC is going to be 1111 because the previous packet or the data that it received, the source MAC was 1111. So obviously I have to respond to 1111, and that is why the destination MAC is 1111. Correct? And PC number 2 will send this data to the switch. Switch will receive this data. He'll see that this data wants to go to 1111. But first, switch asks, where are you coming from? This data says, I am coming from 2222. Okay. And I entered your city via NH48. So now switch 2 knows how to reach PC number 2. And it knows if it needs to reach PC number 2, it needs to go via NH48. Okay. So it first saw the MAC address, first saw the source MAC address. It made a note of it. And then it checks the destination MAC address, that is 1111. It sees, it checks, do I know how to reach 1111? Yes, I know how to reach 1111. Or if anyone wants to reach 1111, he needs to go via NH30. And switch forwards this data or switches the data from NH48 to NH30 and sends this data back to PC number 1. I tried to explain it as simple as possible.
Yeah, I have one question. That switch itself has the two ports, na? They, as you mentioned, that the ports have also MAC address. So how they behave? Because we understand that from 1111 to data is going to 2222. So source is 1111 and destination is 2222. But between this, the switch has itself the MAC address, two MAC address. So that how it behaves.
When forwarding the data,
okay,
forwarding the data. Okay, that means the switch did not generate the data. The data is coming from somewhere else. When the data is coming from somewhere else, switch does not involve its own MAC addresses. It will not interfere. Just like a post office. Okay, when there is a letter coming from Delhi to the Pune. The Pune post office, does he change the address? He will not change the address. He will look into the destination address and he will simply forward it. Correct?
Yeah.
If this Pune post office is creating the letter, he will write his address. No? Here, switch is not generating the packet. Data. The data is generated by someone else. That is why the switch's MAC address will never ever interfere here. Any other doubt?
Yeah, hi Lux. So I have two queries. The one is, so switch will learn the MAC addresses first time through a broadcast, you mean to say?
In some scenarios, yes.
Okay, as you said, say, if switch doesn't aware that destination MAC address, so it sends the packet. Same packet it sends to the all that interfaces, right?
Correct.
Something like a broadcast.
Yes.
Okay. So one thing. So second thing is, suppose in this picture,
there it did not learn the MAC address. When it is, First time when it receives it, again, the point is whenever the switch receives a traffic or receives a data, again, I'm emphasizing on the word receive. When the switch receives the data, it checks the source MAC address. It checks the source MAC address. It sees, do I know about this source MAC address? If not, he will make an entry.
Okay, right.
Okay. Then second point, if it does not know about the destination MAC address, it will forward it out of all the ports. So the first point, again, thank you for telling me this. The conclusion of this whole process is switch learn MAC address when they receive data. Okay, that's the first point. Second point is, if they do not know about the destination, they will broadcast, in other word, forward or flood slash broadcast slash forward the data out of all the interfaces.
But it will be in the starting stage only.
Correct.
Right. With each and every activity, the switch will start gathering information, start gathering all the MAC addresses. Right.
Yes. Yes.
Sir, one question.
Okay. So does this switch gets to on and off if they are placed in a network?
On and off meaning?
And they are ever put off switch if they are in a network. We ever need to switch off the switch?
Why do you need to switch off the switch?
Because in the starting, you're saying, na, in the starting, it will broadcast, it will flood the frames, right?
Yeah.
It is static, but eventually it will gather all the information of all the devices and get all the MAC addresses.
Yes.
So when it will be the initial stage that it starts gathering this and stop broadcasting?
See, if it is a new data, if it is a new MAC address, okay. See, if it is a new MAC address, it will learn it. Okay, first point, as I said, if it is a new MAC address, it will learn it.
No, I just want to know that we can switch on and off the router, right?
Okay.
Power on and off the router.
Yeah, yeah.
So similarly, switch can be power on and off.
Yes, you can do that. Yes.
So it oftenly happens in the network?
No, it does not. Why would you even in a live network? Why would you try to power on and power off a switch? It will basically create a traffic, right? Traffic jam.
Okay. Understood.
So I have a question to continuation to Rajiv. So if suppose due to any chance switch got switched off, then if it switched on again back, so will it learn the MAC addresses again, or will it store this any MAC addresses of previous?
It will learn the MAC address again.
Okay, it will learn again. The process will start again.
Correct.
Okay, and in continuation to that, suppose in this diagram you have 1, 2, 3 PCs. Suppose 2 and 3 MAC addresses been learned already by the switch, and if I want to add one more switch of 4, and the 4 MAC address will not know by the switch. So in that case, will it broadcast to again 2 and 3, 4, or it will only broadcast to 4?
if you add one more PC,
Yeah.
okay, 4444. Okay, it already knows about 3 here also.
Correct.
NH15. So it already knows about PC number 1, 2, and 3.
Correct.
So if PC number 4 is sending a data, okay, source MAC is 4444 and destination MAC, for example, is 1111. Okay, when PC number 4 sends a data, it will learn PC number 4's MAC address because it does not know about 4444 already. It will ask, where have you come from? He says, I have come from 4444 and I came at NH number 50, for example. Okay, NH 50.
Okay.
Right. And then it checks, do I know how to reach 1111? It knows how to reach 1111. There, it will not broadcast the traffic.
Okay.
Read the second point. I said, if they do not know about the destination, if they do not know about the destination, then only they will broadcast. If they know about the destination, they will not broadcast.
Correct. So if in your example, if source is 1111 and the destination is 4444, in that case, which doesn't know what is 444.
Yes, it will broadcast.
So the broadcast will be done again to all 2, 3, 4, or is it only 4? Because 2, 3 already he learned already 2, 3. So why he wants to send it again 2, 3? So that is what my question is.
No, we are not sending to 2, 3. See, the reason we are sending to 2 and 3 is because the reason we are sending to 2 and 3 is switch. See, this 4 might be beyond this PC also.
Yeah. Okay. Correct. Yes. That's
Correct.
possible. Yeah.
So the switch does not know about this. So he is sending out of all the ports. So that if 2 knows how to reach 4, he will forward to 4 and 4 will probably reply back.
Right. There is chances. Yeah.
That is why.
Okay. Got it. Yeah.
Lakshar, I have a question.
Yeah.
So, may I know what could be the scenarios wherein we say the switches doesn't have the dynamic address, destination address whenever? Is it when you connect a new device or you configure it like that, leaving out the destination address?
I have one quick question. So, for example, PC1 is sending data to PC2. So initially, switch don't know about the destination, right? So what it will do is it will do broadcasting. So how PC3 will reject this data and the PC2 will accept this data? I mean, like how they'll get acknowledgement. That's what my question is.
So the same thing, as I said, if you have a parcel coming to you.
Okay.
Okay. But the parcel does not have your name. Will you accept it?
No.
Same way. 3 received a parcel, but in the parcel, the destination, the name was for 2. So why would 3 accept it?
Okay. My question is like this switch even don't know this destination MAC address.
Yeah.
Right. I mean, like PC1 wants to send the data to PC2, right? So in this scenario, even switch also don't know the destination MAC address of PC2, right?
Correct.
So how PC2 is giving acknowledgement that I have received the correct data and replying back to PC1?
That is what PC2, see, PC2 read the destination MAC address.
Yes.
And he saw that this data is coming from 1111. So he needs to respond to 1111.
Okay.
He is responding to 1111. He is not responding to the switch.
Okay.
Okay. So here in this case, switch learned the MAC address saying 1111 was received by at NH30. Okay. And he forwarded it to 2 and 3. 3 rejected it. When 2 responds back, 2 is not responding to the switch. 2 is responding to PC number 1.
Okay.
Okay. Switch receives it. Switch will make an entry for it. For example, NH48.
Okay.
And then he will see 1111. I know how to reach 1111 via NH30. That is this way. He will forward it to PC number 1.
Yeah, understood.
Laksh, one question from my side. So when a packet comes from 111, right, the switch receives first time. So if it want to store the address of the one, like a PC1, right, will it see the pack? It will decode the packet and it will take the MAC address, or like it will send any packets to know the address of the how it stores, like it make a note.
It see, I'll tell you this tomorrow while doing the practical. Okay. Because what you're asking is in a bit of a deeper level, and that I can explain only through practical. You'll understand that.
Yeah, got it. Yeah.
Yeah, Aditya, I'll take this as the last question, and I'll end the session today.
Laksh, if we remove this 222 from switch, so will that have same kind of MAC address on switch interface, or it will change, or it will delete that entry?
So you're asking if
If we remove that, PC, and if we attach another which is having on same port, if we attach another device with 444 MAC address, so what happens to the previous entry?
it will still remain there. Okay, it will still remain there until and unless PC number 4 sends some data. Okay, so in switches entry 2222 was NH48. Okay, now what happens? Now what happens here in this case? If PC number 1 sends some data 11112222, okay, switch receives it, switch sees that 2222 is at NH48, it forwards here. PC number 4 will receive it, but he will reject it because that's not the destination MAC address. PC number 4's MAC address is different than the destination MAC address. He will reject it. Switch will never know that something has changed until and unless this guy sends a data. Okay. Now when he sends the data, switch will know 4444 is now at NH48. Is at NH48. Okay. And he will erase this data from here.
Okay.
As I was saying, switch learn MAC address when they receive the data. So until and unless any device sends a data, switch will never ever learn their MAC address.
So now network can be of for your home network or the enterprise network. If we look about the home network, so this is a kind of your home network. You are having a laptop, you are having a tablet, your mobile phones that can be connected to a wireless access point. So you must be familiar about these networks because everyone is running this kind of network in their home. Okay, so you are connecting your PC either wired or wirelessly to the access point. So let's say you are having a broadband modem, so there must be a chance you are connecting your laptop by using some sort of wire. Okay, wire is acting as a medium for you. Okay, but if you are using the access point, it means the wireless will be acting as a medium for you, and you are exchanging the information by using either wire or wireless. Okay, so connecting the device is known as a network, and exchanging the information over the device from one device to another is known as a networking. Okay, now this kind of network is your home network. Let's talk about the enterprise network, how the enterprise network looks like. So now this is your enterprise network topology. Okay, so enterprise network will be having a different sort of devices. Okay, so they are having some devices with the help of which the information can be exchanged. Okay, so let's say there is a company who are having 100 users. Okay, So those users want to communicate with each other. So what we are doing, we are connecting those users with one device, and that device is responsible for exchanging the information between those computers. Okay. Now, if we talk about any kind of network, if it is a home network or the enterprise network, the network is being divided into two parts. Let me discuss about that. So the first part is the LAN segment, which is known as a local area network. And the second part is the WAN segment, which is known as a wide area network. Okay. Now let's first talk about the LAN. What is LAN? So if I take the example of this one, we are having, if I take the example of your home environment, you are having a laptop. Just a moment, let me draw it for you. So let's say this is the access point, which is the wireless access point. Okay, and you are having your mobile, you are having your PC. Okay, and let's say there is one, this access point is connected to the ISP. ISP is the internet service provider, which will provide you the internet. So this is the ISP device. Okay, so now you are connected via wirelessly, you are not connected via wired. So that wireless means that that is your medium. Okay, so this segment which is behind this ISP router, so this is your home environment segment, this is known as a LAN segment, which is your local area network. Okay, and the segment which is behind this ISP router will be the WAN segment, which is wide area network. So internet is the largest WAN that is available. Okay, so if you want to connect to some internet site, what you will do, you will connect to your Wi-Fi access point, and Wi-Fi access point is responsible to send your data out of this, and your ISP end device will be taking the data and send it to the internet. Okay, so the devices which are in your home network or the enterprise network are acting in the LAN, and the devices which are in the ISP end side are the WAN. Okay, now if we talk about the enterprise network, enterprise networks are having, let's say this is a networking device. We'll talk about this, what this device is known as. This device is known as switch. Okay, so we are having the multiple users connected to this, and we are having this end device which is known as a router. Okay, so enterprise is having the devices named as switch and routers. Okay, we'll talk about this, what these devices do. Okay, so that the segment which is connected on this side, so let's say this is the ISP, internet service provider. So the devices which are connected on this side, on the left hand side, are the LAN devices. Okay, and the network which is on the right hand side is known as a WAN. Okay, so LAN means that the local area network, so it depends upon the geographical region. If the devices are connected in the small distance, okay, so these pieces are connected very small distance. Okay, so this is known as LAN, and the ISP end, ISP is a very large network. So the devices can be connected in few kilometers away or few miles away. Okay, so depend upon the geographical region, that network is known as a WAN network, wide area network. Okay, now I have shown you the enterprise network, and enterprise network is consists of the switches and routers. Okay, let's talk about that. What are switches and what are routers? So these are the some pictures of the Cisco switches. So Cisco switches is having some kind of port. So this port similar to whatever the port is connected to your Okay, so this port is similar to the port which is connected to your laptop. So this port is known as the NIC card, NIC, Network Interface Card. So as the name describes network interface, it is providing you the interface to connect to a network. Okay, so what we will do, we will connect a wire to this NIC card and we will connect a end device. End device will be your PC, your desktop, your laptop. Okay, end device can be anything. Okay, so we the number of ports we are having, we can connect the number of end devices. Okay, so this switch will be responsible for this piece communication between this PC to second PC. Okay, so the switch is the one which will be responsible for to communicate inside your LAN. Okay, so if you are having the enterprise network or you are having the home network, okay, let me again show you. So let's say this is your home network. So this is your Wi-Fi access point, and you are connected your mobile and laptop. So you can directly communicate from mobile to laptop with the help of this wireless access point, because those both are connected to the same device, and this device is acting as an intermediate for the communication to happen between these two devices. Okay, so this device is also at the local area network, part of a local area network. Okay, so the switch is doing the same thing in the enterprise network. So on the switches, we are connecting multiple end hosts, which will be the users. And those users, if they want to communicate with each other, they will do with the intermediate, which is known as a switch. Okay. Yes, we will talk about this MAC address also. Okay. So yes, every port will be having the separate MAC address. Like in your laptop, some of the laptop can have one Ethernet port or one NIC card, NIC card, and some laptop will can have multiple NIC cards. Okay, so the number of NIC cards we are having, that number of MAC addresses we will be having. So I have talked about the LAN devices. Let's talk about the WAN devices. Now let's say this is again your home network, and this is your wireless access point. Again, we are having one mobile and laptop. Now, if they want to communicate with each other, they can communicate with the wireless access point. Okay, but let's say they want to go to the internet. They want to access Facebook. They want to access the Google server. Okay, so you can't do this with the help of these devices, wireless access point or the switches. You need some sort of other devices which will able to send the packet to the internet. So those devices which will be doing the routing for you, that are known as router. Okay, and that routers will be connected on the wide area network. So the devices which are responsible to switch the packet on the wide area network are called routers. Okay, and the devices which will be responsible to switch the packet on your local area networks can be a wireless access point, can be a switch. Okay, now let's talk about the NIC card, NIC card. So NIC card can be of different variant. Let's talk about the simple NIC card. Okay, so this is a sort of NIC card where the wire will be connected. Okay, and every NIC card will be having some sort of address which will be unique. Okay, that address is known as MAC address, media access control. Because on the wire, if one device is sending the information to the other device, they should know what is the address of the other device NIC card. Okay, let me explain you here. we are having a question from will the switch convert the packet to frame? So these are the advanced level things. So once we will be digging into the technical stuff like the OSI model, okay. So I will be explaining you what are the packets, what are the frames, okay. So for now, just I'm giving you the overview of how the devices need to be connected and what all things you should know about the devices, okay. And where each and every device will be used. If we are using a switch, what is the role of the switch? And if you are using a router, what is the role of router? And if you are using the access point, what is the role of that device? Okay. So I was talking about the network interface card. So let's say this is our switch. So every switch is having multiple NIC cards. It depends on what model you are taking of switch. So multiple models are there. Some of them are having 24 NIC cards and some of them are having 48 NIC cards. Okay. So let's say this PC is connected here. Now, this PC wants to send data to this switch on this interface card. Okay. So every interface, every NIC card will be having their unique MAC address. Okay. And that will be in the hexadecimal form. I'll show you what is the hexadecimal form. Okay. So the PC is also connected to some sort of NIC card, and that NIC card will also be having some sort of MAC address. Okay. So in order to communication happen between these two guys, they should know each other MAC address. Okay. So once we will talk about the OSI model, we will be looking into the different layers. Okay. So we will see that MAC address reside on layer 2, and there is something, this is the physical address of the device. And there is something called logical address. Okay. That is known as the IP address. Okay. So IP address is needed if you want to go from one network to other network. Let's say you want to go to the internet. Okay. So then you need a router, and router will do forwarding based on the IP address. But if you want to communicate between one PC to another PC, yes, you need an IP address, but switch will do forwarding based on the MAC address. Okay. Okay. So I've talked about the NIC card. So let me show you how the MAC address looks like. Okay. So let's see. My PC is also having a NIC card. So let's see what PC's MAC address look like. So we are having the command prompt. Command prompt is the CLI command line access of your device. Okay. So from the command prompt, you can enter the different command to get the information. So if I enter the command ipconfig /all. So if you see here, I will be having one Ethernet NIC card. So this is my wireless LAN adapter. Okay. So we are having one Ethernet, which will be my LAN segment. So this is my laptop. My laptop is having two NIC cards. One is for the cable one and other one is for the wireless one. Okay. So this is the NIC card which it is showing for the wireless. Okay. And wireless is having this MAC address. So this is the hexadecimal form. So hexadecimal form, you will be seeing the numbers 0 to 9 and A to F. Okay. So this is the hexadecimal form. It is having some sort of MAC address. Okay. And this is my Ethernet adapter, which is the wired NIC card. And this is the MAC address of the wired NIC card. So both the MAC addresses are different. So it means that we are having the number of NIC cards we are having, the number of MAC address we will be there. Okay. So anyone having questions, you can ask now. Okay, so we are having the question that why we are having the wireless NIC card, why we are having two NIC cards. Okay, let me explain you why. So this is your laptop, let's say. Now, your laptop is not connected to a wire. It is connected to the wireless access point. Okay. Now that access point is communicating with your laptop through the radio waves. Okay. And that radio wave should be received by this laptop on some kind of interface. It needs some interface which will convert the radio waves into the signals that the PC could understand. Now all the machines will only understand 01010101, which is the binary. Okay. Now access point is sending the data in a radio waves, and that radio wave should be converted into this this bits 01010101. Okay, and that should be received by some kind of NIC card interface. Okay, so to receive the signals from the wireless access point, we need another NIC card, which is a wireless NIC card, because Ethernet NIC card is not able to understand these wireless signals. Ethernet is just able to understand the electrical signals. So Ethernet NIC card will only understand the electrical signals which are coming through the wires. It will not able to understand the radio waves. So that is why we need a separate kind of NIC card which will understand the radio waves, and it will convert the radio waves into the binary, which our machine is understanding. Okay, so that is why we are having one NIC card for the wire and one NIC card for the wireless, because the type of communication happening between these two, the wired and the wireless, is different, or you can say the format of data is different. One is in the radio wave and the other one is the electrical signal. Okay, so we are having one more question, and he's asking that why we are having multiple NIC cards for the wireless. Okay, so let me show you through the graphical user interface. In order to see all the NIC cards which are present on your laptop, you can see ncpa.cpl. ncpa.cpl. So we are having these much of NIC cards, but all are not physically present. So the Bluetooth is also having one NIC card, because Bluetooth is doing communication based on the Bluetooth network. It is not using the electrical waves. Okay, so it needs some other kind of frequency which could be understood by this NIC card. Okay, and these are my virtual NIC cards. These are not the physical NIC cards. So if we are doing any kind of VPN, then this NIC card will be active. And if you are installing any virtual device, let's say I am running Windows 10 here right now on my PC, and I also want to run Windows 7. So what I will do, I will install one software which is known as a VMware, and on the VMware I will run another Windows 7. Okay, so I can run Windows 10 on this PC, and besides that I can also run Windows 7 at the same time. So this NIC card will be active once you install the VMware. Okay, so this is kind of a virtual NIC card, because from Windows 10, which is my physical machine, and from to Windows 7, which is my logical machine. Okay, so in order to make communication happen between these two, they should have some sort of NIC cards. Okay, so that is why this is the virtual NIC card, not the physical NIC card. Okay, so similarly, we are having the wireless NIC card. Okay, so the number of the virtual devices you get installed on your physical machine, the number of NIC card will be increased. Okay, so let's proceed further. Now I have talked about the LAN side segment, how the LAN will be looking like in the enterprise network, and how the LAN will be look like in the home network. Okay, so let's talk about something about the WAN segment, how the WAN look like. I told you that over the LAN segment, the multiple routers will be connected. Okay, so we are having one router. So what is this? This is one ISP, Internet Service Provider. This is second ISP. Okay, so let's say this is Airtel. And let's say this is BSNL. Okay, so these two ISP will be directly connected to each other. So inside the internet, multiple ISPs are connected to each other that will be exchanging information with each other. Okay, so these ISP will be having the devices which are known as the routers, and that routers are responsible for exchanging the information between each other. So let's say this is your home network and this is your wireless access point. And here is your laptop. Okay, so wireless access point will be connected to one ISP. Okay, now that ISP is connected to the other ISP, and this ISP is connected to the Google server. Okay, so this is how the communication is happening between you and Google server. You are sitting in, let's say you are sitting in one part of the world, you are sitting in USA, and the Google server is in the some other part of the world. Okay, so how these two devices are getting connected is based on the ISPs. So ISPs are the one which are connected to each other and that are responsible for sending the information back and forth. Okay, so let me show you the diagram how the ISPs are connected and how the multiple ISPs over the sea can be connected. So if you see here, submarine cables. Okay, so this is how the whole world is connected. Let me pick up a clear example. Okay. So how the world is connected, we are having the undersea cables. So every country is having some port where the ISP will be connected, and ISP will do the cabling under the sea. Okay, so cables will be went from the seas to the other part of the world, and this is how the communication is happening from India to USA. Okay, because there are multiple cables that are been raised from under the sea, and that is carrying your data from India to US. Okay, some people think that the communication is happening over the satellite. That is also one kind of communication, but that will be very slow because that is on the wireless, and wireless is very slow medium as compared to wired. Okay, so we are having multiple wires which are going under the seas, which are connecting one country to another country, so that the communication can happen from one country to another. Okay, so this is how the wires are there between under the seas, and the communication is happening. See, there is a person who is putting the wires under the sea. Okay, so this has been done very in a planned way, that so that the wires could not be get damaged, or these are very high-end series wires, so they will not get damaged for the years. Okay, so the maintenance for these wires has will going on at time to time, so that the communication should not go down, or the internet should not go down. Okay, now I have talked about the switches. Let's talk about the routers. So these are the Cisco routers that you will see. So if you look at this image, as compared to switches, we are having less number of NIC cards, because routers are not used to connect the end devices. End devices, I'm talking about PCs, laptops, okay, servers. Routers are not used for that. Routers are used at the edge of your company or edge of your home network to send the data to the ISP. Okay, so that is why we are only having one or two NIC cards, okay, to which your switch or access point will be connected, and your PC or laptop will only be connected to the switches or the access point. Okay, So if anyone wants to communicate to the ISP, that data will be going through the routers and will be sent to the ISP. Okay, so we are having multiple models of the router based on what features that router supports. Okay, so let's see that. So if you look at this image, let me take this image to the paint. So the router can be as small as the 800 series router. So this router can be used for the very small company or can be used to your home network. So you can buy this router for your home as well. And if you are a startup company, you can make use of this router. Okay, and this can be used as an access point. If you can see, there are antennas are connected. Okay, so some of the Cisco routers are also used as a wireless access point. Okay, then comes the 1800 series router, 2800 series router. Okay, so the basic difference between these models are the amount of traffic that each router can handle. So let's say on a LAN segment, we are having 10 to 100 users. So we can make use of the 800 series device, but let's say we are having thousands of users. Then you have to buy the routers which can handle the traffic generated by the thousand of users. Okay, so if you can see here, this is also one kind of router which will be of the Elmira size. Okay, so these are the high-end series router which will be connected to the very large company, because there will be thousand or 10,000s of users who will be sending the data every minute. So the router CPU and memory should be there to handle those kind of traffic. Okay, okay, let me open the PPT from which we'll be doing it. So you should you should be familiar with these terms: the CPU, memory, NIC card I have explained, and the application. Okay, so likewise, your laptop, networking devices are also having some kind of CPU, central processing unit, who will be handling the traffic and sending the traffic where they need to be sent. Okay, so that all thing will be handled by the CPU, and every networking device is having their own CPU. Okay, and similarly with the laptops, the routers are or the switches are also having some kind of memory. Now, why the memory is needed? Let's say the traffic coming on this interface. Okay, so what router or the switch will do? They will store the traffic on this interface. Okay, to store the traffic, they need some kind of memory, and then they will analyze where this traffic need to be sent. Okay, so once they analyze the traffic, the interface or the NIC card to which this traffic need to be sent, they will put the traffic to that interface memory, and then that memory will send the traffic to the wire. Okay, so every device is having their memory, and that memory is used to store the data. Okay, and the operating system. So if we talk about your laptops, the Windows, so Windows is a operating system that you are running on the hardware, who is giving you the interface, correct? So similarly, the routers are also having the operating system, and the switches are also having the operating system, and that is known as iOS, Internetworking Operating System. Okay, so this operating system is responsible to whatever things the router will do. So if the router wants to send the packet from one interface to another, because of this operating system, the code that is running inside this operating system is responsible for doing all the things. Okay, and similarly, they are like the laptops or the other machine, the routers are also having some kind of application. Okay, we'll talk about those in details once we'll be digging into the technical sessions. So I'm just giving you the overview, what all things that are needed inside the networking. Okay, so application can be a network aware. Okay, we are having a question here. every device is having the operating system. So every networking device, even if it is a switch, if it is a router, every device is having their operating system, because we need some kind of operating system who will manage the things whatever the way we want. So we will be running the code over the operating system, with the help of which the routers or the switch will behave as they're supposed to be. So Cisco is having their own operating system that is known as iOS, Internetworking Operating System. So just like Windows, Linux, okay, so those are some sort of operating system that are running on the laptop or desktop. So Cisco devices are running the iOS, Internetworking Operating System, okay. So this is a separate kind of operating system used by the Cisco, okay. But there are some high-end devices. If we talk about the 4400 series router, or 4K routers, 4000 series router, those are running on the under the Linux, okay, and over the Linux the iOS is running, okay. So depend upon which model you are using, the operating system will differ, okay. But basically the iOS is the first operating system that was introduced by the Cisco, over which all the networking devices were running. So just like the Windows or the Linux, you need some file of the operating system to install it into your laptop, okay. So similarly the iOS is also having a file that is known as a bin file. So it is with the .bin extension, okay. So that file will be stored inside the memory of the router, okay. So when you give the power to the router will install that file, okay. Router will decompress that file and run it on the hardware, okay. So the process is similar to all the machines. If you are using a laptop, the similar thing will happen. Once you give power to your laptop, what it will do, it will load the operating system, it will load the Windows, correct, okay. So it will load the Windows in your C memory. Similarly, router is also having the separate memory in which it will load the operating system, okay. And one more thing, never try to cram the things, never try to cram the things whatever you are seeing. So if you are comparing the things with the other machines with to whom you are familiar with, so you are familiar with the laptops or the desktop, you know that how the laptops and desktop operate, okay. So you can compare that thing with the routers, so how the router will be operating if it is having an operating system, okay. So the process is similar, okay, but the functioning of the operating system is different, okay. So the operating system of the router is used to transfer the packets as fast as possible, okay. So the functioning of the operating system is different, but the process is similar. Now I was talking about the applications. Application can be network aware or network unaware. So what do you mean by the network aware application? If we are having the notepad is also one kind of application which is running on your Windows or your Linux operating system. So if you do any changes in a notepad and save it on your desktop, that notepad information is not shared on your network, or it will not get synced with any of the server over the ISP, okay. So that kind of application is known as network unaware application, because that application doesn't know if I need to say whatever the information is stored in my notepad, I need to send it to other devices, or I need to share it on the other network, okay. So that is known as a network unaware application. But if you talk about the Outlook or the Gmail, or you can say WhatsApp, these are the network aware application. Any changes you do on the Outlook, let's say you want to send the mail to someone but you stored it in your draft, so what it will do, it will send the information to the Outlook server, and that information will be stored in the server, okay. So even if you are opening the Outlook from the other machine, you will able to see that information, because that information is already stored on the server and you are getting the information from the server. But if you stored something on a notepad in one machine, you will not able to see that information in the other laptop or other machine. Okay. So that is the difference between the network aware and network unaware application. So these things I have already talked about. What are the end host devices can be? End host devices can be laptop, PCs, smartphone, tablets, or servers. Okay. So now I have talked about the switches, access point, and there were some devices used previously which are known as hubs. Okay. So this is also the devices which are used on the LAN side. But hubs is not having any memory, so it will not store the packet which is coming on the interface. Okay, so these are the kind of dumb devices because it is not having any memory. So but the switches are the intelligent devices. Okay, because switches are having some kind of memory and it will forward the packet based on the MAC address. But hubs will not do forwarding based on the MAC address. If any packet coming on the NIC card of the hub, it will send the packet to all the NIC card which are available. And so that is why the hub was known as a kind of dumb device. Hubs are not used anymore, so switches have replaced the hubs. Okay. Now I have talked about the routers. So these are the symbols that are being used by the Cisco. If you want to do any practice or if you want to make the network diagram, so you can make use of these symbols that represent each and every device. So if for switch, you can represent like this. Okay. For hubs, just a single this one. Okay. For access point, it can be like this. Okay. For routers, it will be like this. And for firewall, it will be like this. Okay, so these are just the symbols that are that are described by the Cisco in order to make the network diagram. Now I have talked about the router. Let's talk about the firewall. What is firewall? Firewall is basically the security device that is inside that will be used inside your network, or you can say on your LAN segment, to provide the security to your end host. So let's say there is one attacker on the internet who wants to get the information from your enterprise, because your enterprise information is very delicate information. You don't want anyone to see that information. Okay, so there is a server here and someone wants to hack the server. Okay, so I was talking about the firewall. So let's say someone wants to hack the server. Okay, so firewall, if we are having a firewall in between your enterprise network, okay, so this is your WAN site and this is your LAN site and this is your firewall. This is your switch and the end host. Okay, so firewall can be connected on behind the router or after the router, depends upon what kind of what kind of design you have got for your enterprise. Okay, so let's say any attacker want to attack this server. So what firewall will do? Firewall will not allow the traffic which is coming from the internet, because according to firewall, this network is unsecure network. Okay, and this network is secure network. So any communication from the secure network to unsecure network is allowed, but the communication from the unsecure network to secure network is not allowed by default. Okay, but by making any changes, some changes, you can make that happen, but by default that is not allowed. So we have talked about the devices. Let's talk about some kind of cables. What kind of cables will be used inside the networking? Okay, we are having a question that can we install the firewall on the routers or not? Yes, there is a feature that Cisco iOS will provide you, that you can make make your router to act as a firewall. Okay, so what you will do, you will make some kind of configuration. Okay, so based on that configuration, you will make this the LAN segment. You will make this LAN segment as a secure network, and this WAN segment as a unsecure network. Okay, so the traffic will be allowed from secure to unsecure, but the traffic from unsecure to secure is not allowed. Okay, but this is not the default behavior. You have to do some kind of configuration on the router, then only you will able to do that. But if we talk about the firewalls, that is the default behavior of the firewall. You don't need to do any configuration on that. Okay. Okay, so let's talk about some cables. What kind of cables that are being used inside your LAN or on the WAN side? So this is the coaxial cable which will be connected to the modems. Okay, so these are not now being used. So previously, when we are having the modems, which are known as the modulator and demodulator. Okay, so to those modems we connect these cables. Okay, but now we are not having any modems. We are having the access point, and that uses the coaxial cable, which is like this, the Ethernet cable. Okay, so any switches, any routers, okay, or any end device will make use of this Ethernet cable, which is having this connector. Connector is known as the RJ45. Okay, so if you have seen the NIC card is in the shape of like this. Correct. So this connector is also the shape of like this. Okay, so you will put this connector inside the NIC card and the wire will be connected. Okay, so now the Ethernet wires are available in the two variants. The first one is the shielded twisted pair, and the second one is the unshielded twisted pair. So shielded twisted pair means that inside the Ethernet wire there will be a coating of aluminium. Okay, so why this coating is needed? Let's say you are in the company where you are connecting the devices where the electrical generator is there. So because of the electrical generator, some kind of electrical signals are getting interfere with this wire. Okay, so in order to protect the data, so whatever the data going inside the wire, that is also in the electrical signals. Correct. And there is one generator who is also generating some kind of electrical signal. So in order to prevent these electrical signals to interfere these electrical signals, we will coat this, we will make the coating of this wire, or we will shield this wire with the help of an aluminium coating. Okay, so aluminium will not allow these electrical signals to get interfere with these data electrical signals. Okay, so in that scenario, we can use shielded twisted pair. But here, the scenario where we are not having any electrical other devices, let's say we are not having that generators, we are having normal PCs and routers and switches, we can make use of the unshielded twisted pair. Okay, so unshielded, as the name describe, it will not be having any coating for the aluminium. Okay, and unshielded twisted pair wires are less costly than the shielded twisted pair. Okay, so shielded twisted pair are more costlier than unshielded. Now these are the wire which are used on the LAN side. Okay, so the router will be connected to the switch with the Ethernet wire. The switches will be connected to the PCs with the help of the Ethernet wire. But there is one more type of cable, which is the serial cable. Okay, so this serial cable will allow you to connect to the WAN routers, to the ISP. Okay, so now this serial cable is having the DB9 connector. So you may have seen the serial wires which are having this sort of pins. Okay, and it is having some kind of this structure. Okay, so if you have seen your old PCs, those were having the serial cable, and you connect your PC, your monitor and the CPU, okay, with the help of the serial cables. Okay, so these serial cables are being used on the WAN side. Okay, so depend upon the LAN and the WAN segment, you are using different kind of cables. Now, instead of the Ethernet cables, we are having the fiber optic cable as well. Now, what is happening in the Ethernet cable or the copper cables? The data was sent in the form of the electrical signals. But in fiber optic cables, what is happening? The data is sent in the form of light. Okay, so the light is more faster than the electrical signal. So if you want to have the communication in a faster rate, you can make use of the fiber optical cables. Okay. Now these are the variants of the fiber optic cables. So there is a multi-mode fiber and the single mode fiber. So the multi-mode fiber will be used for the shorter distance and the single mode fiber will be used for the longer distance. And similarly, like Ethernet and the serial cable, for Ethernet, we are having the connector as the RJ45. For serial cable, we are having the connector as the DB9. And for the fiber optic cables, we are having two types of connector. So GBIC and SFP. So these looks like this. If you are having any port which allows the fiber optical cables to get connected, so you will see this kind of connectors on your devices. So if you can ask any question if you are having anyone. Yes, Cisco has their own firewalls. So let me talk about that also. Cisco's firewall are known as ASA, Adaptive Secure Appliance. Okay, so we are having different models for the ASA. Let me show you. So these are the firewall which are introduced by the Cisco, which are known as the ASA firewall. So now the Cisco has introduced one more variant of the firewall, which is known as the next generation firewall, and that is the Firepower. Okay, so the Firepower is the new variant of the Cisco firewall, which is known as the next generation firewall, and it is having the IPS, intrusion prevention system, IDS, intrusion detection system inbuilt in this firewall. Previously in the Cisco ASA, Adaptive Security Appliance, you need to add an extra module to do the IPS and IDS. So these are the feature related to the security. Okay. So these are now inbuilt in the next generation firewall. Previously, we have to do buy the separate module for the IPS and IDS. So yes, Cisco is having their own firewall. Yes, firewall can be a software based or the hardware based. Okay, so if you are looking at your PC is you also using some kind of firewall, so that is the software based firewall. But if you buy a box which is the Cisco firewall box, that is the hardware based firewall. Okay, so Cisco will provide you one box which will include all the features of the firewall, and you can put that box into your enterprise that will do the security features. Now Cisco will also provide you one software. So what Cisco will do, it will provide you one software and you can install that software on your devices. Let's say you will install that software on ESXi or VMware. Okay, so you can make use of your own hardware and buy a software from the Cisco. Okay, and that hardware will make that hardware will be acting as a firewall based on that software. Okay, so the Cisco is providing hardware based appliance as well as software based appliance. So for software based appliance, you will install that software on the ESXi servers or the VMware. So these are the servers which will install the virtual machines. Okay. So we are having a question: is the working of the NIC same as the modem as it converts the signal? Yes. So every device who wants to communicate with the other device, even if it is a router, even if it is a modem, even if it is an access point, it should need some kind of interface through which it can send the data. Because if we are not having any NIC card, we're not having any interface, how the device will send the data on the wire? Okay, so that is why we need some kind of NIC card over which the data should be sent. Okay, and the VMware can be installed on your laptop. So if you are using a laptop and you are having enough memory, you can install the VMware, and over the VMware you can run different platforms. So let me show you. I'm having a VMware here. So this is the VMware workstation I am installing on my laptop. Okay, so on the VMware, I am running right now Windows 10, but on the VMware, I am running Windows 7. Okay, so if I power on this machine, I will able to run Windows 7 as well on the same hardware. Okay, so this is the use of the VMware, that you can install multiple machine on the single hardware, multiple operating system. Okay. So any other questions? So there is a question: can we install firewall on the servers directly or before the servers? See, servers, we are talking about, servers are also basically the operating system. So that operating system can be Windows server or the Linux server, correct? So those operating system will be having their own software based firewalls. Okay, but if we talk about the firewalls that are dedicated firewalls, okay, so those firewalls are basically deployed at the end of the network, at the edge of the network. Okay, so if we are having this kind of topology in your enterprise network, let me show you. So if you are having this kind of topology, you are having one router, switches, and then your end host. Okay, so you can either install the firewall here before the router or after the router. It's your choice. Okay, so if you want to act firewall to do the routing as well, you can install it at the edge of the network. Okay, so these are the dedicated box which will provide you the security feature and help you to prevent the multiple attacks into your enterprise. Okay,
what are the network devices and so basically before starting off with the teaching, right, I can proceed with the syllabus. I can immediately start off with the syllabus, but I just want to know if people, when I say, for example, I'm telling you, say, hub is a thing which actually it's a layer one device. It is no intelligence, does not have any intelligence, just broadcast everywhere. But people should understand what is a broadcast now. If he says that what is a broadcast, he has to understand. Okay, this is how the broadcast happens. And also, if I say, uh, you know, which is an intelligent device, it takes down the writing of a MAC address from the receiver port to the you know sender port. They should understand. Like, have you guys seen a switch or a hub anytime before, or do you know the functioning of a hub or a switch? Is there anybody who doesn't know?
I've seen
Correct.
switch and routers.
Okay. Do you know the functioning of it? How it functions and what does it do and all that?
Routers are used for routing, and switches are mainly used for LAN network.
Okay. So is there anybody who does not know anything, who are starting as a very fresh candidate for this CNA? Just want to know because the explanation should be in the basic terms if somebody doesn't know about it, right? I cannot go over it, so just wanted to make sure. Now, whenever you take a field, like you take about software, you take about hardware, okay? You take about wireless. There should be some devices, right, which supports wireless, hardware, software. For example, what are the things that you know in software? Which support software, coding, right? The most famous, most popular coding. For that, you need a server client, right? Wireless. For wireless, what do you need? Wi-Fi, access points. Similarly, for networking, you need networking devices. What are those networking devices? Hubs, switches, right? Routers, firewalls, right? These are the devices which actually make up your network. Whenever you speak about a network, you should know that the network devices are hubs, routers, switches, and so on. Because I'm just not making you by heart it. So, because as and when we deal with different, devices in future, you will get to know that okay, these are the devices because these are the devices I play with on a regular basis, right? So, let's talk about the first device. We can talk about the first device, but before that, anybody has any confusion, or we can be move further. Anybody has any doubts?
So far, good.
I will take that as none, and we'll start moving. Hubs. Now, Abhishek, do you want to say something? All right, I am back. Okay, so let's take an example. Okay, not an example. Now, first of all, whenever there was a computer invented, okay, there was a computer invented, right? Now, whoever invented this computer was able to do all the Excel calculations, whatever. Okay, he was able to do a list of objects, right? He was able to list out everything. Fine, he should be good with that. But he was also playing some games, whatever. Then he had lots of data in his computer, lots of data, right? Now everything was going smooth until unless he found out that okay, this is my house. Until I come to this computer, until I come to this computer, I don't have access to that data which I have stored in this computer anywhere outside. If he goes anywhere outside his house, he is not able to access that particular data or whatever the list of Excel files that he has stored in this computer anywhere outside this his house, right? So there arose a problem. What is the problem? Communication. So what he did, so okay, I'll keep another computer for office, because I am not able to access this particular data in my office. So I'll take another computer in office. What he did, again he made all the data, replicated it, okay, on the computer in his office. The same Excel list, everything is he prepared. Next, he moved to his branch site or many branch offices or whatever. He moved to another location, but he is not able to get hold of either of the data. right? Maybe you can also imagine it as room, hall, maybe room number 2. When he goes from one room to the other, he is not able to get that same particular data on 3 different PCs. But he has 3 different PCs. Again, he has to write all the information from PC1 to PC if he wants to access. That is where there arose the need of something which is centralized. Even though you have 2, 3, or 4 PCs, a person realized, okay, the one who discovered realized that there is a need for connecting from one system to the other, right? There is a need for connecting one system to the other. Why? Because if I have computer and do not connect it to internet or do not connect it to anybody across, let's say I have a computer and I don't connect to anybody of you, I just have it at home, I don't connect to the internet, nothing. What am I doing? Nothing. No use of that computer which is only to me, unless and until I get the information from outside or send the information outside, neither talk with people. That kind of a computer is not at all used. So they found out connecting from one computer to another computer is very important. So they brought cables. They started connecting from one computer to the other. In early old days, you knew the computers were very less. Just when the computers were discovered, you could see that only in 1 or 2 houses, or maybe in 1 in 10 houses, not in 10, 1 in 100 houses had computers, right? So at that time, computers were very less. So if there was any computer anywhere else, they said, okay, I'll ask service provider. Now, what are the service providers in India or like US? Like in India, we have something known as, Airtel, Vodafone, or Jio, Reliance, whatever it is. In US, we have Verizon, AT&T. These are the service providers which actually connect from one organization to the other, or connect from an organization to the internet. Okay. Now we connected from one computer to the other. Okay. I brought a computer at home. Okay. It's in room 1. I brought another computer, which is in room 2, just to share the information between them. I wanted to share the information between them. I connected from room 1 to room 2 using cable. Now, I brought another computer, which is in room 3. Even that needed the information. I took another cable. Next house, I wanted to connect to the next house, who is a friend of mine. I took another cable, and he has 2 computers. I connected with another cable. So as you can see, the usage of cables are increasing, where the cables are costly, right? The usage of cables were increasing as and when the computers were increasing, right? As and when the computers were increasing, the usage of cables were increasing. So what they did, they came up with an idea. All right, let's discover something known as a centralized device. What is the centralized device? It is a centralized point where you can connect all your computers to. They got a hub that they named it as a hub. Okay. Now bring in your computer. First floor, connect. Second floor, just connect. Third floor, just connect. Fourth floor, connect it. Okay. Now also you're using cables for just to connect to the hub. Okay. And hub, as you can see, if you want to connect from PC1 to PC2, you're using one cable. PC1 to PC2, another. PC1 to PC3, another cable. You see how many cables you were using per PC. It was more, right? But with hub, just use one cable, finish it off. Hub was known as centralized device. Why centralized device? If I send the information out of here, it will send to all of them except myself back. Okay. Only on the port which I have sent, it will not come back. But the information will go to all the other ports. Okay. That was how the hub was designed. That was a intelligent design, right? Now, moving on. Till now, anybody has any doubts? Are we good?
Yeah. Thanks.
Okay. Moving on. Hub was able to do the job of a centralized device. Fine. You don't have to send to each computer. You don't have to send to each computer. Okay. You just send it to me. You just send it to me. I am a centralized device. I will take care of forwarding the traffic to I'll send out the traffic to all the others. Fine. That was working fine. That was an intelligent move. Okay. But you know the functioning of a hub. If I send it out on one port, it will automatically send the same traffic on all other ports. On all other ports. On all the computers connected to all other ports. All right. So what if you send it from here? If you send it from here, except this port where the information is coming in, it will send the same information on all other ports. Even if there is a port here, it will send the information on that port. So what do we call that? There are three types of communication. Communication is divided into three types. Unicast, broadcast, multicast. Right? What is a unicast? One person talking to one other person. For example, this computer talking to this computer. One person, one sender, one receiver is known as unicast. Whereas, let me write as 1-to-1. One sender, all are receivers. Like in our hub, right? In our hub, I just showed you, if you send out the traffic on one port, all the other ports will have that information received. Okay, all the other ports will get that information. So it is one to all. Let's talk about multicast. One to group. One to group. Now, what is a group? All. One to group. Okay. Now, what is a group? For example, only this computer, these two computers wants to receive the traffic which is sent by PC1. PC3, PC4 only wants to receive. PC2 doesn't want. So it's only a group of receivers, one to a group. One sender to one receiver is known as unicast communication. One sender to all receivers, one sender to all is known as broadcast. One sender to a group of receivers is known as multicast. For example, the training which I am doing now is a multicast. Whoever is interested in this particular class will be available and listening to me. If I am only speaking to Amit or like Utkarsh, whoever it is, only speaking to only two of them or only one of them, that is a unicast community. Okay. Hope you got to know the difference between unicast, broadcast, and multicast. Right? These are the three different types of communication we have in network. Hope that is all clear with you. Okay.
Sir, I have a question.
Moving on.
Hello.
There
Hello.
was some problem with the hub. I told you they invented a hub
We all receiving your communication, so why is it not a broadcast?
because you are a group of people, right? You are a particular group. Not everybody in this world are receiving that information. So, for example, this hub has 10 ports. Okay. Imagine this hub has 10 ports. Okay. If one person sends the traffic and all other 9 receives it, that is known as broadcast. If one person sends the traffic and only particular ones who are interested receives the traffic, that is known as multicast. If one person sends the traffic and only one other port receives the traffic, it is known as unicast.
And is it correct to say in broadcast, other 9 people, they cannot send traffic back, but in multicast, they can send traffic back to that one person?
Nothing like that. Nothing like that. So it is all like, so if you have PC1 sending the traffic, PC2 is receiving. Of course, PC2 also can send the traffic. He can, use the IP address of PC1 and send the traffic, right?
That's unicast, right?
Unicast. That is unique. One-to-one is always unicast. If one person or one computer talking to another computer, it is always unique. Right? Next thing. Maybe if you're not clear, I'll just give another part of explanation. Imagine a hub. Okay. Let's take 8 ports. 8 ports in a hub. Right? You can connect from your computer, you connect a cable to one of the ports. And there is another computer connected here. There is another computer connected here. Another computer connected here. One more PC connected here. One more PC connected here. So you are the designer. You're the designer for this particular network. You have so many PCs connected. Now, you want to speak to from one, let me name this 1, 2, 3, 4, 5, 6, 7, 8. You want to speak from 1 to 8 to send out the information. Information goes to hub. Hub is a device. So we just spoke that hub is a device which will never care where you send out to whom you send out the information. Even if it is from 1 to 8 or 1 to 7. My job is to send out the same information received from port 1 to all other ports. Even if you want to send it to only 1 to 8 or 1 to 7 or 1 to 3, I don't care. My job, the way I am designed is, if I receive any information on any port, I will transfer that information, or I will flood that information on all other ports. So basically, according to the type of communication that I explained you a little earlier, what kind of communication a hub is doing? It is broadcast. Exactly. It is broadcasting, right? Because it is receiving on one port and it is flooding it on all the other ports, right? Basically, the hub is doing a broadcast. Now, this became a problem as and when the computers were, going more and more and more. This became a problem because there were companies set up at that time also. Now, this PC connected here, these two PCs which were connected here belong to the accounts department, okay, in the organization, okay. These two PCs which were connected here, they belong to some other department. Let's say HR department. And here the PCs, these two were operations. This is also for operation. Now 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I wanted to send one of the operations file which belong to the operations, like see, we have to use this VLAN, or we have to use the security guidelines to get the circuit up, or whatever. Okay, these are the rules that we follow. These are the secrets of networking. Something you have to send it to the operations department. But the problem is, once you send out of this PC, all other PCs were getting this information. The HR department didn't want this information. Accounts department didn't want this information. But still they are getting it. Right? So this kind of a disadvantage. Now, at the same time, even if operations 3 sends out a message to operation 4, again it will go to everyone. So as you can see, the arrow marks inside the hub, you see a lot of traffic, right? So there is a congestion in traffic. There is a kind of congestion. There becomes a lot of traffic that the hub cannot handle because of its broadcast nature, right? And also one of the disadvantages, the hub broadcasts to every port. With this, what happens? The computer, even though he is not interested, a computer which is never interested in the traffic, should I mean, will be forwarded with that particular traffic, which is not what we want. So as and when the computers started increasing, as and when the network started growing, now there was a big headache. They started thinking about some other device which can actually perform efficient, not like hub, which can broadcast, right? So then they came up with an idea, and they came up with something known as a switch, which is even famous even today. I mean, which is still famous even today, right? I think most of you guys know about switch. Okay, maybe the functioning you would not have known, but Amit, do you want to ask something?
Yes, sir. So usually we come across two terminologies. One is broadcasting, which is clear. You have already explained it. But sometimes people also use flooding. So are they both same, or there is a difference?
They are both the same, because flooding, in the sense, when you just think about the river which is flooding, it doesn't care, right? It doesn't care. It goes everywhere. The water goes everywhere. That is why you use the word called flooding. Similarly, go ahead.
Yes, sir. Understood. Got it. Thank you.
Yeah. Similarly, a hub also, it doesn't care who is sending from whom to who. It just floods from everywhere to everywhere. Okay. And unicast, I think you would have understood. Broadcast and flooding are the same. Multicast, I think multicast traffic you should be clear by now, because see, most of us are using. See, for example, when you think about Netflix or Amazon Prime, so if you are a subscriber, only you get that particular episode or season or movie, whatever. If you're not subscribed, you will not get that. So Netflix is only sending the channels or seasons episodes to those who are subscribed. That's kind of a multicast. Okay.
So broadcast and multicast is somewhat clear. However, unicast is creating a bit of dilemma there. A reason being, suppose there we cannot unicast if there are multiple devices connected on a hub, right?
We cannot.
Okay.
But the problem will be the behavior of a hub. That's it. But if you send the information from this computer will definitely receive it. Okay. Now,
Understood.
your question is, can we unicast from in a hub? Can we unicast? Yes. The hub will broadcast. The hub will send to all other ports. Okay, it will send here, it will send here, and it will send here. Now, this computer's IP address is 192.168.1.1. This is 192.168.1.2. Now, if I send from 192.168.1.1 to 1.2, the hub will broadcast it to all the ports, but this computer will say, hey, I am 1.2 and I will receive this information. Now, this computer will say, I am 1.4 and I don't need that information. I am 1.3, I don't need that information. Even though it receives that information, then it will discard the packet. Discard the packet in the sense, even the information that it has received, it will just throw it away. Okay. Whatever the information it gets, it will just throw it away. It will not use that information because it knows it is not correct. Okay.
Understood, sir. Thank you.
Yeah. The next thing we're up to is the switch. Now there came, they wanted to do some, okay, let's do something.
Sir, email can be an example of unicast.
Yeah, email. See, so if I send it to Shankar Das only, email Shankar Das, only your email in the two, that will become unicast. If I email you, Amit Verma, then Virender Singh, if I unicast only particular of them, that will be a multicast. But if I use the group known as CCNA batch, okay, and send it to hi all, it will be a broadcast where I'm sending to everyone.
Oh, oh, thank you.
All right, moving on. Now, they invented something known as a switch, which is denoted in network terms with the two arrows. One is pointing towards the right, the other is pointing towards the left. Okay, that was known as a switch. Now, switch, if they invented switch, now you would have already known, okay, it will not behave like a switch. It will not behave like a hub, because the disadvantage of hub was it forwarded the information on all the ports. That is, it was flooding the information. It was broadcasting the information, right? That is one of the major disadvantages of the hub. Now, what happens if the hub broadcasts? The computers who are even not interested in the traffic will be able to get that information, and they have to deny it later, right? That was the problem with the hub. Now, what happens with the switch? Let's say I have a computer connected here. Let's say I have a computer connected here.
Just just want to add one comment on this. Can
Go
we
ahead.
say radio is a broadcast?
Definitely. It can be a broadcast if you think about only one frequency, right? If everybody switches to that particular frequency, it is a broadcast.
And in same sense, the news channel and TV channels, they are broadcast as well.
Yes, they are broadcast.
Thanks.
Now, in switch, we have these three computers, these four computers connected. Now, at first, let's give a name. Let's not talk about the IP address so far. I mean, so quick. Say he is A and he is B. He is E, he is F. I want to go from A to B. I want to send the information from A to B. Let's look at how the switch behaves. Once the information comes here from the computer to this port of the switch, switch has something known as, in its CPU or inside the switch, there is something known as MAC table. Okay, MAC table. At first, where there is no information sent from any PC to any PC, the MAC table will be empty. The table will be empty because which learns or makes this table dynamic. What do you mean by dynamically? Means as and when the information flows through the switch, it will create this MAC table. Okay, that is why we call it as dynamic. Now, once the information from A comes to the switch, now switch will see A is sending it to B. Okay. Now switch will broadcast the information for the first time. Only for the first time, switch will broadcast the information on all its ports for the first time. Why? Because the table inside the switch, MAC table, is empty. It does not have any information stored for where is B. right? Now, once also gets this information, and in this information, it is asking, are you B? Is your name B? So he declines this packet. F discards this packet. Now B checks this information. Here it says, are you called B? The computer B will understand, okay, this packet is for me. And he will reply back saying that, yes, I am B. In this process, there are two things which has happened to say that the switch is an intelligent. As soon as the information came from A on this port to B, switch recognizes that, okay, I am getting information from A and A is connected to port 1. Okay, because this is port 1. It knows. So if I am like, if you think, just imagine, I have 4 to 5 hands. Okay, 4-5 hands. Okay, one of you guys, I mean, for example, Bilal, Amit, Abhishek, okay, Pawan, maybe you are holding one of my hands. Okay, once you send the information or once you shake my hand and say, pass it on to maybe some other guy, and you say your name, I will know that, okay, my right hand is now connected to Amit or Bilal, whatever. Okay. Similarly, the switch also has many ports. Only once the information comes into that port, it will know that, okay, A is connected to port 1 because A will send the information with the source address and the destination address. Right? So looking at the source address, it will come to know, okay, my port 1 is occupied by A. Once the B receives this information and sees this information where A is asking, are you B? Then it replies, yes, I am B. Then it will make sure, it will write down the table. Okay, B is connected to port number 4. Okay. Next time A sends any information to B, after that, next time, then it will check its MAC table. Hey, A, okay. A is anyways port 1, I have that entry. It wants to go to B. B is on port 4. Okay, let me forward that information only on port 4 instead of broadcasting on every other port. That is the functioning of the switch. That is how the switch was designed. Okay? Any doubts?
No, so far. Thank you.
Sir, the MAC table will be formed when the first time A is sending a signal to a B, right? So at that time, the B's IP address will be port address will be stored in the MAC table, and next time when any traffic will be sent, it will go to B only, right?
Exactly. So this is A. First time when A sends the information with the source address as A, for example, let's create a source address and destination. Source is A, destination is B. Okay, B is connected here, C is connected here, D is connected. Okay, this is B. Now source address is A, destination is B. Packet comes here. Switch checks that my MAC table is empty because it is the first time. Okay, so I will broadcast this on every port asking who is B, who is B, who is B. B replies, I am B. Once the packet comes from A, looking at the source address, it will say port 1 connected to A. Okay, and when B replies, see, I am B, say port 4 is connected to B. The next time the information comes in, Another packet comes in next time. I want to go from A to B. You will say, information comes here. Okay, source address is A on port 1. I've already had that entry. Now I want to go to B. It will also again check the MAC table. B is connected to port 4. I will send only to port 4. I will not broadcast to all other ports. I will not do that. Got it? Clear on that?
Yes.
Yeah.
Yes,
Thanks.
sir.
So that's about the switch. The same thing that I've written here. Hubs are called layer 1 devices. Switches are called layer 2 devices. But switches are known as intelligent devices as they can forward the frames looking at the destination MAC address. As I just showed you, looking at the destination MAC address. Looking at the destination MAC address. What is the destination MAC address here? B. Looking at the destination MAC address, they can forward the information to particular port number. We cannot connect PCs to each other to form a LAN. Hence, switches were discovered to do that job. Now, you might be wondering what is called as a local area network. This is a local area network. Means a switch which has 3 to 4 PCs connected. This is called as a local area network. Right? Nothing. So these are the terminologies that we use in network. Local area network, wide area network, metropolitan area network, right? LAN, WAN, MAN, okay? These are the terminologies that we use. Also remember the terminologies that I used here. Broadcast, flooding, okay? Unicast, MAC table, okay? These are the terminologies. Yes, Amit?
Sir, there are managed switch and unmanaged switch. But we'll come to that later. Sir, this MAC table that you just mentioned here, this MAC table, the switch is called an intelligent device and hub is not, because switch can prepare this MAC table, and then depending on the MAC table, it operates afterwards. This MAC table, can this be configured by us, and can this be set on a switch?
Definitely, you can do that. So basically, switch learns something dynamically. Okay, the design, the way it is designed, is to make a switch learn dynamically. But if you go to the switch, okay, if you go to the switch, you say on port number 1, I should only have the MAC address AB. Then by mistake, if somebody connects the device PC having CD MAC address, then definitely the information which is coming in, it will not allow that information to come in, right? Whatever MAC address I have configured, only that particular PC I have to connect to port number 1. Okay, even if you configure, you have to make sure that you are connected only with that PC. Okay.
Yes, sir.
For
Got it.
example, Amit, let me give you a better example for that. Amit, you used to have labs, right? Computer labs in your
Yes, sir.
schools, right? So they allowed you only to connect from a particular point. Okay. From a particular point, only if you can sit, you can access that particular lab. You can't sit everywhere and access them. right? Because they would have configured your computer's MAC address there on that particular port. If you connect with any other laptop, it would not work, or if any other computer, it would not work. Okay, that's how it is. You can do it manually also, but think in this way. Okay, switch, on the switch, there is a MAC table. On the MAC table, what it does, every particular computer. Now this is the computer on which I'm sharing my screen, right? This is the computer. I'm sharing my screen. On this computer, there is something known as NIC card, which is burned. Okay.
Yes, sir.
Which is
Network interface card. It is burnt on all the devices.
exactly, all the network devices will have this network interface card burnt on it, on the system, on the PC, while designing this PC. And this NIC card will have the MAC address. Every NIC card will have the MAC address, AB, or yours might be BC. Somebody else will be EF, like that. So when I might connect my computer here, so if my computer sends an information, switch will come to know, okay, I am getting the information from the MAC address AB. How will he get to know? How will the switch get to know? Because while sending the information, along with the information, my computer sends additional information saying that the source address is AB and the destination address is EF. Along with the information, it is also sending who is the sender, who is the receiver. Right? That is where switch knows port number 1 is connected to AB. Now, as Amit said, I can go ahead and configure port number 2 with the particular MAC address only, port number 3 with the particular MAC address only. I can do. But imagine huge organizations where there are 70 switches, 60 switches. Do you think a person can go to every port of those 70 switches and configure MAC addresses? It will be a difficult job, right? That is why we allow the switches to learn the MAC address dynamically on its own, right? Since that will be a tedious task to the administrator to go to every port and configure a MAC address, we allow the switch to do that job.
Suppose there is DHCP servers that works and it usually works on a router, but we can configure a server for it as well. We can use another device to act as a DHCP, and we want to connect it to a network through a switch on a particular port. So
Okay.
in that case, can we just manipulate the MAC table?
Definitely.
And okay, got it, sir. That will be all. I'm pretty sure that you will be explaining these things.
We will get into it.
Yes.
We will get
The
it.
only second question that I have regarding switch is the difference between the managed and unmanaged switch. Is it just the layer difference that they work on, or something else as well?
Oh, okay. Since I've explained the switches, let me explain the managed switches and unmanaged switches also. Okay. There is
Hey
all the
there,
switches
continue
which work
learning
on.
directly from industry experts. You are watching these recorded topics from our master's program, but you can watch it live by joining any of these master's program, where you can become an IT engineer that too without coding.
Layer 2.
Now you can continue.
Okay. Just remember this. Okay. Hubs work on layer 1. Okay. L1 is for hub, L2 is for I'll tell you what are the layers also while we move across. Now this
As per
is
the OSI layers, sorry, sir. You're talking about the OSI layers.
yes.
Yes, brother.
Okay.
Yeah, as per the OSI layers, this is layer 2, switch is layer 2, hub is layer 1. Okay. This is a managed switch, right? This is an unmanaged. Okay. Now, what do you mean by unmanaged switches? You people, most of you don't know. I will give a switch to your house, like a Wi-Fi. Do you know Wi-Fi? Wi-Fi is nothing but your switch, come router, come everything. It has switch, router, Wi-Fi, firewall, everything all in one. That is why it is known as a Wi-Fi. Okay, it's kind of an access point where you don't have to connect cable to it. It is also combines of access point. So there are many features on that Wi-Fi. Now, is that your Wi-Fi kind of? Is that your managed or unmanaged? It is unmanaged because there are some devices an internet service provider gives to a home usage. When they give to home usage, at home, people will not configure anything on that switch. They just plug in a cable to that and they start playing. So, unmanaged switch are plug and play. Just plug in and start using. Right? There, we don't have any necessity of getting into the switch and configuring. Right? We
No
don't have to.
setup or no configuration is required in unmanaged switch.
Exactly. But in managed switch, we can get into the terminal, can do the configuration. Whatever you want, you can do a VLAN configuration. We can, bifurcate the traffic. Whatever configuration you need, you can do that configuration. That is why it is known as managed switch, where we can manage. Here, we cannot manage it because it is already managed by someone. Somebody has put in the rules inside this and just given it to us. We cannot manage it. We just have to plug in a cable, start using. It is more of plug and play.
So
Okay.
I guess there are some Netgear unmanaged switches or devices which are used as a plug and play and a medium.
There are Netgear devices. Cisco also has managed and unmanaged. So having said that, the MAC table manipulation that we were talking about earlier, that can be done on a managed switch only, not on an unmanaged switch. Is that so?
Definitely. Only on the any kind of alteration, any kind of changes can only be done on managed switch because managed switch allows you to get inside itself and configure things. But unmanaged switch, you cannot get into the switch itself, right? Because you are not given access to even change anything on this.
Network fundamentals. So I'm writing over here, let us see network fundamental. So within this network fundamental topic, so we have many small topics available. So the major topic is what? The network fundamental, wherein we have various small topics. So when we start with various small topics, the first thing which I told you that we need to understand what is network. Right? So this is the first thing. Then even though before knowing what is network and its component, we should understand what exactly is the communication. Why do we build network? Right? So what is it? Before that, we need to say that why it is required. So that is another component. Why network, right? So once we understood why and what exactly it is, then we will be moving towards what? How exactly it is implemented. Right? So once we finish this why, what, and how, then we will be able to say that, okay, now we are aware about network, right? And this is what I consider it as in one particular, you can say minor topic under networking fundamental, right? And later the another topic which will be we will be continuing, that will be the another topic where we need to discuss about each and every component of the network in depth, right? So when I say this is, so I can consider it as this is the first topic, network fundamental. And we're starting from here, we have this is 1.1, which is network, right? Within 1.1, these three small topics are there. Why network is required, what is network, and what are its components, and how exactly we are implementing this network. So this is what I consider it that we will be covering it in today's class, right? And then 1.2, if I say 1.2 will be the another topic, that another topic will be what? The components, depth of each component. When we say depth of each component, so we will be talking about, once I discuss the component, after that, what exactly is the physical medium which we use within the network. Then after that, we will have the another topic here inside this only, that is what? The devices. So when we look at the devices, so devices are what? The switches, routers, hub, bridges. So we'll discuss each and every type of device and their iOS, right? The depth of each device. So once we'll cover the depth of each device, and then we will have the another major topic, that is what? 1.3, and that 1.3 will be the 2.2. Here I can start writing as in what? Not only devices, I can say we will discuss first about NIC. Within the network, we need to first look at what? Why network is required. Can somebody tell me why network is required? So it's not this networking, which is technical term. Just think about social network. Why social network is required? What is the requirement of social network? We all are connected with social networking sites, right?
For communication. For
Perfect. The purpose is communication. What is the purpose of it? The purpose is communication. So why do we would like to have communication?
To exchange data or information.
Perfect. To exchange information. Right? So this information, when we talk about this information in layman language, we even though call it what it is, data. So this information is what? It could be what kind of informations we have?
It could be
Emails
data,
or
email.
Sometimes we need to have what? Confidential information exchange. Sometimes we would like to have public information exchange. Sometimes we would like to have personal information
Personal
exchange.
info. Yes, yes.
Right? So
Yes, ma'am.
personal information which we would like to share only with our friends. Right? Public information which we can share it with everybody. Like somebody is doing what? A business, and they would like to share that business detail with everybody. Right? And personal detail, like something is personal to me and I would like to share it with my friends or with my brothers, sisters, or with my family. I would like to share, that is what my personal information, right?
Okay, ma'am.
Confidential information is what? Confidential information which I would like to keep it secret only with 1 or 2 people I would like to share, not even with my entire family. Right? So these kind of, there are many type of informations available. So to have the exchange of information, we say the communication is required. To build the communication, we connect with the network. Right? The same thing comes with what? The same thing is available with the digital era as well. So what is digital era? Where we are talking about computers, where we are talking about the devices. So not only the computer, where we are talking about the digital devices. So when we look at this digital devices, what are the digital devices available? Phones, right? Then after that, we use phones as well nowadays, right? Then we have what?
We got email or the exchange,
PDAs,
PBX.
right? PDAs. Then we have personal computers. Then we have laptops, right? A lot of devices we have it. With the help of these devices, we connect to the network. We connect to the network. And then from the network, we go with what? We look at communication. And while doing communication, we do what? We exchange the information. This is what the cycle goes in, right? So we are using, as a human being, we are using all these devices to connect to the network. And when we are connected with the network, we start our communication. And while doing communication, we exchange the information. Yes or no? So this is what layman, why network is required. Ultimate goal of the network is what? Exchange of the information. So what exactly is the role of, if I say why network is required, this is the reason, that's the reason network is required. Like when we look at the older time, in the older time, this task was done by a postman. If we need to exchange the thought from one location to another location, we used to write a letter and we used to send it via the post office. Right? Nowadays also post office is there. But we think that the post office is working very slow, wherein within this digital era, everything is what? So quick, within seconds, fraction of seconds, you can send a message from one location to another location. Via Telegram, via WhatsApp, via emo, there are many applications available. With the help of those applications, we send a message from one location to another location with fractions of seconds. So ultimate goal of the network, why network is required? Because we would like to have exchange of information, and that exchange of information also in what? In fraction of seconds. Quick transmission we needed. Right? So any question about why network is required? So if somebody is asking you why network is required, can you answer that?
Yes, we can answer.
So
Without
anyone
network,
would like to?
no communication.
If there is no network, no communication, no exchange of information.
Right, ma'am.
Right? So we get to know why network is required. Now, once we get to know why network is required, the another topic which we need to start, that is what exactly is the network? What is the network now?
Can you
What
repeat,
is the
ma'am?
network? Yes, please.
Can you say again? What was the question?
What is network?
Network is we are getting connections of multiple devices. If we are talking about computer networking, to communicate from one distance to another distance by using internet service, or inside the building also we can do with the help of Ethernet NIC card or something like that, which communicate PC to PC.
So I can say when we connect two or more than two nodes.
For that, I think, yeah, we can do that, ma'am. If we use devices like which helps you to connect multiple machines.
Right. So when we connect two or more than two nodes.
Yeah, we can say network.
To have
communication.
Exchange of information or communication.
Right.
Right?
Yes, ma'am.
So it is called as in what? It is called as a network.
Network, yes.
Right? So when we get to know, okay, what is network? So let us now think about what are the things we needed to have it.
From hardware perspective?
Yes.
Yeah, we need a computer. We need
Hello?
internet connection. Yes, ma'am. Can you say again? What?
Yes, as in hardware. Continue, please.
Yeah, as in hardware, we need anything, a laptop or desktop, something. And to make communication, we have network connection.
So I can say the nodes. Nodes are required, right?
Yes, you can say that.
Right. And
Yes,
when
ma'am.
we look at the nodes, what are the nodes?
It could be your internet connection modem.
All these devices?
Yeah, all these
Phones,
devices.
PDAs, PCs,
Yes.
laptops, all those devices.
Everything which can provide you communication, that I can say.
In network terms, what we call them? We call them
network
end devices.
end devices. Okay. Thank you, ma'am.
Right? What is this? These all are end devices. In terms of hardware, whenever we need to build a network, we call it what? It is end device. Why we call it end device? Because this end device will be generating the information, will be used by an administrator, and I can say that administrator is what the human being, because we are responsible to generate the information. So that's the reason we call it what it is, the AND device. We get the access of this AND device, then we generate the information. And once the information is generated, after that, we are sending that information to someone else. Like example, if I need to say hello to you, so what I'll do, I need to have my AND device. On that AND device, I will type hello, and then I will click send button, and that information will be sent to all of you. Right? So who has generated that information? Is that computer or AND device has generated? No. We as a human being has generated the information, and then we pass that information to AND device, and then AND device is responsible to further pass it to other AND device. Okay. So this is the AND device, the nodes. Then we would be needing what? As in hardware, we would need some set of servers. Right? Now, what is servers? Servers are also similar to AND devices, but they are having high processing power rather than the AND device. Okay. So AND devices, I will keep a note over here, and I will start writing about AND devices. What is AND device? It is the last AND point. Right? I'm writing last as well as AND, both. Right? It is the last or AND point of the network. Responsible for generation to generate information. And that is the same information which exactly we need to share, right? So what is server further? server, it is having high processing power than the end device. Right? Now then what exactly is the difference between server and this end device? So we need to have a look at that. Right? So I'll show you all the end devices, right? So let me share my screen with you. So I believe now you guys can see my browser, right? I'm on Google, right?
Yes.
So I'm writing here, first thing is what? Phones, everybody is aware what is phone, right? So there might be possibility, personal phones, everybody is aware, PDS, everybody is aware. Let me show you personal computer, right? And we will have a look at the image of personal computer. Can you see the personal computer? So this is the personal computer, which is from the Dell, right? Can you see that this is, I can show you this as an personal computer, this one. This one will be all-in-one personal computer. So it has CPU, it has monitor, it has input, output devices, right? So this is what the personal computer. Now we'll have a look at what the server. Can you see server? The servers are hosted there in the data centers, right? Servers. So you can think about, this is also look like as a personal computer only. But these are what? So you can see it. So this is a person who is inserting this one server in the rack.
Yes.
Right? So these are the servers. So they are small in size, but they have high processing power. When we talk about this high processing power, what exactly this high processing power is?
CPU.
So let me, yes, perfect. So let me come back now to my notepad again. And so what exactly is the high processing power when we talk about it? We are talking about CPU, we are talking about memory.
Memory, yes.
Right? We are
Capacity,
talking about
RAM.
Memory is the RAM only. So let me write technical word RAM. And then we are talking about the hard drive, which is storage.
Yes.
Right? So these three are the main component, right? And very important component when we talk about networking, that is what? NIC, network interface card. So network interface card is also having high processing power to transmit the data quickly or with higher speed or higher transmission rate. So this is the difference between NAND device and server, right? So when we have the high processing power for the server, it means it will generate more heat. So it needs more cooling power. So that's the difference between NAND device and the server, right? So this is the main, you can say that hardware, which we would be looking at, right? As to connect to the network. Then the next we look at the another type of hardware, which we need to have it. That is what? The network devices. Network device, right? So now what is network devices? We need to look at that. So when we look at network devices, there are various network devices available. So initially started with repeaters.
Hub, switch.
Right, perfect. Then with hub.
Switch.
Then with switch.
Router.
Then initially the switch was layer 2 switch.
Yes.
Right? Then it was layer 3 switch.
Multi-layer.
Yes. Layer 3 switch. Then the another switch came in as in what multi-layer, which has the functionality of layer 2 as well as layer 3. So we started calling it what? Multi-layer switch. Right? Multi-layer switch. Right? Then we have another device called as an what? Router. Right? Then we have another device called as an what? Firewall. right?
Yes.
Then we have another device called as an what? Load balancer. Who will balance the load, right? Firewall
Yes.
to filter the data packets, right?
Traffic.
Then after that, we have another device that is known as an WLC, wireless controllers, right? Before the wireless controllers, we have
Yes.
another device which is similar to switch here.
No.
That is what? Access point.
AP. Yeah.
Yes, AP, access point, right? So this WLC and access points are for the wireless network, and L2 switch and multi-layer switch, these are the wired network connectivity, right? So these are another type of hardware we have it. So whenever we talk about the network components, so what are the network component? The first network component is what? The hardware devices which we require, right? Within the hardware, the nodes which we needed. When we talk about the nodes, so we might need AND devices, we might need servers, we would need network devices, right? And then we would need what? Physical cables to have the connectivity. Right? So when we look at physical cables, there are different type of physical cables comes in. So initially when we call it the cable, so we say the copper cable or the fiber cable, right? So when we look at copper cable, within the copper cable, there are various cables having. When we look at fiber, there are various cable within the fiber as well, right? So within the copper cable, the popular cable which we use to connect to the network devices, we call it what? Any idea?
Cat6.
Twisted pair cable, right? And this twisted pair cable comes in shielded twisted pair or unshielded twisted pair, right? So shielded twisted pair or unshielded. The most common which is used, that is what? Unshielded. Unshielded twisted pair, and we short form we call it what? UTP cable. Unshielded twisted pair, right? So, and then we talk about its categorization, that somebody has correctly said it is Cat6, the categorization of your unshielded twisted pair cable. Similar way, when we look at the fiber, within the fiber, there are single mode fiber
Multi-mode.
and multi-mode fiber. So single mode fiber or multi-mode fiber. So these are the physical cables which we use to connect to the network, right? So I'll show you the diagram now about these cables. What exactly, how it looks, unshielded twisted pair cable, how exactly single mode cable or multi-mode cable looks like. Let me go back again to my browser, and we will have a look at the image of unshielded twisted pair cable, right? Can you see this cable, right? So how many cables are inside this one particular jacket? There are 8 cables,
Yeah.
right? And all these 8 cables, when you look at this particular diagrams, it is twisted with a pair of 2, right? 2 cables combined together it becomes one pair, and there are 4 pairs of twisted cable inside one jacket, right? Here in this diagram, you can see that 2 separate cables, then they are twisted together into the jacket. So altogether, when we look at it, what these are 8 cables, and we call it what? It is UTP, unshielded twisted pair cable.
How we can know this one straight cable or
Yes, straight cable and cross cable. How do we
cross cable?
create
Yeah, how
straight
we can.
cable? How do we create cross cable? We will study about those, right? So that's what I'm telling you, that today it's just the initial part. So it is just an overview, and then later we will move in the depth of each component.
No, I can know, ma'am. Through color coding, we can know. No. That's I'm
Yes,
asking.
Through color coding also, there are numbers allocated to it. The straight cable is what? The color which we have decided will keep in one end same color and the second end also the same color. What is the first end and second end? Two end points of the cable. Okay. So if we are keeping the same color, then it is what? The straight cable. But if we are twisting the colors, so I'll tell you that there are two colors which we twist, right? So I'll let you know that which color we twist, how do we create straight cable, how do we create cross cable. I'll teach you that.
Okay.
Okay. So don't worry about that. I'll move in depth of each topic. Today just I'm sharing the overview of everything so that now you are aware these are the topics which we need to cover.
Yes.
Okay.
Okay.
So now we need to look at what? The fiber cable, right? So
Yes.
single mode fiber cable. Right? Here when you look at it, what it is? The optic cable. So it means optical signals are. So if you look at it, what here it is? This is the exact figure of it. So it has one single core, right? Then on the top of it is having what? The multiple components so that the signal should not come out. So there is a cladding, there is a buffer, and then the outer jacket comes in. How this cladding and buffer looks like? It looks like this. Right? Why I have not shown this initially? Because it doesn't have single mode. It has multi-mode inside. Right? So this is the cladding. Yes. This is the buffer, and then this is the outer jacket. Yeah. Right? Perfect. So you get to know what exactly is the optical fiber cable, what exactly is what your twisted pair cable, right? So when we look at the fiber cables, to establish the network, initial network or basic network where we are connecting the endpoints, so we say that single mode fiber, or we say Ethernet fiber cable. Ethernet fiber cable, right? So when we look at Ethernet fiber cable, it is this. This is the Ethernet fiber cable, right? You can say this is the Ethernet fiber cable. You will be able to see that how thin it is, right? Nowadays, even though when we get the broadband connection, so we get this Ethernet fiber cable, where we have 5G connections, like Airtel is providing 5G connections, right? So we have this like this way that they are providing the connectivity through the modem. So this is the twisted pair, wherein this is what the fiber cable, right? So this is the twisted pair and this is the fiber. So it is so thin. So this is the Ethernet fiber cable. How do we build crossover cable? How do we build straight cable? What are the differences? What are the categorization? What are the standards? Those they are available for these cables that we'll be talking about. Okay. So now after this, the physical medium, right? The next component which we need to look at it here, that is the software components, right? So what are the software components? Does anybody having any idea? In terms of software, what are the components we would need?
I think OS, operating system. First thing.
Perfect. Operating system.
Yes.
So which
And
operating system?
applications. It depends on the platform which you're using, either Windows or Linux or.
Perfect. So operating system will be of end devices. Operating system will be of servers. Operating system will be of network devices. So for every device, there will be an operating system available, right? So when we look at it, what the operating system of end device, What is the operating system of an device? As said by, it could be what? Initially, it was
Windows or
it was DOS.
Windows 7.
initially
Yeah, this
DOS. Yeah,
operating system. Yes.
Then after that, Unix, right?
Then
Then after that, Linux,
Server, Windows Server.
right? And then after that, Windows, right? Nowadays, currently, which version of Windows you guys are using?
11.
Windows 11, right? I forget to write Mac,
yeah, Mac also iOS.
right? Perfect. So Windows 11. So Windows 11 is the popular one, right? Similar way, when we look at the OS of servers,
Ma'am,
there
you're
are
not
OS of
sharing the
servers as
screen.
well.
Ma'am, did you share screen? No, not yet.
No? Okay, let
No.
me share it. I'm writing it on over the notepad. Is it visible?
Yes, yes.
Yes. So here I have written first initially the software component. Within the software component, the operating system, right? And then we look at it what operating system of end devices. Right? The popular one nowadays is what? Windows 11. Right? Then operating system of servers. Before even the moving on operating system of servers, if it is phone or PDAs, then what is the operating system which we use? Android.
Yeah.
Yes. Android for the most of the phones. Yes.
Yes, yes.
So further, the operating system of servers. So for the servers as well, Unix, Linux, Windows, Mac, all are the popular one. All are the popular one. And within the Windows, if we need to say server, which server is the popular server nowadays? Operating system?
2019.
2019.
Yeah.
Perfect.
Windows.
Yes, Windows 2019.
Under Linux, maybe.
Windows Server 2019, right? Similar way, when we look at the network devices, every network device, they also have the operating system. Every network device. So be it my network device is what?
Repeater, hub,
Repeater,
switch.
hub, switch, access points. So some of the devices, they have only the firmware. And some of the devices, they have fully operating system. Full operating system. Okay. So some of the devices, like if I talk about the access point, it has only firmware. If I talk about hub, it has only firmware, right? So some of the devices, they have only the firmware. What is the firmware?
It is also OS version.
It's a software.
Upgrades, latest upgrades, whatever.
Yes,
For
it's a
actually patch.
software, right? But we cannot fully customize it. It gives us very less options to configure. Right? And wherein full operating system, if we talk about, it gives you a lot of option to have the customization. We cannot configure every feature within the firmware, wherein with the full operating system, we can configure a lot of things. So the other example, that is what the another software, which was correctly said by somebody, that is what the applications. So if we have firmware, we don't have much of the applications available to install over the firmware. Wherein in the operating system, we can install a lot of applications. Like example, on the Android operating system, how many applications are available on the Play Store? If you go there in the Google Play, how many applications you have it? Have you ever counted applications? How many applications are available? Can somebody check in your phone?
And numbers, ma'am, so many.
So
Not
many.
even
Even though if I say that I need to download a game, or even though if I say I need to even though download an Excel, so I will be able to get a lot of publishers, those they are publishing those applications. The same application is delivered by many vendors. N number of application, N number of vendors are available. But still those everything is compatible with my device, right? Is there any by chance you have seen that your phone is not compatible with any application which is available on Google Play Store?
no, everything work.
Everything is
Yes.
compatible. Everything is compatible. And that is the another feature which we needed to bring the compatibility in. What exactly is that feature? We call it what? Standards or rules, right? So that is the another component. And those standards and rules are governed by a model, and we call that model as OSI model. What is OSI? That is Open System Interconnect. Right? So it is Open System Interconnect. It is a model which is initially shared by a standardization authority. And what is that standardization authority? That is ISO, International Standard Organization. Please, if I do some spelling mistake, because my objective is towards to give you information. Sometimes while writing, spelling mistakes comes in. Please excuse for that. International Standard Organization. Right? So this is the authority who has shared this OSI model. And what exactly is the objective of this model? To bring in interoperability. Or we can say that compatibility. Right? My device is compatible with every application. My device is interoperable with every application. Why it is so? Because of this particular model, because of this particular standard, right? How? Because of this particular standard? Because those are the manufacturer of all these components, be it is hardware, be it is physical cables, be it is software. Every manufacturer is following this particular model or this particular standard so that devices are compatible with each other. Until the time a manufacturer has not properly followed the standard, that device will not be compatible with network and we will not be able to connect the device with the network. Like example, when we look at the Mac, Apple, there are challenges with the Apple, right? Yes, have you heard about there are some challenges with the Apple? The reason behind it, because they use their own proprietary standards. They are governing, they are based on ISO, but for few of the things they follow their own standards. That's the reason for the Mac sometimes we get the interoperability and compatibility challenges. Right? So that's what about the network components. Anything which you would like to ask here? So should I consider it as no? So in case if no, then I can see that why a network is required and what exactly is the network and its components. We are aware about it, right?
Yeah.
Right? So we have seen today a lot of components. Just as an overview, we have seen that hardware components, we have seen the physical medium or physical cables component, we have seen the software components, and then we have seen the standards and rules. Right? So these all are the components. Till the time you will not be able to understand each and every component, it will be very difficult for you to implement a network. Right? So while implementing the network, we need to know which cable we need to use. How do we prepare that cable? Which end device I should use? Which network device I should use? What is the role of the hub? What is the role of the switch? Why I'm using layer 3 switch? Why I'm not using layer 2 switch? Why I'm using a router? For implementing the network, the next thing is what you need to know about all these components in detail. And once you are aware about, then we will be talking about the implementation. And while implementing the network, we need to take care of few more things, right? What are few more things apart from these detail of the components? We need to know about other details. What are the other details? The other details are while implementing, what exactly is the topology which we use it. What is topology? The topology is layout of the network. Right? So when we talk about this layout of the network, we say it is what? It is the star style, right? Bus style, it means what? We are keeping all the devices in a linear format. Within the star, we are keeping what? The device in the form of what? One device as a central device and all other are connected with the central. Right? So that's the way the central format. So bus topology, star topology, right? Mesh topology, where everything is connected with each another. Perfect mesh topology. Everything is, right? So within the mesh, it comes fully mesh, hybrid mesh, right? So we will be talking about the topologies, right? So when we look at the topologies, while even though looking at the topologies or layout of the network, we say that topologies are of two types. One is physical, how the physical layout will be there. The another one is what? The logical. So physical is what? The physical layout. Logical is how the data will transfer. Right? How the data will transfer. Logical is data transfer layout. Right? From which device the data will go to the next device, then to the next device, then to the next device, and then it will reach to the end destination. So that is what the logical topology is, right? Further, after knowing about the logical topologies, then we need to know further that what configuration we perform while having the connectivity or while implementing the network. Configuration of the devices. Right? So while doing the configuration, we generally used to say that we need to have the first thing is what? We need to allocate a name to the device. Right? After allocating the name, we need to allocate an IP address to the device. Right? After allocating the IP address, we need to say that what is the exit gate for a device so that it can transmit the data out. And that exit gate is known as what? The gateway. gateway, IP address. So these are the important things which we configure when we would like to bring a device on the network. Where exactly we perform this configuration? How do we configure it? Right? Either we do the manual configuration, we do the automatic configuration to bring a network device or onto the network. So this is what the implementation stage comes in. The implementation stage composed of what? Topologies and the configurations, right? So this is what I can say, that an overview of my first topic, which is their network, as in why network is required. We would need to know that in which topology diagram we need to implement this network, how physically it look like, and how exactly it is transferring the data. And then after that, while when I'm connecting these devices, what configuration I need to do it onto these devices, right? So we do the configuration of a name, we do the configuration of an IP address, we do the configuration of the gateway, how exactly it will be sending the data out to the gateway. So first we need to understand what is IP address, what is the naming convention, what is gateway. So that once we get to know these things, depth of each detail, and then we will be doing what? We'll be starting the implementation of the network. Right? So this is just as a fundamental overview of it.
So I'll start with what is network. So what is network? So what is network? So like if two computers are connected, they are all, this is also a network, right? So computer A is connected to computer B. So they can share the things with each other. They can send files to each other. So this is a network also, right? And if multiple computers are connected, suppose four computers or four devices are connected with a device which is known as what? Yeah. So four devices are connected with a device that is known as switch. Okay. So this is also a network. When four computers or four devices are connected together, that is also a network, right? And when we talk about like, suppose I'm sitting in India right now and you will be taking this session from US. Okay. So I'm in India right now and you are in US. So so we are also connected, right? But how we are connected? We are connected with service provider network. Okay, so you have your own ISP. Suppose you have AT&T and in India I'm using maybe Airtel or Geo or whatever, right? So all these ISPs are connected together with a cable, or you can say that a fiber cable, that is submarine cable. Submarine cable. Okay, so what is submarine cable? I'll show you all these things. Okay, so this is also a network. So means network can be like two computers are connected together, and and network can be like if 4 or 5 computers are connected. So computers, PCs, laptops, mobiles, you can say anything, any host. So we can say that host. So what is host? So host basically any device which gets the IP address is known as host. So PC is host, laptop is host, server is host. So when we say host in networking, so host means the any device which gets the IP address, that is host. Okay. So PC, laptop, servers, all these machines are your host. Okay. So now, so got my point, right? So this is network. And what is networking then? So this is network. So what is networking? Right? So IT networking, or you can say the networking. So networking means when they are going to share the data. So suppose you are watching my screen right now. So we are sharing resources with each other. So sharing of data and resources is known as networking. Okay. So sharing of data and resources in a network is known as networking. Yeah. The basic I'm covering. Okay, so now in network we have like in industry we call this LAN and WAN. So don't just read the books with MAN, PAN, and there are a lot of other networks. So just simply learn these two terms, LAN and WAN. So what is LAN and WAN? So LAN is local area network. Okay, and what is WAN? That is wide area network. So these are only just the terms, trust me. But when you will be in the industry, you will not be figure out this is WAN or LAN, what exactly. But yes, in a simple term, suppose uh, you have your own office, and let's say this office is in Mumbai. Okay, so this device, this icon is of a circle with this like 4 lines. So this is a representation of a router. Okay, so this is a representation of router. So why I'm adding a router here in Mumbai? Because maybe I have another router in Chennai. Okay, okay, so why we have two routers? Because when we connect with the different networks, we need a device that is known as router. So what is router? So when you want to connect two different networks, so I'll write here router. So when you want to connect two or more networks, and which are different, right? So when you want to connect two or more different networks, okay, so different networks, then we use this router. So let me take an example. Suppose you are sitting at home, you have a broadband router right now, and router is connected with internet. Okay, so you have your own mobile phone, laptops, okay, which are connected with the router. So these devices or these PCs are connected to internet. So internet is what? Internet is a network of networks. So what is internet? Because a lot many companies and users are connected, that is internet. So internet is nothing but a network of networks, a very big network, which is a combo of small networks, big networks. So you can simply say that internet is a network of networks, right? Yes, it's an interconnection of network, correct? Right. So this device router is helping you out to connect outside your network. So this is the role of router. When you connect with a different network, this is the reason we all have routers at home when we get the broadband connection or any type of connection. Got it? So this is the reason when you have your branch in Mumbai and you have another branch office in Chennai. So if you want to connect both the locations, so you need a hardware device that is known as router. Okay, got it? So router is what? When two or more different networks are connected together, they actually need a device that is router. Okay, got it? So below this network, below this router, okay, so we have a device that is, you can say that simply, that is a device which is a switch. Okay, so switch has a lot of ports, like 4 ports, 8 ports. So it has a ports where we can connect our computers, servers, printers, or any type of network device. And this switch is actually connected with your router. Okay, so this area you can say that this is a LAN network, right? And Chennai also have same type of terminology, that we have a switch, all my computer servers are connected together, and that is also a local area network. And this we can say that this is a wide area network. And now WAN, so this wide area network doesn't mean like we are connecting two locations only, that is WAN. So WAN can be of two types, that is private and one is public. Okay, so public means internet and private means your private connection. So when you are paying, see, it's a very simple thing, just understand. So when you are not getting, or if you don't want to pay a lot, you can just use internet connections. Suppose Mumbai device, just hold on. Yeah. So Mumbai device is connected with internet and Chennai is also connected with the internet, right? So now with the help of internet, you are actually connecting your Mumbai and Chennai. That we can say that this is a VPN. Okay. So when you want to connect Mumbai and Chennai location with internet, because in Mumbai we also have internet, in Chennai we also have internet, right? So when you want to connect to your branch offices headquarters, at that time we can say that we need to create a VPN connection between Mumbai and Chennai. That is your public WAN. So this type of network is known as public WAN, when you are actually using public resources and connecting your locations. Okay, so when we are going to connect with the help of internet, that is known as public WAN. And when we have enough money that we want secure connection, we can use a dedicated line that is known as private WAN. But yes, we don't have enough funds to invest a cable between Mumbai and Chennai. So who is going to make or create a connection for you? ISP. So in both the networks, in private WAN, your ISP will be same for on both the ends. Like in Mumbai, also you are using Airtel, and in Chennai also you have to use Airtel. Then only Airtel can create a virtual connection or a hardware connection, lease line. There are many type of ISP connections available, right? Like MPLS, L2 VPN, L3 VPN. There are a lot of other connectivities. That is too advanced right now for you. So just understand one thing. Like in WAN, we have two type of connections, private and public. So when we connect all our offices with internet, okay, so that is public WAN. And when we connect all our offices with the dedicated line with a high cost cable or leased line, you can say that leased line. Okay. So that type of connection, you can say that private. So private is costly and secure, but so it's a secure connection because nobody is in between the connections. But in public WAN, it's internet. It's not costly. It's a cheap connection, but yet it's not secure. So this is the reason we have to use advanced technologies like VPN, IPsec, or other type of things. So that I'll discuss. Okay, so that is the difference between local area network and wide area network. So local means the network which is behind your router, or you can say that downstream, uh, like all your switches, routers, and all. So this is the LAN network. When you are going from outside your network, that is WAN, wide area network. So you can simply say that. So this is my wide area network. So I'll explain what is a switch. Okay. See, so switch is a device which is used to connect two or more hosts or two or more computers. So what you will do when you have two or more computers, like let's take an example. Suppose we are four guys and we want to play a LAN game. Okay, so we want to play a LAN game like Counter Strike, Call of Duty, and anything, right? We want to play together. What exactly we will do? So either we can create we can connect with the Wi-Fi or something, but or simply we can buy a switch from market which is hardly 10 to $15, right? And we will connect all our devices with this device. This is a switch. But we in market, when we buy switches from Amazon or from any website, it starts from $10, And like we have a very big companies like Cisco, Juniper, HP, Aruba, and lot many big companies. They have $2,000 switches. They have $20,000 switches. But what is the difference between this $10 and $2,000? Basically features. Features. So in a normal $10 switch, when this device uh, wants to communicate with B, the information will pass on to D also, C also. So this happens with the local switches, which are known as unmanageable switches. So unmanageable switches are nothing, just a extension to the devices. Like suppose you have a power surge, right, at your home or at your office, or extension board, what we call. So you have a one power socket. So what you will do when you want to connect multiple devices, you will order a power surge, right? Or a power extension board where you get multiple ports, and you can put your charger, laptop charger, and other things, right? So the same this unmanageable switch is like, this is just an extension so that you can connect multiple devices. But when we talk about manageable devices, manageable switches, so they have a lot of functionalities. Like VLAN is a concept which comes under manageable switch. So all your industry companies or big firms actually uses manageable switches, so that we can create a lot many or we can use a good features in these manageable switches. But in unmanageable switches, we hardly get any feature. Okay. Yes, you can say that it works like a hub, right? But it's not a hub right now, because hub is obsolete technology. Nobody uses hub right now. Okay. So switch is nothing. When we want to connect devices in a company, we use actually manageable switches. And when we just want to play games or just want to use at our home offices or a very small offices, we can use unmanageable switches. So now in switches, we have this term L2 and L3. So what is this L2 and L3 switch? Okay. So L2, L3 switch I'll explain later, because before knowing this, you should know about the OSI model. What is the example of unmanageable switch? I'll show you something. Just hold on. Okay. So I'll show you. See, this is an unmanageable switches. So you can see it hardly costs $10, 15, 20, $17 device, which will help you to connect 4 to 5 machines. So you can see. So it's a 17.99 $18 device, which will help you to connect at least approx 4 to 5 devices. So you can see 5 port. So it means you can plug almost 5 devices in this device, and this is unmanaged. You can see here, unmanaged. So in industry, you can have around 24 port, 8 port, or 48 port also. So you can able to connect 48 devices. So that is unmanageable device. That is very like you can say that cheap or like cost effective. But from industry point of view, this is not acceptable because it doesn't have too many things. Okay. Yeah, but you can see here is managed, but somehow it's a smart managed or partially managed. So it is giving you option of VLAN, but if you go and buy the Cisco switches, which are or HP switches, so they are very costly. So these, even Cisco makes very small devices nowadays. Okay, but this is hardly at $60. But when you go into the industry side, it will cost more, or maybe $1,000, or maybe you can see this. So I'll show you one device that is 3850. So that model is 3850. So Cisco has a device that is also a switch that will cost around 3000 plus, or maybe and maybe this is a new, or you can see the actual price is $14,000. Maybe this is the old one or refurbished one. Okay, so this is the difference between managed and unmanageable. Okay, so I'm giving you some real examples by showing some images and with Amazon. So what's the difference actually? So unmanageable is like very basic functionality just to get the work done. But in manageable switch, we get VLAN features and lot other things. So this is the difference between unmanageable and manageable. Because people actually ask me when they do um, what exactly they ask. They ask, sir, what's the difference between this $10 or $20 switch and yes. So it goes with the router also. So if you have, let me show you. Yeah. So now so let me take a snapshot so that okay. So now router. So router is also like you can say that it's a manageable or unmanageable, but it's better to call this uh, when we have this device at our home. So we actually think that this is a router. Suppose you have a broadband connection, but this is not a router. This is actually a device which is a combo of a router, modem, these type of technologies, and this is what we call ADSL device or DSL device. Okay, so what is ADSL? That is asymmetric digital subscriber line. Suppose you got a connection from AT&T, or maybe you got a connection from Airtel in India. Okay, from any ISP. So the type of device you are looking at right now, maybe that device is not a router. So that is a ADSL because it has a functionality of modem. So why we use modem, by the way? So let me explain you what is modem. So modem is actually doing modulation. So what is modulation? And modem also does the demodulation. And what is this demodulation? So when we get any type of signals, they are coming in the form of analog signals, right? So when the signals are coming to your device and your computer understand which signals, digital signals, right? So we can't send analog signals directly to the system, to the PC. So this is the reason we have or ISP put down one device that is ADSL. So this device is actually converting your analog signals into digital signals and sending those signals in the form of 0 and 1, and computer understand those signals. And the same way it is giving back digital signals, and ADSL is converting these digital signals again back to the analog signal. So this is modem. And this modem is actually integrated into this device ADSL. And now ADSL has one another functionality, router, because this device is actually created for multi-purpose. Router, modem, it has a 3-4 ports outside also, like it has a small switch inside also. And this is a very cheap device which is used by ISP to provide the internet connectivity. Yeah, it goes with the fiber also. Your fiber modems actually converting your light signals, because when you have a fiber or fiber type of modem, the signals are coming in the form of light, right? So that is optical transmission. So when we get any type of communication with in the form of signals, that we call this optical, but your computer does not understand these type of things. So we have to convert this into digital signals or electrical signals. So this is what fiber modem does. So fiber modem is converting your light signals into electrical signals. Got it? Yeah. So Himanshu has a question. Sir, I have a Wi-Fi router. These are not Wi-Fi routers basically. So if ISP has given you something, I'll show you with the example again. Okay, just hold on. Mm, yeah. So again, see, when we buy ADSL, so this type of device is like a router, but it has ADSL functionality also. Like you can see this modem. So this is a Motorola device or with Wi-Fi. Everything is inside, and it has a lot. See, you can see the ports. So it is a switch also, because it has around 4 or 5 ports so that you can connect to your devices. And it has a DSL cable also. This DSL is when we have phone connectivity, from any of the service provider. This all that cable is actually giving you analog signal, and this port is actually converting your analog signals to digital. Okay. So this is ADSL device. Okay, ADSL, DSL. So this is actually a combo of router, modem, and somehow switch also. Okay. And when we get this Wi-Fi router, okay, so these type of devices like Wi-Fi router, and let's check the ports, guys. So you can see here we have only internet cable, but this type of port is not like DSL. So it means when you are putting any connectivity here or any type of connection, so ISP should give an Ethernet link to you. Then only you can use this type of device. So I have explained you what is a router, switch also. Okay. I'll show you something interesting. So that I always show to my students. So just hold on. No, Avinash. So Avinash is asking something that it has 250 computers, like 250 computers. Okay. So all these computers are actually, suppose these are 250 pieces. Okay. So all these PCs have one chip that is known as, all machines, all laptops have one card that is known as NIC card. So that is network interface card. So you can check your laptop right now. You may be having some port where we can put down the cable, or maybe you have wireless, right? Why? Maybe you should have this wireless card. So all these chips are known as NIC. So either we have wired NIC, where we can put down our cable, and we have wireless NIC. So what is this NIC? NIC is a chip or any type of part which is actually helping you to connect your computers with the network. Okay. So you are adding the network cables into the computers, and where we are adding these cables in a small, like this chip is nowadays integrated in the motherboard. So we don't have to add this, but a few years back we need to buy a separate card to install in the PCs. But nowadays it's pre-installed into the motherboard. Okay. Yeah. NIC card is basically your Ethernet port. Yes, when we say we have Ethernet port in our laptop, that actually means it's a NIC. And do you know that your computer does not have any MAC address? Your NIC chips have. It means if my laptop has wired NIC, means and wireless NIC, and a Bluetooth adapter, Bluetooth NIC, Bluetooth means also NIC. So it means if I have three things in my laptop, it means how many MAC address we will have? 3 MAC address. Okay, because this MAC address, when we say MAC address, so this is not an address which we are giving to any computer or machine. This is a hardware address which is actually address of these chips. Either it is a Bluetooth, wireless, or wired. Okay. So if somebody is asking you how many MAC address you have in your laptop, just count the NIC. Okay, so NIC you can count, you can check with the help of which command? ipconfig. Okay, so I'm using MacBook here, so I can. So if you are using Windows, you can type ipconfig right now, and you can see all the details or your yes, your NIC. So I'm in Linux and in MacBook we have if config. Okay, so in if config, so you can see a lot many ports here because some are virtual ports. Okay, virtual means that is created just for the virtual purpose like VMware and all. Okay, so you can see here EN0. So my computer is getting this IP address right now 192.168.1.3. Okay, so you can use ipconfig. Yeah, so I was discussing the question. So we have around 250 computers, remember? Yeah. So when we have all these devices are connected with the device, we call this switch. Okay. All the cables are going inside this device. This is switch. Right. So suppose these type of NIC have a speed. Nowadays we got 1 Gbps, but few old laptops have 100 Mbps. So suppose all the ports. So do you know what is kbps, mbps, and all these things? So just a quick overview. So we have 0 and 1. These are known as bits. Okay. So when we have 8 0 1s, when we count 8 0 or 1s, either it would be 0 or 1, that 8 bits are known as 1 byte. So like 0 1 0 1 1 1 0 0. So what is this? This is 1 byte. Okay. So when we have 8 0 and 1s, computer understand this 1 byte. Okay. And when we have 1024 bytes, when we have combo of, this is a group which is byte. When we have 1024 similar 0 1s, that is known as 1 kilobyte. Okay, obviously then you know KB, and when we have 1024 KB, we say this, what we call this, 1 MB, megabyte. And then we have gigabyte, terabyte, petabyte, hexabyte, exabyte, zettabyte, a lot many bytes. Okay, so you can check this on Google, but yes, you understand this bits. 8 bits is 1 byte, and 102. See, I was taking one interview few years back, and just I asked one person, what is 1 byte? So even that person can't able to give that. So he was saying 8 bits. So I was just asking, what is 8 bits? So that was the actually answer. 0 1s are actually bits, right? So 0 and 1 are bits. So it happens sometimes, you know, but you can't. In interviews, you got blank. Okay. So now if all my devices are 100 Mbps, right? So how much throughput they will get? What is throughput? Means how much data they can send or receive, maximum 100 Mbps. If my computer has 100 Mbps, what is the maximum throughput? Throughput means how much data I can send or receive, that is throughput. So how much data this device maximum send or receive? 100 Mbps, right? That is the same example. Like we have a pipe from where we are transferring water or something, right? So we can, when the pipe is broad, then we can send or transfer a lot of water. But when the pipe is smaller, we can sheer small amount of water, right? So this is what I'm trying to explain. This all your computers are like 100 Mbps. They can only get maximum 100 Mbps, and you got an internet connection of 1 Gbps. Tell me how much maximum speed these computers will get. Tell me. You have 1 Gbps internet connection, but your computers have 100 Mbps. So what would be the maximum speed you will get? Yes, correct. 100 Mbps, right? So that is exactly throughput means. And let's take another example. Let's take another example. When you have 1 Gbps, all your ports have 1 Gbps, but they are using 100 Mbps connection. So what would be the maximum speed these devices will get? Again 100, right? Because you are going to internet, but when they are sending data to each other, they are sending data to each other, or they are sharing data between them, how much data or how much throughput they will get? Yes, 1 Gbps. Correct, correct. Very good.
Hey there. Continue learning directly from industry experts. You are watching these recorded topics from our master's program, but you can watch it live by joining any of these master's program, where you can become an IT engineer that too without coding. Now you can continue.
Cool. Clear? Okay, good. Okay, so explain again. Okay, so explain again. Okay, don't worry. So I was saying, so this is my computer. Okay. Okay, so I'm getting internet connection of 1 Gbps, but I have a chip in my computer which is only supports 100 Mbps. That is, so 100 Mbps, sometimes we call this 100 Mbps fast Ethernet. Okay, so when we use 1 GB or 1 GB connection, so we call this 1 gigabyte or giga Ethernet. Okay. And when we have 10 Mbps speed, which is very obsolete, but we call this Ethernet. Okay, Ethernet. So I'm asking, you have an internet connection of 1 Gbps. You have a device here which is giving you whole 1 Gbps, but your computer supports 100 only. Okay, so you can't have speed more than 100 Mbps. So I'll give you another example. So all devices should have good speed, right? Suppose you have 1 Gbps, okay, and your computer has 1 Gbps, but you have a device which is only supports 300 Mbps. So tell me how much speed you will get. Maximum 300, right? Because between the transmission, if any device have low bandwidth, it means you are going to get the same bandwidth. Okay. You have very good laptop, right? MacBook, and you have 1 Gbps port. You got an internet connection also. Suppose 100 Mbps. Okay. You got an internet connection of 100 Mbps. Okay. So you are paying for 100 Mbps plan. Suppose you are paying $50 or approximately 2000 Indian currency. So you are paying for this internet connection, but you think that you are getting 100 Mbps connectivity. Okay. And when you are watching a video from YouTube, but you are getting a delay, means it keeps on buffering, and you always complain to this local ISP, man, you have given me 100 Mbps, but I'm not able to watch this YouTube in 720 pixels or 1080. Why? Because maybe this local ISP giving you 100 Mbps link here, but maybe they have 100 MB or maybe low bandwidth link over the internet because they are also taking connection from somewhere. So this is the trick actually played by local ISP, right? So they say 1 Gbps, 100 Mbps, but when you actually do the speed test, they go to their server only. I hope I'm trying to explain this. So I'll show you exactly. Okay, I'm going with speed test. Okay, so I'm checking speed test. So by the way, I'm in North India right now in Chandigarh. Okay, so I'll check. This is a small ISP I'm using, Fastway. Okay, so let me check the speed. Go. So it's giving me 70, 80. Even I'm teaching right now with Zoom. So this is the reason it's giving me 80, 90 and all. It means from my ISP is giving me around 90 Mbps and upload speed also 90 to 100 Mbps. Right? Are you getting now? So you always go and check, okay, and they show you the speed test. But exactly it doesn't mean you are actually getting 100 Mbps over the internet. So this is just a marketing gimmick by ISPs. I'm actually opening their secrets. Okay, no issues. So 100 Mbps, here we are getting 90, but again I'm going to speed test, but I'm going to choose another server. Maybe it's in Bangalore or maybe somewhere, or maybe let's check in New York. Let's test any server in New York. So let's test how much speed actually. So you can just check the speed outside India and you will be actually getting that speed only. So you can't go more than that. So let's see. It's going good. Might be my ISP is good, right? But see, if New York is giving me 70, it means my ISP is good. This is how you check your ISP. So just check with another country ISP or any location, and you will find this actually gives me, yes. So mine is better because I have around 3 connections at my home, and I'm using this one because this is the best one. Okay. Now you got the point what I was trying to say. If you are getting low speed over the different servers, it means the bandwidth is choking somewhere. Okay, might be ISP have low bandwidth plan. So this is you guys need to check.
So yes, network devices. So there are multiple types of network devices that you can discuss. So this can be considered as mainly so one is endpoint devices, endpoint devices, and the other one is intermediary devices. So these are the basic two types of devices that we have or that can be considered as network devices. Okay. So when it comes to endpoints, uh, in context to like our form of network, endpoints are basically your end user devices. So this can be your PC, this can be your laptop, can be a tablet or mobile phone, or some of if you are using gaming stuff like gaming console can be considered as a endpoint. Or even like if you have a smart TV or something like that, and if you're connected to Wi-Fi, your television can be considered as a endpoint device. So this but when we are going a bit more deeper, this can be like for networking aspect. If you're going a bit more deeper, we'll consider our PC. A server can be considered as an endpoint device because uh, it's at the end basically. Okay, and all the data that are stored inside that server you'll be using. So just like a PC or something, you can consider the server also as an endpoint device. and what else? Network printers, network cameras, like CCTV, etc. All of these can be considered as an endpoint device. So basically, any device that we actually use directly. Okay, so for example, PC, consider PC. You'll be accessing that PC directly from your end, right? So that is a endpoint device. Camera, it is at the end of that network. To that, nothing else is connected from that particular point. So that can be considered as an endpoint device. Whereas when it goes to intermediary devices, these are basically the types of network devices which help you to connect to another device. Okay, we won't be using this particular device for its requirement. We are using that intermediary devices to connect to our endpoint device. Okay, they just perform, their performance will be dependent upon the connection to that endpoint device. Okay, so for example, if you are using a switch or if you are using a router, etc., we won't be like working on that switch or router. Instead, what we'll be using that switch or router to connect to another computer or connect to another printer or maybe to a camera or something like that. Okay, our requirement, our output, and everything is coming from that endpoint device, and this is just the path through which this data is being sent. Okay, so those kinds of devices are known as intermediary devices. Some of the examples are switches, routers, access points, wireless devices like modem, etc. Yes, hubs also can be considered as a intermediary device. Hubs, bridges, and even firewalls can be considered as a intermediary device, because whenever a connection is coming from outside to your internal network, you have this firewall in between. Even though it's not just used to connect between that two devices, it's used in between to filter the kind of request, which means it is part of the intermediary devices. So these are some of the intermediary devices and some of the endpoint devices. So practically, I think you got an idea about network components. You have endpoint devices, you have intermediary devices, and you also have network cables. So that also you can consider as intermediary devices. Not actually device, but intermediary component. Okay. So let's go. We discussed on network components. Next, yes, routers. So router again is like one of the most important uh, intermediary device that we have. So this router is a crucial network device that operates with the layer 3 network layer. Okay, layer 3 or network layer. So this is part of your OSI model, and its primary function is to forward data packets between multiple networks. So we'll get to that. So before starting that, let's say we discuss a little bit on OSI layer. No, we can discuss OSI layer later. After we discuss switch, we can go to OSI layer. So right now, let's look at a router. Okay. So let me minimize this. So yes, router. Any ideas on what this router actually is?
It's the communication between two networks.
Yes,
So
that's
basically a gateway to the outside internet, I think.
also right, correct.
Just communicate to different network. Maybe I'm correct.
You are right. Yes, correct. So all of you said like different functions of this router, and all of them are absolutely right. Okay. So when you're putting it in a simple words, all you can just say is like one of you said, router is basically a device used to connect to different networks. Okay. So how do we identify these two different? It's basically simple. Each network should be having different sets of IP address. Okay. So for example, imagine that you have a network here. So this is a switch S1, and to that you have a PC, three PCs connected. So it has an IP address of, let's say, 192.168.1.2. Here you have 1.3. Here you have 1.4. Like 192.168 is common. Okay. And 1.2, 1.3, 1.4. And here you have another switch onto which you have again 3 PCs. This has, let's say, 192.168.2.2, 2.3, 2.4. So just by looking at it, you can understand both of them are two different networks. So understanding requirements, you can just mention /24. We'll discuss on what that actually means later. So when /24 comes up to here, you consider as a network ID. Okay, so each IP address and everything has a particular subnet mask. Okay, if I start explaining that right now, it will be a bit confusing. So let's remove something. Just consider this. At the moment, just consider, yeah, that's enough. So this is 1.2, 1.3, 1.4. Here you have 2.2, 2.3, 2.4. Okay, just assume these two are completely different networks. So this is first network, and this is another network. So if we are establishing connection from this switch to this switch, the connection won't establish. The reason is simple, that this is the switch is a L2 device, and this is switch 2 also an L2 device, which is layer 2. Okay, whereas this IP address that you see over here is something that work on L3, that is the network layer. Okay, so switches don't have the option to send an IP address from here to here, since it does not manage or work with IP addresses. It doesn't have the ability to work on that. Whereas we have L3 devices such as routers. So if you are adding a router over here, R1 and R2, what basically happens is this request that is coming from this device to that device goes to the switch forward into this particular router, and router, inside router, it has the ability to manage L3, which is an IP address. It will be able to identify where this packet has to go or where that request has to go and forward it to the correct network or correct destination. So whenever you're dealing with these kinds of IP address and all, switches don't have the ability to manage those IP address. Okay. Hence, when we have multiple networks, it has to use this router to forward that data. At the same time, like if this 1.2 want to communicate with 1.4, you don't need this router. The reason, because when we are trying to connect from this device to this device, it not only uses the IP address, it also uses something else known as MAC address. Okay, somebody's coming up. Yes, correct. You mentioned it right. So it also uses something known as a MAC address. A MAC address is basically the device identification. Like it is a hexadecimal value which is unique for each devices. Okay, so if this device has a MAC ID, it will be unique to that particular ID, and that details will be stored inside this particular switch. And switch has the ability to communicate within a network. Okay, so the difference you can just make note right here itself. Router, it has the ability to communicate between two different networks, whereas switch is used to communicate between devices within a network. So router, two different networks, switch within a network. So that is the main difference that you have to know. If somebody asks you what is the difference between router and a switch, you go ahead and say router works like router helps to communicate within two different networks, and switch helps to communicate within one single network. And router works on layer 3, that is network layer, and switch work on layer 2, that is terminal layer. We will get to what are the different layers after this. We'll discuss a bit on OSI layers as well, though you'll get an idea about what is L2, L3, and etc. are. So this part you got, right? How to work between two different and within a network. Router for two different and switch for, one single network. Okay, so another question. Nahid. Okay, can we say that router is a bridge between two different devices? So that is a good question. The only thing is, don't use the word bridge. Deepak, please mention chat.
Kelvin, one more thing, like in even in layer two, communication between one single network,
Yes.
even layer two uses ARP table of MAC, right?
Uses ARP table. Yes,
Yes,
correct.
ARP table for MAC also, right?
Correct.
When it
In
comes
Switch,
to
we have a table, but it
yes,
won't be able to manage IP addresses over there.
yes,
That's the
yes,
only issue.
that
That's
usually
correct.
comes on ICMP level, like, if I'm not wrong, on layer 3.
Correct. Yes. Okay. Okay. So let's go ahead. So, so what I just mentioned is just the basic function of the router. Okay. So that don't think that is the only function of the router. We have multiple functions over there. So I just joined. I'm from Nepal. Okay, Deepak. That's fine. So yes, coming back. So as I was saying, that's just the basic function of routing. That's not just the only function. So
One doubt, yeah. So regarding that packet, this thing, so it will go through the router or it will directly packet will be
So,
forwarded from the
like
switch.
what I have to tell you is, I didn't hear your question completely. When you just started, it just went off. I couldn't
Oh,
even
okay,
hear.
sorry. So let's say that like a PC has this IP address 192.168.1.1 and it try to send packet to 1.2.
1.2. Okay, which means in between you just
Yes,
have a switch.
which is in the
Correct.
same network.
Okay,
Same
fine.
network. So in this case, the packet will go to the router or within the switch only it will.
It won't have to go to the router. Reason is because when we are trying to connect with inside the same network, inside that particular packet, it has IP address, but at the same time, it also has the source destination of MAC address as well. So when it reaches this particular switch, it won't check the IP address part, but it will check the MAC address part. Okay. And this switch will be having the MAC address of this particular device. Whereas if you want to connect to an external network,
2.1.
yeah, let's 2.1. Consider it's 2.1. MAC address of this device is not available here. Only this switch has that. Hence, it won't be able to forward it. Okay, you got that part?
Yes, yes.
Okay, so within the network, no issues. It will be able to identify. Outside the network, we need router. That's the reason. No worries. We'll do that as a practical also. Okay, great. So everybody is able to hear. So as I was saying, some of the extra functions of routers that we have, that so again, these are the major functions that we have. The first one is packet forwarding. So let me just go ahead for that. Okay, again, we have like few more questions. Like, just give me a second. Monty, okay. Sir, if we open a run command, we type IP address. I'm guessing you're talking about ping. So in that case also, even if we are mentioning just ping, when the packet is being created inside your system, it not only takes the IP address, it also takes the MAC address of your device. Because MAC address you don't have to mention inside the system. Whenever a packet is being created inside your system, it takes something known as the fingerprint of your system, which consists of your MAC address. Hence, you don't have to mention that MAC address. Every packet will be having the source and destination MAC address over there. When it reaches that particular device, because this device will be taking all the required MAC address over there, it has a complete table on that. So you don't have to specifically mention that MAC address. Others KG. So if we use only one router in between two different networks, can they communicate with each other? Yeah, sure. We can use one single router. So I hope you mean something like that. R1. Here you have a switch. Here also you have a switch. 192.168.1.0, which means here you have 1.1, 1.2, etc. And here you can set up 192.168.2.0, that is 2.1, 2.2. I hope this is the setup that you mentioned, the others. If this is what you mentioned, definitely yes, it will be able to work. Because here you have the option to set something up over here. This is your default gateway. We will discuss that during our practicals as well as when we're discussing more into routing. Okay, no worries. So yes, with just using one router, you have the option to set up multiple networks over there. Great questions for the first day. I'm actually impressed. So yes, let's go ahead. And as I was saying, some of the extra functions of the routers. So step first one is packet forwarding. Okay, so packet forwarding, let's say a router basically examines the destination IP address of the incoming data packet and forwards them to the appropriate next hop router for the final destination based on the routing tables and algorithms. So for example, let's say if you have a router here and you have a router here, you have a router here, and here you have a network, let's say 92.168.2.0. Here you have a network 192.168.1.0. And here you have a network 192.168.3.0. So these are your three networks that you have right now. So imagine from this network, I'm sending a package. And inside that, I have a source IP will be this 192.168.1.0 or 1.1.1.1 or something like that. Destination is 192.168.2.3. So that is the destination IP address I mentioned. So once it reaches this router, let's name it R1, R2, R3. When it reaches R1, what it basically does is it go open this packet up and it checks the source IP address, destination IP address. So it finds 192.168.2.3 over there. So it has to decide. So based on that particular IP address, it will be having a routing table in which it will store details. So if I want to send to 192.168.2.0 series, I have to forward it to R2. Similarly, if I want to send to 192.168.3.0, I have to forward it to R3. This kind of a table will be present inside R. So it finds out the destination is 2.3. It goes into the table, find out the 2.0 series, 2.1, 2.2, 2.3, 2.4, etc. I have to forward it to R2. So it just forwards the same to R2. The packet will be forwarded to R2, and R2 is directly connected to that network and it forwards to that particular network. So wherever that PC is, the packet will reach that particular PC. So this method of forwarding the packet from one router to the next router is known as packet forwarding. Okay, so that is one function of our router. Another thing is something, okay, so basic thing, it's known as routing, the name itself. Okay. Thing. So I'll just explain the basic over here. So imagine here, we have a router here. Let's consider it like this. Okay. And I want to send a packet from this router through that router. That let's say R1, 2, R3, R4, R5. If I want to send one packet from R1 to R4, you have two paths right now. I can go through from here to here, then here, then here. That is one option. Or I can send through here. So I have two paths right now. So the process of decision making by R1 to choose whichever route it has to follow. So it can choose this route. It's completely up to the router. It can choose this route as well. So depending upon what kind of protocol that we're using, this router will be making that decision. We have different types of routing protocols, static, dynamic, etc. We'll come to that. So before that, so let's assume this R1 made decision to send the packet to R5 and from there to R4. Okay, so that decision making process is known as routing. Okay, sending or creating a route inside this network to send a data packet. Okay, so that is another function of, let's say, our routers. And there are few other stuff like subnetting, which basically divides one network into two, and network address translation, which basically converts public IP address into private IP address, etc. All these are different topics we'll be discussing later. Okay. So these are some of the major functions of a router. And each router has like a specific set of components within them.